This in between sessions, we can switch off the video camera now, sir. Okay. Okay. Yes, sir. Yes, sir. Okay, sir. Yes, sir. Okay, sir.
Madurai?
Yes, ma'am, Madurai.
Sir, can you share the invitation card for the time meeting is not started till then?
Ma'am, no, just, ma'am, you want to present it now. Now itself, ma'am.
Hi, yes, sir. Just only so anybody joining the meeting, they will see the invitation card.
Oh, okay, ma'am, we will share it now.
Yes, sir.
Thank you, ma'am.
Thank you.
Right, you already log in? Right. Chalo, do it, yeah. Right? Okay. Okay. Manu, good morning. Manu, good morning. Sorry.
Yeah.
मेरा नेट ही नहीं चल रहा है, क्या है?
Good morning, sir.
Suman, morning.
Morning, sir. The Sadhana Divas is there.
Yeah, what? We continue. You start it, and then by the time we can Sadhavan also here.
Morning.
Otherwise, we can have inaugural session, then we can break, sir.
Suman,
Yes, sir.
you have inauguration and other thing continued by pledge in this forum itself. Wherever it's there, you have to do pledge only.
Yes, sir. Yes, sir.
Okay, then again you continue. I feel that will be better. Inauguration, pledge, and this one. You
Yes,
talk
sir.
to
Once
Sandeep.
CST sir joins, we will start.
No, you talk to Sandeep, who is coordinating from headquarters.
Senior IRSTE Chennai, sir.
You talk to him. Or it may be. If it is
Okay, sir.
applicable, just put a word to CST, sir.
Yes, sir.
You plan it, people are waiting, no?
Yes, sir.
रंजीत चाय बोला, चाय बोला।
I request everybody to mute their mics.
साइलेंट नहीं, किसान किधर ऑफ कर रहा है?
Good morning, sir. Sir. Yes, sir. Good morning, sir.
Good morning all.
Morning, sir.
Good morning, sir.
Sir, quantum.
Good morning, sir. Morning.
Good morning all.
Morning, sir.
Sir, we will start the integral session, sir. Then we will break for this Sadbhavana Divas pledge, sir.
I think we can take the Sadbhavana Divas pledge as part of the IRSTE meeting also.
Okay, sir.
That is better. 11 o'clock we will have the pledge
Okay,
along with this.
yes.
Either I will read out or CSC planning will read out. One of us will read out. No issue.
Sir, I will start, sir, now.
Oh, you can start. You can start.
Respected PCST, sir, all HODs, officers from headquarters, division, and all supervisors. Good morning to all of you. IRST, Institute of Railway, Signal and Telecommunication Engineers. India, a technical body, is playing a vital role, disseminating and sharing of technical knowledge among railwaymen regarding design, construction, and maintenance of railway, signal, and telecommunication assets. The institution was formed on 19th April 1972 at Bombay and subsequently registered at Hyderabad in 1976. Under the valuable guidance of PCST, sir, IRST seminar is being organized every month. Last month it was Chennai division. This month other division is happening. Today we have 6 presentations, sir, covering signal and communication subjects. 3 presentations in the morning and 3 presentations in the afternoon. And in this we have 2 presentations from industry also. With this brief introduction, I will request CSC one, sir, to be welcome on this.
So, good morning,
Okay,
all
good
of
morning
you. IRSTE Chennai chapter again is becoming very active. Suman was wanting to reduce it to half a day, which I was not agreeing. Let us have full day seminar on all third Thursday. So now, I am also trying to make people review whatever is the IRSTE seminar data, what was conducted long back, to be available in the website. So we will also try to migrate these data into the internet website so that it will be useful for the railwaymen, retired railwaymen also. Okay, and the prospective railwaymen also. It will also give a lot of people like facility for what is happening in SNT. They can always read out and go through the videos of IRC seminar of Chennai chapter. So I think it should all be done quickly. So we will also have to look forward for themes for the next big IRC seminar to be conducted in October, November. So I was telling Sunil to look for the theme to be suggested by people. The best theme suggestion will be awarded. So whatever is going to be adopted, that theme will be awarded. So today he may make an announcement. Okay, I wish all the best for Madurai division, and then let us do good work. Thank you. Let everybody learn.
Thank you, sir. Now I request CSC, sir, to give welcome address.
Rajshekhar, your mic is muted. Your mic is muted. Unmuted, sir.
Sorry, sir. Sorry, sir. Indeed, a privilege to be part of this session. And IRSTE Chennai chapter has been extremely active. It's acknowledged at the national level also. And I think despite all the situation of the country, our enthusiasm triggered by, of course, PCST continuing with the IRSTE seminars online. And the challenge of involving even the industry, despite all the present situation, continues to be successfully overcome by all the people who are organizing this time. I think Suman and Madurai division should be congratulated on the efforts they put in to get us all together on this IRSTE seminar. It's an important event basically because it's a good opportunity, and now with technology, to disseminate the knowledge of whatever equipments and technology which is coming into SND. And from the list of whatever items are there in today's sessions, some of them are in fact ahead of time, but it's time we stepped into it, like the application of artificial intelligence in SNT by Ram Prasad, who's done some good work. I've been in touch with him and Harsimran Singh. There's a lot of promise in it. It possibly opens out avenues which we really never imagined are possible. So now it looks possible, and thanks to the initiative of these youngsters, it's doable right now. And possibly shortly, in a couple of months, we should be in a position to get something tangible out of their initiative to bring in artificial intelligence into maintenance. I think very interesting topic. Lightning and surge protection is a never-ending challenge for us. So we have Manu Mukundan, who's going to be talking on that, which is a critical aspect of signaling and signaling performance. And reliability, another interesting thing which has happened, a recent trend in IRST is that we have people doing excellent work within ourselves, and they do it there quietly in their place of work, and it gets restricted to their place of work. So we've been in a position to possibly bring them onto this platform, get them to share the expertise. Some people have done excellent work, and every such person is being given this opportunity, and I'm happy this tradition has been introduced and it's continuing. So reliability of improvements of telecom circuits by effective utilization of SDH by Murli Krishna. SDH is an equipment where, in fact, I think Southern Railway is amongst the earliest railways to decide on going in for STM 4/16 in its network. Normally, STM1 was what people were looking at, but we were progressive, and when we saw this large-scale replacement activity being taken, we took the initiative of going ahead of time. So we're getting STM 4/16 installed across the entire Southern Railway, and I think whatever important sections are there, significant amount has already been covered, and the balance will get covered. So this is one area where some good work is being done, and I think that's another presentation which really we can look forward to. And of course, we have the axle counting systems of Siemens ACM 200. Now, this is industry's participation. Mr. Sri Krishnakant, product manager, Siemens. So that is another area which we are looking forward to, because MSDAC is the future of all axle counting systems and critical for railway signaling. Coming down to the EI, there was a very important and pioneering effort which was done. Madurai division was the first to basically carry out the modifications to EI departmentally, and Gopal Krishnan, signals, Dindigal will be making his presentation on self-reliance on electronic, which is a significant and pioneering step. I think this was something which we wanted to. It gives us the confidence that we slowly started getting into areas which are important, and it requires a level of mastery to approach it with confidence and successfully do it. Then data loggers is another equipment which I feel are grossly underutilized in terms of the potential versus the utilization. The utilization is fairly limited. I think Suresh Kannan has apparently done excellent work in fault analysis and failure prediction. So this is another interesting presentation we have. So I wish the organizers all the very best to keep this IRST flag flying high, continue the efforts being made, whatever be the situation, and continue involving our staff who are doing excellent work on the ground, so that all of us and who are both witnessing can also adopt some of the expertise which is being developed locally. So we can it over the entire Southern Railway. I should thank the organizers for giving me this opportunity. I think the sessions should start. Thank you, Suman, and wish you and your team all the very best for this session. Successful conduct. Thank you.
Thank you, sir, for your valuable guidance. Now, another 10 minutes is there, sir, for this Bhagwan Divas pledge. Shall we wait, sir? Around 11 o'clock, we have to take pledge, sir.
I think possibly if Mr. Madhusudan is there, then we can ask him to speak.
Madhusudan can address. Why not Madhusudan address?
So it's unscheduled and maybe unfair involving suddenly.
No, orders, it doesn't matter. So we'll have to pass time up to 11 o'clock in addressing. Then after pledge, we can start. Madhusudan Salvadrai.
I'll call, sir.
Murali Krishna is there. Murali Krishna can address.
One second, sir. Hello?
Murali can address. We'll have to have some more time. We are having another 10 minutes. So
Okay,
you will
sir.
address the gathering.
Respected PCSC sir, CSC sir, senior colleagues and other officers of today's IRSTE Chennai chapter webinar. I think after PCSC sir has taken over, we have been doing these webinars online for a full day session. I think this is a third such session. I mean, which we have been doing continuously from June onwards. In fact, in June, workshop has started it. After that, last month, Chennai division has started. Now, Madurai division is doing it. In fact, Southern Railway has been pioneering on a lot of innovations. In the recent times, if you see, a lot of innovations are being done. Trivandrum division, lot of new things are being introduced, and workshop also, thanks to PCST sir, with the support, we were able to do a lot of innovations in the recent times. And the best part about Madurai division has been recently they have introduced, done a modification in the Meda electronic interlocking. I think which we can say first of its kind. In fact, about 6 months back, Palghat division had done, sir. I think some LC gate removal or something they have done in West Race, I think. I think after that, now Suman and his team has done in Madurai division. I think it's a good trend. Our people are doing it. In fact, they should help us in making us independent and self-reliant in handling the modern technology. Because if you are not going to do these things in-house, definitely the OEMs will take us for a ride. So we should break ourselves from these people. 1 second, sir.
So commercial break. What I will do is around 11 o'clock I will break. You
Sorry,
can
sir,
continue with the program. I will
think
break for.
our people are also calling. Actually, we will break at 11 o'clock, sir. Then
We will break at 11 o'clock to join GM's program. SNT, other people, whoever is not joining can take the pledge. I think one HOD. Sandeep is there?
Sandeep is down. Sandeep is there.
Or Suman himself can read out the pledge. Suman himself can read out the pledge. Sandeep is there.
Yes,
am I video audible?
Right.
The chat box we have provided, sir. Chat.
Okay.
Is it audible?
I think whoever is having that, one person will have to have the nomination of one person who will read out. Other people can repeat it. Who will read out? Sandeep will read out.
Sandeep.
Sir, my voice is audible, sir.
It is audible.
Audible.
Okay, okay, right.
Audible or horrible, we don't know. It is horrible.
Because I am testing with some other speaker.
No, let us look at. Normally, sir, you are having the this one pledge.
Yeah,
Pledge.
in my office I am having. In my office I am having, sir.
Right, you take. Oh, you will go to the office and do.
No, I'm in office, sir. My people are waiting. Let
Right.
Sandeep take here.
Okay.
Already I kept it in the chat box, sir. People can.
No, if Sandeep's voice is bad, is not good. Then
I'll put the headphones, sir. Otherwise.
right, you put the headphone. Okay, right. Okay. Continue.
Yes, sir. Sorry for break.
Hello, sir.
Even in IRSTE also, break.
Is it clear, sir?
Very details we have
Very
break,
clear.
sir.
Now it's clear, no?
The trend. Sandeep, can you switch to mute the mic?
Yeah.
See, Chennai chapter, as it was said in many forums, IRSTE Chennai chapter is the most active forum on Indian Railways, and we are continuing that trend. And in fact, earlier we used to have afternoon session 3:30 to 5:30, but now after Bhaskaran sir taking over as PCST, we are having full day sessions of. And most of the papers are in-house, and it is good to see that senior supervisors are coming forward and sharing their knowledge with all of us. It's a good trend which we have started, and I think we should take it forward and make it more and more active. And as PCST sir has already announced in the last international IRST seminar, we are going to have again another mega event in November, where we are going to bring in some more innovations which are under development. Hopefully, we should be able to catch up with the SARS speed of innovations. I think we will definitely will do well, sir. Southern Railway is poised to achieve bigger things, and in spite of the pandemic situation, we have been able to achieve a lot of things, be it Jolarpet or Maniachi. And recently, Palghat has eliminated, interlocked all the LC gates. I think next division which is going to achieve that feat must be Salem division, as PCST sir has announced in the last VC. I think with you, sir, with all the support, I think SNT Southern Railway will do wonders, and we will take the SNT organization to newer heights. And I welcome all the participants to today's RST webinar, and wish all the speakers all the best for sharing your knowledge with all of us. And thank you very much. Thank you, sir.
All the best. I'll break actually. I'll break. Sandeep can continue.
Sir, I'll also take break, sir. Even I have to take the pledge in the workshop, sir. I'll just wait for 5 minutes and I'll come back, sir.
Right, sir.
All right, Sandeep. Now your voice is very clear.
Right, sir.
You can continue with the pledge. You can lead the pledge team.
Yes, sir. I'll lead the pledge, so all can take together.
One suggestion, sir. This pledge can be shared in that this one so that everybody can read.
It is already shared in the chat box. Chat box is one of those options at the bottom of your screen when you run your mouse. So I think it's already shared in the chat box.
Thank you, sir.
So in fact, Sandeep has put it up on screen also. That's good, I think.
Is it visible now?
Sandeep, I think it's visible. Sandeep, it's visible. It's good.
Right, sir. Hello.
I think Sandeep, it's time you can start.
So bell will ring, sir. Another some time is there. Another one. I think already time is there, but we are not able to hear. So we'll start, sir.
Yes, sir.
Permission. Right, sir. I take this solemn pledge that I will
take
work.
the solemn pledge
That I will work for the
that I
emotional
will
oneness.
That I will work for the emotional oneness
And harmony of all the people.
Harmony of
all the people
Of India, regardless of caste, region,
of India,
religion,
regardless of
or language.
religion,
religion or language.
I further pledge that I shall resolve all differences among us.
I further pledge that I shall resolve all differences among us
Through dialogue and constitutional means without resorting to violence.
through dialogue
and constitutional means
without
into violence.
Thereby we end the pledge. Thank you very much, all of you.
Thank you, sir.
Thank you. So Suman, what is your plan of action now?
Sir, CS sir said we can go ahead, sir.
So you want to start the sessions immediately, or you want to take a break and then start?
As sir says, we can start, sir.
Okay, then let's start. In fact, yeah, okay, let's start. No problem.
Now we will move to session 1, sir. Here we are having 3 presentations. Sir. First presentation is by our DST, Sir Ram Prasad. It's an application of artificial intelligence in SND. Now I request Ram Prasad to start his presentation.
Respected PCST sir, CST project sir, CSC 1 and 2 sir, CST PNP sir, CCE sir, CWM sir, and my beloved senior DSTs, deputy CSTs, and my dear colleagues. The topic which we are going to discuss today is application of artificial intelligence in signal and telecommunication. Artificial intelligence is an emerging field. It has found wide variety of applications in many real world applications. In SNT, signal and telecommunication, it is a new entrant, but it has a wide promising features and promising applications which can ensure safe and punctual running of our trains. So now with this, we'll go into this presentation. So the term is Railway Revolution 4.0, which means we have undergone 3 revolutions. Our S&T department has undergone 3 revolutions in the past, which I consider as when we moved from electromechanical signaling to relay-based, we did a revolution, and from relay to electronic interlocking, solid-state interlocking, we made another revolution. Now this is the 4th revolution, which will be based on this artificial intelligence, which will make our systems, signaling systems and telecommunication systems smart in their own way, so that it can make decision, it will have decisioning capability and help us run an effective train running, will help us in effective train running. So for this, we'll be needing 2 components. That first one is Internet of Things, IoT. Internet of Things is nothing but interconnected sensors that we place that transmit the data to a hub. For example, we can place the sensors over the track points. Wherever we require the data, we can place the sensors and it can transmit the data to a central hub. And with that data, then we have to utilize the artificial intelligence. Artificial intelligence is nothing but enabling the decision-making capability of a computer. We humans can make decisions. We are good at decisions, whereas computers are not good at decision-making. So using the data which we collect from the field, using the sensors, we can program the computers to make an intelligent decision. And once with these decisions, we can make a new revolution, which makes that revolution will be our smart signaling telecommunication gear. So that is the agenda of introducing this artificial intelligence in our S&T. So now a brief history about artificial intelligence, how it all started. So let us assume a case that I'm playing a chess with a computer, like as shown in the image. I'm playing a chess with a robot. So what I'll do is I'm moving my bishop. Assume I'm moving my bishop. What I will think is I'll just see the pieces on the chessboard and I'll make a decision. But what the computer will decide is it will not see only what I'm moving and what is the position of the pieces. It will think about all the past best moves for this particular move done by various chess experts, like it can be Bobby Fischer's move or Kasparov's move or Vishwanath Anand's move. It will analyze all their moves and then it will make a decision. So what the machine does is it learns from the past experience. With the past experience or past data which it has, it makes a good decision. So obviously a machine can defeat a human person. So mainly this artificial intelligence started with this checkers. They call it checkers as a Chinese game, and similarly chess, equivalent of chess. So with that, this artificial intelligence started developing, and mostly it was in the 1960s era. In Dartmouth, a symposium was conducted in Dartmouth, and those people who attended the symposium, they became the pioneers of artificial intelligence. And now it is a very emerging field, and by 2050 or 40, we will be merging our brain with the computer. That is the aim of this artificial intelligence people. But now it is in a very good emerging state, and a lot of application has been developed into it. Now, machine learning, though the heading is artificial intelligence, mainly will be concentrating on machine learning. So how machine learning is different from artificial intelligence? You can consider, as I said, artificial intelligence is a superset, and machine learning is a subset of artificial intelligence. So artificial intelligence involves, like, it has to sense the data, it has to decide, and it has to act upon it. So it has to sense the data from the field, okay, some voltage or current from our point, it has to make a decision, and it has to do some corrective action. So this machine learning is a part which will work on the decision making capability. It will help the computer program on its own without explicitly doing. Like, no need for us to explicitly do. For example, we are taught in the childhood 2 into 2 is 4, 2 into 2 is 6. We are taught in the childhood. But we have that each and every time we go to 7th standard, 8th standard, we are not being taught things again and again. So once the primordial piece is taught to the machine, it should learn on its own. Each and every time I should not explicitly program the computer. So that kind of program is called machine learning. That is, the machine should learn on itself and act upon itself. So that is the concept of machine learning, and the project which we have done in Mother Division is for this machine learning. And now let us have an interesting thing about machines. So, for example, assume someone is asking a question like, what is this 6-digit number multiplied by another 6-digit number? What we would do is, it will be very difficult for us to, a normal human being, to say, like, okay, what is the number? Whereas if you take a robot, you can say it instantaneously within a fraction of a second. We, unless otherwise with the use of calculator or even with a hand multiplication, it may take time for us to identify what is the value of it. Whereas machine can do it in a fraction of a second. So this is the capability. The machines are good at doing this mind numbing arithmetic. Now, for example, if I giving other tasks to machine, I'm saying, okay, these are 2 images. Can you tell me which is a cupcake and which is an animal? But machine cannot tell immediately. Whereas we human, by just seeing, we can say, okay, A is a cupcake and B is an animal. Whereas for machines, it is very difficult. So this differentiates humans and machines. Humans are good at making decisions by seeing things based on our past data. We are good at doing. Whereas machines are not easily. They don't have that kind of ability to do. They can process. They can multiply 10-digit number and decimal point, floating point. Whereas a small decision making between A and B, they are not able to do. So this is what machines are being trained at. They have to make a decision, concrete decision. I'll give an interesting example. Like you could have seen in many when you're logging into some site, it will show whether it's a human or animal. It can do captcha. It will show some set of images where some will be cars will be there, some will be. So people ask us to identify the bus. So what we exactly are doing is we're teaching the machine. We are correctly, we can easily predict which is a bus or which is a car. We can say by that image. Whereas machine can't say. So the machine will learn in the backdrop. The program will be such that when I choose a car, the machine will learn it is a car. So over a number of iterations, many number of people will teaching. After teaching it, the machine will learn that okay, it is a car and it is a bus kind of thing. Similarly, we can take our childhood experience also. So, for example, the same thing. So, I show these two images to a child, which is of 1 or 2 years. It cannot identify what is first of all, it will not what is a cupcake or what is the animal. So, after training it also, it will take time for a child to learn which is the or separate which is a cupcake or an animal. So, the mission is like a child. So, we are taught from childhood. As an adult, we are able to say this is a cupcake and an animal. Whereas for the machine, which has not learned, which has started from the very lower stage, they should learn slowly like a child. Over the years, they will learn and they will be able to identify which is a cupcake and which is an animal. So machines are not good at it, whereas humans are good at it. So we are teaching the machines to be good at decision making. So now, how do machines learn? This is more of a theoretical thing, but I'll just give a brief introduction. Generally, machine learning is segregated into supervised learning and unsupervised learning. Supervised learning, as the name implies, there will be a teacher and a student. So a teacher will teach the student, okay, this is the multiplication table, 5 into 2 is 10, 5 into 3 is 15. So slowly we'll learn. 5 into 3 is 15. So we'll ask the machine to tell what is 5 into 4. So slowly we are teaching the machine to learn. That is supervised learning. And next is unsupervised learning. The name itself suggests, like Ekaliva, we say the machine, okay, you learn on yourself. I'll just give a bunch of data, you learn on yourself. I'll not teach properly. You have to learn with the basic knowledge which you have. You have to make an idea of it. So that is unsupervised learning. Now, in supervised learning, we have 3 different types: linear regression, logistic regression, and neural network. Linear regression, in detail, we'll discuss each and every topic. But linear regression is nothing but just predicting an analog value. For example, my voltage, local EB voltages. For example, last week it was on 220, and what will be the value after 2 weeks? I want to predict the value based on the past trend. So linear regression can help me predict a concrete analog value. And whereas next logistic regression is true or false, yes or no kind of thing. And this logistic regression will have wide applications in our criminal telecommunication, because mostly we are into predicting whether it is going to be a failure, whether the system is going to fail, or it is prone to failure, or what is the probability of its failure. This logistic regression model will give an idea about all these things. Next is neural network. Neural network is a very interesting topic. It was developed in 70s and 80s. Suggests neural network is just mimicking our human brain. Our human brain works. We all know that neurons are the basic part of our human brain. So neurons, they work, they can interconnected neurons are there. They will start firing, they will communicate among themselves. So the same pattern, scientists try to make it as a program and make the machines learn. This field was started in 70s and 80s, but there was a lag in the field. Now again, it is gaining emergence. I'll give an interesting case to this, how our brain works. Our brain is not like this particular part of brain will only do the job of eye, or this particular part of brain will only do the job of ear, or only the mouth. It is not like that. It is like a panel, like where we can change things. It is not like this particular part will only do this. What scientists did was they were able to rewire the connection. Earlier, the part of brain which was doing the function of eye was programmed to do the function of ear. It didn't learn instantaneously. The first day I just reverse plug it, it didn't start. It started learning. So it started learning the ear input. It learned it, and then slowly it adapted to it. So our human brains are capable of such a thing that it is not like a domino panel where we keep each and every dominoes are there in our brain. Each domino is not fixed to one particular function. After some time, brain can do the role. A particular part of brain can do the role of ear, or it can do the role of eye. So it was tried in most. So the same kind of logic we are implementing in our algorithm also. Next is clustering. As I said, this unsupervised learning, it has a type of clustering. Clustering is, as we know, group. For example, I want to cluster the group of class students based on their height. So I just cluster. So that is the kind of cluster. So machine can do that thing without any teaching. There's a particular algorithm which has the ability to do it. K-means clustering is what we'll discuss in detail. So these are the general learning models of machine learning. So now let us have an idea about this prediction and intuition, three different logistic regression, linear regression of effect. For example, one of my friends comes to me and asks that, brother, I want to purchase a house in Chennai, Anna Nagar, which should contain a square feet of 2,250 square feet. So what could be the value? So a normal person, what he would do is he will just see what is the past trend. He will think, okay, near this house, somehow someone would have bought a house for a particular rate, and he would suggest that rate to him. But what a data scientist will do is he will take the data for the past 1 year or 2 years of the rate of the houses that has been sold in Chennai Anna Nagar, and he will feed it to the machine. So you can see from the graph here that it is seen this data points are the corresponding square feet and their rate. For example, a house of 1,200 square feet must cost 50 lakhs, the access in crore, and another 1,500 square feet may cost 75 lakhs kind of thing. So it will try to plot the data and it will try to fit a straight line to it. It is not only a straight line. Based on the equations, we can have a curve also. So it will try to, the algorithm will try to fit a best possible curve, and it will try to predict. So now once it has fitted a straight line which is approximating this points, sequence of these points, when it comes to 2250, then it is predicting that if we purchase the house for 2250, the value will be around 1.2 crores actually. So that is what the algorithm has predicted. So what the algorithm does is, based on the past data, it has predicted what could be the purchase of the house. This is a generic case. So let us now consider a case of a signal and telecommunication. For example, we know that our local EV voltages may fluctuate, and the fluctuation may be during the daytime. Morning times the fluctuations will be there. It may vary from station to station based on the local EV source. It may fluctuate in the daytime, afternoon time, or in the night time. So what we can do is, based on the fluctuating trend for the past 6 months, okay, morning time the EV voltage is becoming so low. So with that, we can predict what could be the value next week at this time, in particular time, at particular instant in the morning. So after knowing that, what we can do is we can identify this is a particular voltage that is going to come, and we can take corrective action. Similarly, when the voltage is going to exceed, it is going to be around 260 or 270 volt, we can predict. So this high voltage applications, where we can want to predict analog voltages, we can do. A similar application would be lightning also. It will be seasonal. It will not be based on daytime. It will be seasonal. Maybe last monsoon season we had surges, more number of surges in this particular station. Then the same data we can take for some few years, 2-3 years, the seasonal monsoon pattern of surges we can take, and we can give it to the machine, and the machine can predict. Machine can predict that what is the surge voltage that will be developed over the next season, next monsoon. What will be the surge value, protection value that will be developed. So this is also an application for this logistic regression. Linear regression will predict the analog value that is going to come, which has wide avenues in our SNT. And next will be our logistic regression. So that this logistic regression also has a huge potential, because it is going to say ones and zeros, like yes, failure or not failure, or what is the probability of failure. This is what we need for our signaling system equipment. So now I have considered a case like, for example, a technician says that during normal running, there is a difference between normal running current and obstruction current of my point machine only 0.85 amps. So what could be the chance, or what is the probability of its failure? So then in that case, we can make use of a logistic regression. For that particular point machine, we can take the difference between normal operating current and obstruction current. We can plot it. So we can see in this graph, the x-axis is the current and y-axis is the probability. It is labeled as 0 to 1. So we can multiply into 100 to get a probability. So we can see, as I have marked the current, it is trying to fit a S-shaped curve. Whereas in the earlier case, it tried to fit a linear straight line curve. Here, for predicting zeros and ones, there is a logistic regression. As the equation has been given above. This curve is according to this equation. And moreover, this machine learning is pure mathematical. Mathematics is a fundamental key for machine learning. So what machine learning is, to plot this curve, and it helps us in giving an idea. For example, you can see the currents which are less than 0.5 amps. If I take this threshold as 0.5 amps, which are having less than 0.5 amps, the point machine is prone to failure. It is going to fail. So it needs immediate attention. And for example, if it is more than 1.5 amps, if the difference between obstruction current and normal running current is more than 1.5 amps, then I can say my machine is in good condition and we can do normal maintenance. So now this particular technician has told me that it is 0.85 amps. So if it's 0.85 amps, I'm seeing this 0.85 amps, I'm directly looking at the plot what is the value is going to come. It's coming as 0.18, which means 0.18 is the possibility that it is going to be good, which means 82% chances are that this particular point machine will fail. So such kind of intuition we can come. This is only for point machine we can do for track, signals, all this logistic regression will be very helpful. Even in this particular application, a case study has been done in Madura division, for that logistic regression has been used. So which will be discussed in detail. And next is clustering. Clustering, as I said, you can see the school child. She has given some data to someone. A data scientist should have given and asked her. She will not tell what's the data she has given. She'll just give some data and the algorithm will throw some output. So it could be something like assume like it is the height and weight of the students in the class. Y-axis can be the height and x-axis can be the weight. So this cluster, blue cluster shows that people are overweight but they are short. Whereas this cluster shows that people are tall but they are having normal weight. And this cluster shows that people are having their required height and the required weight. So algorithm, without knowing it is a height data or it is a weight data, it is segregating it. So no need to tell it is a height, it is a weight to make a decision. Like earlier case I told it is a current and tell me it is a failure or a not failure. So, but not required. Similarly, we can use this application or SNT for clustering some voltage data. I'm having some voltage. I want to cluster into low voltage, normal voltage, and high voltage. So that I can cluster. For example, it will group the clusters from 160 to 180, it is considering as a low voltage, or 190 is considering, so 200 to 230 is considering as a normal voltage, and 230 to 240 is considering as a high voltage. So I just give a data of 6 months from the data logger to the algorithm. We'll just segregate the data into 3 groups: low voltage, high voltage, and normal voltage. So normal voltage, it that system is working properly. Low voltage and high voltage we can take and we can analyze. Next, after that we can make further analysis. What is the problem? Why it is becoming low voltage? At what point of time? Is there a problem in the cable or problem in the source transformer? So we can make further analysis. This clustering will give an initial idea. That is that which is it that there is something wrong in your circuit. There is two groups existing. Everything is normal. Everything should be uniform. If there is an abnormality, this clustering will help us in identifying there are two clusters of data. One is right and one is wrong. So what we do is we have to take which is wrong and analyze in detail. Now a case study which we have done in Madura division by applying this machine learning technique for failure prediction. So the hypothesis what Madura division we are proposing is the relay high contact resistance is proportional to the time taken by the final relay of the circuit to pick up after the root initiation. So this hypothesis and this case study is for finding out high contact resistance failures in our circuit well in advance. And so the hypothesis, what it means is, for example, there is a high contact resistance due to some clip or in the contact, a contact resistance has developed. And then any particular relay can be any relay in the HR circuit. So due to that, there will be slow pickup of the relay. We would have already observed that the sluggish pickup of relay is also possible. So what I am doing is we are taking the difference between the time instant when LR is picked up till HR is picking up for the particular route. When route is initiated till HR is picked up, the time difference I'm taking, which I'm proportionating or equating it to high contact resistance. If there is a high contact resistance, this pickup time will increase. This is my hypothesis. And we have made an experiment at a particular station and data have proven that there is a chance that high contact resistance, if it is developed, then relay will pick up slow. And this slow is not like we can observe easily, not by human mind or human eye can't observe it. Whereas we can take the data, it will be in milliseconds only. But that milliseconds will be very helpful to us. So now this is the hypothesis that has been proved, and based on it, an experiment was conducted at Silaiman station on 5/6/2020. That in a particular HR circuit. And one more thing I have to add is that since it is an experimental trial, what we have done is we have removed all the external variabilities that we know that, for example, if I initiate a route until HR pickups, there can be many possibilities that points may not be in a set condition, points may be in a different condition, LC gate might be involved, lot of externalities are involved. But what I am assuming for this experiment, in an experimental basis, what we have assumed is everything is in favorable position for us. That points are set in favorable, LC gates are involved, LC gates are involved, it is locked, all are favorable. So when I initiate, it will just take till the time HR picks up. So the data for the simplicity of operation, we have taken this kind of data, and you can see that and resistance was introduced in the circuit to have a sequence of data. So for the machines to learn. So resistance was introduced in the circuit through a potentiometer. So that slowly when I increase the resistance, what is the change that is happening? Because if I directly put a high contact resistance or a failed relay to the circuit, it will have very high contact resistance and I cannot predict failure in advance. So there is a difference. For predicting, we need to know, though the system has not failed in real time, we must have an idea that it may fail. There is no use in predicting a failure after the system has failed. So to do well in advance, an experimental basis, resistance potentiometer was introduced in the circuit, and slowly resistance was increased, and the pickup time, the difference in pickup time from LR to HR was monitored, and it is seen that when I'm increasing the resistance, there is a pickup time. This axis in milliseconds, y-axis is in milliseconds, so maximum it is going up to 4,000 milliseconds. That is 4 seconds it is taking when I increase the resistance. So this proves that there is a definite increase in pickup time when I increase the resistance. So based on this hypothesis and the data which I have taken from the station, now I am trying to apply this machine learning algorithm so that what is the intuition I can get, what are the predictions I can make in it. So first of it, the basic what I want to do is clustering. Before going to any high model, what I can do is cluster. I want to know whether there is a problem in my data or not. So as you can see, the clusters, there are two kinds of clusters. One is red color one and one is blue color one. As I said, this algorithm is called K-means clustering algorithm. It is a very simple algorithm, very easy to understand, basic mathematics only. Though like this algorithm is very basic, but it has a very immense potential to cluster the data. So it has clustered the data into two groups. So by seeing it, I can say that, okay, on this x-axis is in time and y-axis is just for a reference. It has no meaning in the y-axis. X-axis is just the time in milliseconds. Now I can make an inference that there are two groups of data, that is red and blue, which means two sets are there, and it does not know which data. It does not know it is a time data or a high contact. No, it has no idea. Just say two groups are there. So once I have an idea, okay, then there is some difference or there is a problem in my circuit. So with this, can I make any prediction? So that is what this question is. So after applying this K-means algorithm to the data, this is the output I have got. With this output, now I'm going to use logistic regression to make some prediction. So now this is the prediction model, and the program was done in MATLAB, Matrix Laboratory 2014 version, and a data set of data were taken. You can see first this data spreadsheet is the test data. Now there's an interesting thing called training and test. So we are trained in the class. As the same thing to machine also, it applies to us also. They are trained in the class. We are given some questions to learn in the class. A mathematical problem is given the class to train us, and the same problem is not asked. We are asked a different problem in the test, and just we are being evaluated based on that. If I'm giving 2 into 2 is 4 in this training session, I'm asking what is 2 into 5. So if I have to predict, so like the same way, out of the total data what I have taken, 70% of the data I have taken to train the machine. Machine needs data to be trained. So the 70% of the data is used for training the machine. Remaining 30% of the data is used for testing, whether the machine has learned properly or not, to test its capability. Now, if you see this first data spreadsheet, you can see this axis 2938. It is just the time in milliseconds 4038. And you can see interesting thing is next to it, a variable has been marked 1 or 0. If 1 or 0 is nothing but failure or not a failure. So as I said, machines needs to be taught. Even a child has to be taught. Similarly, machines need to be taught. So for teaching the machine, I'm saying if the pickup time is 2.9 seconds, it is definitely a failure. And if it is 4 seconds, that is time difference between LR to HR pickup, it is taking 4 seconds and circuit is going to fail. And if it is 1172, that is 1.1 seconds, then it is not a failure. But if it is 1.359, it is a failure. And interesting thing is, in the site 1359, that is 1.3 seconds, would not cause failure. Definitely it will not cause a failure. Circuit will operate normally, relay will pick up, there won't be any sluggish pickup. But in order to predict well in advance, we need to give this guy. So you can see this normal operation, 1172 will be repeating many times in the data. So this shows that 1172 is the normal operating time for the particular relay. 1172 milliseconds is the time for that particular LR to HR distance pickup. It is repeating, even if it is a normal condition. And if there is more to it, which means I have added a resistance to the circuit. So once I added a resistance to the circuit, it is causing failure. So in order to predict the failure well in advance, I am marking even 1, 2, 3, 4. That is the 1, 2, 3, 4, 1, 2, 3, 5. That is 1.235 seconds as a failure case, so that I can have well in advance that my circuit is going to fail. And one more thing is, you can see the data is in jumbled position. What I have done is, we have just randomly, out of 100%, 70% has been taken randomly out of permutation. Remaining 30% has been taken out of permutation for testing. So that if I give a constant data, this is a 100 numbers, I'm not changing the order and I'm giving it to you. machine will not adapt. So machine should adapt because this is like a black box. Anyone should be able to do it. I have to give the set of data, the algorithm should tell the output. So I have made the machine to learn in a random way, so that every time I used to randomly change the 70% of data and test data also will change. So that is why data is random. But when the experiment was done, it was linearly increased. The resistance was linearly increased. The time to pick up was linearly increasing. So 1172 was the normal time for increasing, and slowly when I increase the time, the resistance in the circuit increased and the pickup time also increased. So to predict failure well in advance, I've given 1, 2, 3, 5, even 1, 2, 3, 5 seconds of a failure case. But I can predict before the circuit has failed in action. I can predict. I can take any corrective action. So this is the algorithm, a matrix laboratory, and this algorithm, no need to go in depth into the algorithm. It is just a computer application, very basic mathematics. But still, wide applications can be used without having an idea about the algorithm. It can be considered as a black box. Just your input can be given and few parameters which will be explained in the next slide. So once this data is given to the algorithm, it will provide us two parameters. Though these numbers look simple, 6.4835, 24.5609, these numbers are really valuable. These numbers are the output of the computer. The doubts may arise how these numbers can help in predicting, but as I said, this machine learning is purely mathematical. When these are just a constant in an equation, what algorithm is giving is just a constant in an equation. Once I apply this constant to that equation, the equation will have an output 1 plus 0. That is, it will give a probability. So these numbers also matter. Now next is results. What is the prediction result that you have got? As I said earlier, it was 70% of the data was given as a training, and out of this 30% of the data I have taken as the testing. So which means I know what is the output. If it is 1.578, which means it is a failure. If it is 1172, I know it is a 0. But this I'm not giving to the computer, whether it is a failure or problem is not there, that I'm not giving to machine. Whereas I'm giving only the time to the machine, so that machine should predict. But I will have an idea whether it's failure or not a failure. So I must know the efficacy of the machine. Like a student has to test him in the examination, the machine also must be tested. So I'll just give this time to the machine and check its output. Now, as I said, we can consider this algorithm as a black box. This algorithm can be considered as a black box, and you can see which I have marked in red column, two parameters, iteration and learning rate. Iterations is nothing but it is not like we learn something instantaneously. We have to read once, twice, thrice. Slowly we'll learn. So 10 times if you read something, we'll learn. Like that, machines also needs to learn. This iteration helps the machine. So 10,000 times I made the machine to learn. First time the machine may not learn properly. It may not able to tell the 4 seconds is a failure. It will tell wrongly only. The second time it will adapt. Third time it will adapt. Over 10,000 times it would have adapted, and it will give us an output. And this learning rate is an important parameter. It is just like a boost, a motivation to the student. Okay, you're doing well, you're doing good. Or it's kind of a penalty also. That's a kind of penalty also in this algorithm, which I have not included, but we can put penalty. If he is not learning properly, he can be punished. He can be given some penalty. So such kind of parameters is this learning rate. So with a learning rate of 0.1, it will be less than 1. We can less than 1. This point learning rate and iteration are the parameters which an end user should give. So once this considers algorithm considers a black box, if the end user can only tweak this iterations and learning rate, he can get a desired output with the data. So now we can see the results what we have got. So first result I want you to see is this overall prediction probability is 84.61, which says that out of these tests, 13 data I have given, 84% of the time machine was able to correctly predict. Remaining 16% or 15.4%, which machine was not able to correctly predict, which means that it has made a mistake. In that case, it would have been some 1.5 seconds and machine would have said it is not a failure. So that is a case. If it had been a failure, machine would have predicted wrongly, or it would not have been a failure, machine would have predicted, yeah, it is a failure. So these cases occur. So 84, it is the efficacy of this machine. And you can see further in detail for each and every time. So 1578, what is the? So this algorithm, as I said, logistic regression, since it is a mathematics, it will give the probability. So we can have an idea about probability also. Not every time we have to. Based on the probability value, we can make a decision. You can see if it is becoming to 1578, we can think 99.9% it may fail because it is deviating from 17. And if it is C 1, 2, 3, 4, then the probability is 5.4 only. Okay, that the system will work fine. If it is 1172, it is 0.5, it is negligible, which means the system will not fail. And you can see a special case like you can see 2938 milliseconds, if it is taking to occur, then 100% the algorithm predicting it is going to fail. So this failure prediction probability It's the main thing in this logistic regression. We'll have an idea about the probability. Based on it, we can act. We can have a threshold of 50% of probability. Once it is crossing 50%, we can take action. So that is also something. So as I said, iterations and learning rate are the things we can tweak to get our output. So I have changed it to get better results. So now what I have done is I have given the same test set is different. As I said, I'm randomly jumbling the data. Like I'm not giving the same data, like same times to this relay. I'm randomly jumbling the data I'm having so that machine should learn on its own. So you can see last data was something different. This is different. I'm randomly giving a test set for the machine to learn and train also to say that. So here I've kept the iterations of 10,000 times. The machines to learn 10,000 times every loop. And learning rate I have kept as 0.2. I have given a more boost to the algorithm. I've given a more, okay, you can do it, like a kind of boost to the algorithm, a kind of additional features, parameters to the algorithm. So now in this case, we can see the failure probability is around 92%. So which means only 8% of the cases this algorithm has wrongly predicted. The remaining 92% the algorithm has correctly predicted that there is a failure. Similarly, a case also you can see, in this case you see 1172 is 0.73, and which means there is probability of failure is very less. And for 4 seconds, that is 4032 milliseconds, the probability of failure is 100%. Which means 10% this particular contact or this contact of high resistance and this circuit is going to fail for any train operation. So we can tell. And now further, next one more thing is, this time I have made the algorithm to learn for more time. I have given 1 lakh times. I have made the algorithm to learn 1 lakh times, and I have given learning rate 0.3. More boost stages I have given. So you can see 10,000, 1 lakh, though it looks like a big number to us, for algorithm or computer, it is a very small. Like 10,000, 1 lakh may take time, like it may take some 2-3 minutes, whereas second 10,000 will do in seconds, operation will be done in seconds. If I increase the iterations like 1 crore, then algorithm based on the processor speed, running operation will be required. So in this case, you can see my failure prediction probability is 100%. So in all of the cases, the algorithm has predicted that is, here I have kept the threshold as 50%. If it is more than 50%, then it is going to fail probability. So exactly all cases the algorithm has predicted. So based on the iterations and learning rate, our failure prediction probability will change. So in a specific case also you can see 2938 milliseconds, the probability of failure is 100%. So the algorithm has predicted clearly, and similarly for other seconds also. So these results of what it shows is that the algorithm has the capability, but it is in a learning phase. The data is also in a learning phase. Data needs to be generated. The things are required, but it can be made as a black box. No need for everyone to go into the algorithm or no need to have deep in-depth programming knowledge. It can be made as a black box, and only three tools or three parameters are to be done. One is your data you have to generate properly based on your sensors, and next is the iterations you can tweak, you can change, and the learning rate you can change. These three parameters you can change, and if you have the data, any division can apply this algorithm for their failure prediction. They need to have a concrete model, what is they are going to do, what is the data, and whether it's a failure case or not, they have to do. And mainly for this case, data taking was not so much difficult for us, because since we took the data logger, our data logger has a large chunk of data which we are not utilizing. So this particular data was taken from data logger. Even data logger has a map for showing the relay pickup time also. The time the relay it has a it can show a plot, but that is not useful here. Here we are tackling the difference between two relays. So the data available in the data logger is not into our format. Here before this testing was done or this experiment was done, the data logger data was required, or it has to be subtracted. It will give, if I take a data from the data logger, it will give me time along with date. So I have to separate the time along with it, and I have to subtract the time. So these algorithms can be done in Excel sheet or in a program also. So this was easy for us. Since already data was available, sensors are not required. We have the data from data logger, we directly apply to it. If you want to do some other applications for point mission track, we need additional sensors also. So, but this is general idea about how this algorithm can be used. This is just the first phase of doing it, and these are the results. Now, this will be the future avenues. The few ideas I'm just throwing open to everyone so that interested people can really work on it, and there's a wide potential for SLT. And many people have started working in many other countries for railways also. So these are the few avenues that I am protecting. It's like this should be useful. First thing is we can monitor the health of a signal unit using the path, current and voltage data, but we need the data. So we have options also. We can do it in our FTOT, but we cannot monitor each and every signal that 110 volt which is getting extended to the site. We can have a more sensor ammeter in series to the 110 VX which is going to the site, and then that we can make. But as a whole, all the particular north side of the station, the signals, all the signal cells can be used, but it is also a possibility. If you want to go in detail, we can go for each and every particular signal current also at every location we can monitor and do. And next is point mission health. We have point mission health. We can monitor using the current or the operating time also. The point mission is taking more time to operate. I can predict well in advance. No need for me to go for maintenance once in advance. And after the system has failed, no need for me to run. If I'm able to, this operating data time, we can do it easily. We already have no data logger, but we must have an idea when the point knob is reversed till the NWKR is returned or indication comes to the panel. The whole time can be taken, and then
yellow color Rajeshwari, please.
This point mission prediction using operating time. This we can do now also. We are on the job. We can do it also. But it will be a wholesome data till our knob is turned, till NWKR is returned. That whole time we will get. But in between, our point operation time is also included in it. If in case if the point is taking more time, it can be due to any friction or anything in the point location or two. But we'll have an idea. But for point current, we can do. But I've heard like people have told me that sensors have been placed point current monitoring. That it also can be used. Next is we can predict the health of our track circuit. It's a very important thing, and we mostly face failures in track circuits. Both is a very simple concept, but still our failures are predominant in this area because intermittent track dropping, all these failures are high. With this machine learning, this intermittent track dropping can be analyzed with the parameters we can take, because when we go and do the maintenance or after the failure happens, after intermittent, it will not repeat also. We will not be able to identify the fault. Most of the cases we say we are not able to identify the fault. But in such a cases with the machine learning, we can have a 6 month data when it has intermittently fault. What are the parameters it has cost to make this intermittent track drop? So such cases can be analyzed using machine learning. And further avenues is our data transmission or telecommunication has a wide potential for machine learning. Mainly data law, this machine learning algorithms has been used in many advanced companies. They have used this machine learning artificial intelligence in their transmission data. So we can identify whether any mistake is there in our transmitting media or device using the data rate, what rate data rate or error rate, what is the error rate it is producing. Based on the error rate, we can have an idea what is the end of error rate. So we can use it. And next is the short-haul protection. So networking is the best thing which uses algorithm for predicting the shortest path. There are many other algorithms for predicting the shortest path. Basic algorithms are there, higher advanced optimization algorithms are there. But machine learning also gives a chance for data path prediction networking. We have implemented short-haul protection in Southern Railway. With this short-haul protection, we can choose the best short-haul path. Even though many short-haul paths, if it is available, we can choose the best path also. It's also one of the applications. And next is for cable. We have a lot of cables, and each cable has problem in it. We will have many problems in the cable. So by analyzing the cable data, we can also have a intuition about whether the data is going to, whether the cable is going to fail, or whether what is the condition of the cable. It's also one of the promising opportunities for us. So with this, like it shows that machine learning has a wide variety of applications, but still let's compare what is the role of AI, artificial intelligence, in Indian Railways, and what is not. So now we can see it just shows two things, like what is the advantages of having AI and Indian Railways, what is not. So we can see the advantages. We can failure to predict well in advance, so it will reduce our failures that whatever is coming, and we can run the trains punctually, and we can reduce the downtime, how much time the gear is reduced. No need for downtime, we can predict in advance. So once it is working properly, we can take a short disconnection, and if we are able to predict minor fault at minor stage itself, we can identify and rectify. So our gears downtime will be reduced, and we can make a monitoring hub that all the data throughout the division can come to a particular place. We can make it as a grid format, and like our data logger system, the data logger room, a separate artificial machine learning server can be created, programs can be loaded into. Data logger data must be refined. That is more important. Data logger data is so raw that it cannot be processed by machine. It has to be refined in such a way that machines can learn from it. Even for that also we can make algorithm. It will take time, but we can make an algorithm. So converting the data logger raw data into the refined form, which will be helpful to us. But data logger has plenty of data which can be used, and that data can be used, and our control room can be made as a monitoring hub that really can be predicted well in advance, and we can inform our counterparts of the field and take necessary action. Next is targeted maintenance. Since we know it is going to happen well in advance, no need to do night midnight, no need to run when train has stopped, we have to run, or any failure happens, it has to run, or instead of doing routine unnecessary maintenance, we can target the maintenance. Because here is really good, we can do the overhauling, whatever maintenance record we can do. But if it is really in a bad shape, we can easily do a targeted maintenance for that. So these are the some good advantages of using artificial intelligence in Indian Railway. And next, let us see what are the shortfalls, what are the problems that are pulling us back. First thing is infrastructure. Let's say we need the data. Primary thing for all this thing is data. Even my colleagues who are into substance and is also into artificial intelligence. Main problem we are facing is collecting the data. Collecting data is a bit tedious for us because our data logger, as I said, data logger data is so raw, and moreover it takes time to download the data, and moreover these data are particularly limited. If I want the current and voltage of every particular gear, I need to have more infrastructure. My sensors have to be placed for track circuit parameters, or at the location I need to get the data. So this infrastructure is a main hurdle, I would say, because once we have the requisite infrastructure, we can start, we can go ahead with the data logger, but once it has to be fully at a complete stage, it has to be complete, we need proper infrastructure. And next is the skill set. Though it's a skill set of nothing but basic mathematical skill set is required, which we all definitely have. And the skill set can be improved more with a bit of programming knowledge also, so that anyone can take the program instead of considering it as a black box. They can make their own programs, and sources are available worldwide that can be used. And finally, thing is, it is a bit complex. People, it is being introduced in the Indian Railways recently. It can be a bit complex for people, but really it is a basic thing. It can be seen from the past. It is just a basic how human. You just put yourself as a child in place of a machine and see what a child will do if you want to do. So you slowly teach. So that much complexity is not involved, but slowly we can also learn. So it is seen that advantages outweigh the disadvantages. So AI can be given a definite go for Indian Railways, and it will help us in maintaining our signaling assets in a good manner, and we can have a punctual running and at the same time very safe running for our passengers. And thank you all for listening to this presentation. I thank C.C. Rajshekhar sir for encouraging me to start with research and guiding me also. I thank my senior sir for motivating me, and my colleagues Saini, Hasimran Saini, Nidil for guiding me, and my supervisor Kumar Babu and field staff for helping me in getting the data. So thank everyone for this opportunity. Any doubts, sessions can please ask.
Any questions?
Yeah, more than questions, possibly a suggestion. Suman, because you have a very promising youngster with you with a lot of knowledge and enthusiasm to do this work, and it's a very promising field from what I find. The number of areas where it will help SNT in the long run, and immediately I think we should look at one, possibly looking at how to go about a proposal to involve possibly IIT Madras into this, because they're doing some research for railways. What I suggest is go over your failure analysis, identify areas which are affecting us. See, one is in terms of the failures per se. It's better to look at this analysis, what they call ABC analysis. What are the failures which are creating a maximum problem for us in terms of even the restoration? Right? For example, cable defects are one area where the restoration times take a lot, and the predictability is not there, because cable testing is something which we are not very systematic about doing, and there may not be any reflections earlier. So identify those failures which are troublesome to us in terms of the randomness of their occurrence and the duration for restoration. So they become your category A. So focus the effort on those A category failures first. And in fact, possibly we can look at a consulting arrangement with IIT Madras. You can also look at making out a proposal. We can work through GM and the former GM at IIT Madras so that we can look at an address. So I think there are some tangible areas of work. I think Ram Prasad has been doing good work. I've been interacting with him, and so also Arsimran. So whatever I'm saying, Suman, is applicable even to Babu. Do an analysis of the failures, identify the failures which are unpredictable for us and take long duration to restore. Prioritize them and let us focus our efforts on those failures because they give us the maximum and tangible benefits. So that's my suggestion. Just that suggestion. Great work being done, Ram Prasad. I think take it to its logical end.
Thank you, sir.
Ram Prasad, this is Sridhar from here. You're able to hear my voice?
Yes, sir, I'm able to hear, sir.
Ajay, I was just listening to you regarding this high contact distance and relays and this one, and you have taken one parameters like time delay, time taking for picking up that parameters you have taken. But when it is being used in the circuits, the picking up relays, so many other parameters involved. Like your end voltage, if it is less, then also that relay status will be there. Parameters. Similarly, other parameters will be there. Then it is taking all the parameters. How it is going to make your graph? And because multiple input, no, and there will be some kind of averaging will be there. Critical point will be there, which is going to be a deciding factor. How you will address this thing? If it is multiple factors, now how we are going to address?
Yes, sir. Sir has correctly pointed out, sir. Actually, multiple inputs are possible for this algorithm. Just since it is a learning curve, we have taken only one input. Algorithm is capable of handling multiple inputs, sir. Actually, the equation is such that it can take voltages also, time also. Based on this, it can make a very concrete decision also. So in this case, I was able to, since with the data logger data which I had taken, I was able to take only the time. So data logger data cannot unlock relay and voltages each and every time I couldn't take what is the voltage. That's why I introduced the resistance. Slowly we changed the part and it took the time. But for digital data for relay, we generally are taking the digital data, ones or zeros. So with that data, I cannot do, but Sir's idea is really good that I can take the voltage of the particular relay end and that also I can feed it to the algorithm. So if it is fed, it can make a more informed decision it can take, sir. But that analog voltage has to be, relay analog voltage has to be taken, sir, through some sensors or data logger also, analog voltage we can wire, sir.
Any questions, sir?
There will be multiple parameters and multiple point of critical decisions to be taken. That has to be averaged and regression to be taken for that, is it not?
Yes, yes, sir, correct, sir. Yes, sir. A program has to be changed accordingly, sir. If I am giving more inputs, the equation has to be changed accordingly. This is just for a simple one input, one output program, sir. For multiple inputs, we can change the program, sir. But it will give a better result. Like instead of one input, if it has multiple inputs, can give, even the algorithm can be made for its points are not in favorable position also. That point operation time also we can take include as a parameter, and that case also we can predict, sir.
Okay. Good, yeah, good presentation.
Suman, am I audible?
Yes, sir. Yes.
Yeah, Ram Prasad, very nice presentation. Here in recent times,
Thank you, sir.
A great one, that too from our DST, who is in-house.
Thank you, sir.
Really good. And this one is recently I actually through last month there are 5 techniques are available, particularly using this type of unheard of these like AI blockchain technologies not being used in signaling SNT systems, where the world is also looking into it, which we have missed it, like something like that. So this is one of the good steps where you have taken and had studied as CSE told. AI has to be implemented in consultation with IIT Madras and all. Definitely, it will be a great step. Here, what I may is doubt or suggestion, what you can say, instead of going for infrastructure or particular component level, where we are already having sufficient systems which are already available for monitoring a particular gear or particular gear, say, track circuit and all, which is we are having are going to give in commercial products, and then we will send the data in the cloud, and then we will compare and doing it. But these components is integrated, like system integrated equipments, integration systems. For example, you are operating a route, what you have explained. Say you have process is nowadays turn the knob, then from the again coming back and signal it, and then signal has you got a signal, let us say. So this entire operation with one click you are doing, and you are expecting that in next 10 seconds it will be happening, because depending upon the number of points in the type of operation. So in that such type of operations, you can take it rather than monitoring the equipment predictive analysis. This also will not be understood by somebody else, like particularly unless you are a signaling engineer.
Yes, sir. Correct.
I expect to have this study also, so that it will be a great advantage for us, so that we can improve upon the entire system as a whole by using the components where the components are already having AI inbuilt by commercial equipment, or which we are going to do it as per RD specifications. This step will definitely take you to next level. I'm sure that this will be really useful also for us.
Yes, sir. Definitely.
Thank you very much.
Thank you, sir.
Any questions? We will go for next.
Ram Prasad, one question from my side.
Sorry,
about
sir.
CNDST coordination Chennai.
Sorry,
now,
sir, please.
So what is the tool you are developing now? What is the action plan you are making for any predictive maintenance tool? Anything is in pipeline?
Sir, with MATLAB only I have made, sir. MATLAB package is available. It is not an open source tool, sir. But I have taken from a friend, like we have taken the tool, but tool is not open source, but we can purchase the tool. With MATLAB, it will be much more simpler, sir. We can make it as a Simulink. There is a kind of tool with MATLAB Simulink, so that can help us in do. But now next we are planning to implement the signal cable which is going from the FTOT to the field. So on identifying one whole side signal units health, we can do it, sir. Point mission health also, this both work we are planning to do, sir. But this MATLAB has to be...
Okay, good. Now here one thing I'm identifying, two problems we are facing. One, we are having already some predictive maintenance tools like ELD or data logger is available. Now, if you see the data logger, if as and if you go and check it also, there may be so many issues with the logic. Okay. Now, unnecessary false logics are getting triggered. Is there a way out to sort out those things? Because electronics have so many letters also. Now, even then when we're doing validation now, signal passing of danger is coming, or some other issues are coming. When ultimately it is going deeper, it is coming as a problem of logic. What is happening in data logger is relay status they have given, like so and so up condition, down condition, everything they have given, but it is taking old data of some triggering. Okay, triggering point is some old data. It is not the correct data. That's why false triggerings are coming. Now, if you go with your experience, is there any way out to sort out those issues? That is one thing. Second thing is already we are having ELD, where doing predictive maintenance. Some alarms we are generating, but what is happening is we don't have the faith on the system because so many false alarms are getting triggered. Can you take it as a point to go ahead with the existing data logger ELD, where at least existing system can be fully utilized if you are able to sort out those shortcomings?
Yes, sir, it can be done. That's a good idea, sir. It can be done, sir. In that case, first you have to teach the machine, like, which is the really fault logic, the fault logic which has been wrongly entered. That we could have wrongly entered the track, which instead of a particular track, they would have entered other track, so it will create a false mode, sir.
No, that can be easily solved. That is not a problem. That is only checking of data. That is easy. But I'm talking there is inherent some deficiency in the logic. It has been pointed out to electronics also almost 4-5 years back. Even then now I am coming and seeing same things are being repeated. Okay. Now, at least with your experience, we can coordinate with the data logger person like electronics or something, We can set right
Okay, sir.
whatever this logic problem is there. They are unable to set it right. They are telling everything is correct only, but ultimately it boils down to there is really problem is that they are not able to set right. That is related to data layer. Second thing is related to ELD. Already we are having some system where it is giving because of calibration issue or some other issues, it is giving some false alarm. By taking the ELD as a input, is it possible to devise something telling that yes, our cable is at fault, there is a real problem with the cable, so that our persons can go there and attend the cable before failure happens.
Yes, sir. It can happen. It can be done.
Also unlock voltages. Last time you have seen it. Harsimran knows it. Okay.
Yes, sir.
Before cable fault failure, it has given some indication of spikes and all those things, fluctuations in the voltage power supply, and sudden drop that one. And with that one, if you are able to, whatever logic we are going to develop by utilizing the data log ELD, if you are able to develop that easy for our system instead of inventing a new tool. Okay, but anyway, Chennai, IIT Chennai, and other things, always it will definitely come up. But already we are having some basic system. By utilizing the system, we can make it more effective by putting some artificial intelligence. Already now, they are telling point machine tool, all these things, everything is based on our data logger only. Okay. Maintenance predictive tools or battery monitoring or everything, they are taking the data and analyzing it and doing it. But one thing is, some shortcomings are there in that one. Either with VO, so Harsimran, all these things who are already into this thing, artificial intelligence, you can make a step towards this direction. That is my suggestion. Okay.
Definitely. Definitely, sir. We'll work on it.
Side.
Sorry, sir.
Can you hear me?
Yes, sir. I'm able to hear you.
Yeah. So this you have taken the case study of time taken for activating the LR pickup and the HR pickup.
Yes, the time difference.
Based on this timing, you have you are going to predict whether there is any contact resistance problem.
Yes, sir. Yes, sir.
So okay, the tools, everything is okay, but the factors, okay. One is that because the resistance being an LR circuit, the resistance will have an effect on the pickup time.
Pickup time, so that's a hypothesis.
This is a hypothesis based on which you are trying to now make the system learn the system.
Yes, sir. Yes,
so
sir.
the thing which you have missed is that there are certain other parameters also.
Correct, sir.
Find if it is in favorable condition, if it is not in favorable condition.
Yes,
so
sir.
then your hypothesis becomes very critical when you are teaching a machine. If these variables are there, then it may learn wrongly also. Because if the points are on favorable condition, you may get a lower time.
Correct, sir. Yes, sir.
But if the resistance is completely very high, but if the points are in some other condition, then you may get a different result.
Correct,
so
sir. Yes, sir.
It becomes very critical, I think, when you are going ahead with teaching. The first thing.
Yes, sir. Sir, for that also solution is there, sir. In that case, as I said, the clustering, you have to cluster the data into 2-3 groups, sir. But since I started the programming needs multiple clustering, it's a complex programming, sir. We can do that programming also. We can cluster where the points are in favorable condition. That will be one cluster. For that one prediction. If points are not in favorable condition, for that one prediction, even LC gate also. If, for example, if LC gate closing time may vary, so that also separate clusters. We can first group the data into clusters. Then that clustered data we can use for predictions. Also, that all is correct, sir. Lot of externalities, lot of variables are involved. But this is a simple case, but for that clustering can be done. But the clustering algorithm, the more clusters we want to separate, the more complex algorithm is. So that also can be suggestions. I will include. I'll do the clustering algorithm for doing this case also.
Yeah, because this is a knowledge which we only have. Even if you go to IIT, they will be able to know that what is the variables, what are going to affect.
Correct.
Telling is what is very critical. Creating that hypothesis, that is where we have to apply our mind and then go ahead for modeling.
Okay.
Just one related issue, because this has been brought up. See, what you could possibly do was look at stations which have identical configuration. What do I mean by that? I look at a station which is a wayside station without LC gates, right? And look at similar yard layouts and look at what are the time frames. So essentially, like what you just said, you're clustering the data, right? Possibly there are two levels of doing it. One is you do it through the artificial intelligence. Other is through your learning data, which is being supplied itself, right? So the learning data which is supplied, it will be relatively easy for you to do it because your drawing office can identify yards which are identical with regard to the availability of an LC gate or non-availability of it. So that data you can always filter it and use it for learning. So what you're essentially doing is your algorithm and the particular tool which you're creating becomes specific to a particular yard configuration.
Correct.
Right? Improves the accuracy and eliminates this issues with regard to the LC gate being far away. So that itself taking time for a pickup, further delaying whatever the operation and so on and so forth. Right? So possibly you can start segregating the data at the capture level itself, rather than look at developing an algorithm to take care of this, right? So what I suggest is possibly work with your drawing office, identify such yards, and then work. So essentially you're clustering, you're kind of segregating it totally. Using your algorithm for a particular case, your capture data is identical to that. So you create tools for without LC gate, with LC gate, or whatever parameters you identify.
Okay, sir.
Is that okay?
Yes, sir.
Am I making any sense?
No, sir, that is correct.
So
That
I've
is
become a making sense.
Yes, it can be done in that way.
Look at it. I think your drawing office, please involve people with regard to your data. In fact, the reason why I'm saying IIT Madras Consulting is a lot of the data crunching and gathering and filtering out can be done by students who will be much more enthusiastic to see it in a practical context. While you can give the domain knowledge and the overall expertise. And it will be a win-win for all of us. Like I know you've been working, you and Lakshman have been working for quite some time now. But to expedite that, because the domain knowledge and the expertise and applicability is what is critical. They'll be able to do the number crunching and working on the algorithms and tool verifying, setting those parameters, setting those iterations, and so on. So look at involving people where you don't, basically the grunt work can be done by somebody else while you do the intellectual work, that kind of a arrangement. I think Suman, please do plan it. I think they've started making some progress. Similarly, Babu also, please contemplate going ahead. One of these days, possibly we can have a discussion. We'll have a separate BC on this and then let's see how to take it forward. Is that okay?
Yes, sir. Thank you, Ram Prasad, for giving
Thank you, sir.
presentation. We have discussed about machine learning, training of machines with different methods, with case studies you carried out in Bangladesh and function of MDUs, like high contact distance. Thank you. So we'll go for next presentation. This is on lightning and surge protection for SNT gates by Manu Mukundan. He is manager protection solutions of Research in India. Mr. Manu, over to you.
Thank you, sir. So, is my PowerPoint visible, sir?
Yeah, you can go ahead.
Yeah, thank you. So, first of all, I would like to thank the organizers and IRSTE Chennai chapter for giving us this opportunity to conduct the presentation. I belong to an organization called DEN India Private Limited. We are part of the 110-year-old DEN group in Germany. And for the past 110 years, we've been involved in lightning and surge protection business. The major solutions that we offer in India is the external lightning protection components, lightning current tested clamps, and natural weather condition tested components that we supply. And also for internal lightning protection, surge protection devices, isolating spark gaps, equipotential bonding devices, etc. These are all certified by third-party or agencies like KEMA, VD, etc. We also supply earthing and bonding devices, and most of our products are UL listed. We are also involved into safety devices, which can be used in the railways also, and also in the power distribution. These include high voltage detectors, short circuit devices, arc flash suit, arc flash helmet, safety high voltage gloves, etc. Also, we are involved in the installation, testing, and commissioning of the products throughout India. We also offer consultancies, solution services for protections. We carry out risk assessments of sites as per IEC 62305 and look at what is actually missing and what can be implemented to improve the system there. And from a point of electrical safety, we have a separate division which deals with electrical safety, power quality, and arc flash studies. So we offer electrical safety based solutions also. Now, without much further ado, we'll jump into the technical topics. So before understanding the concept of lightning and surge protection, we have to understand the sources of disturbances or sources of damages. So this slide is going to represent the sources of damages. So the first source, which we all know is and which we all worry about quite frequently, is external or direct lightning strike. So direct lightning strike can be onto your structures. It can be onto your ground also. So direct lightning strike will most probably damage your physical structures, especially your relay rooms or your IPS rooms, etc. and station buildings. These are damaged during direct lightning strike, and this is one of the damage which causes significant hazards to people, especially death is caused by this kind of failure. And this also creates a specific inductive effect, which can be through the conductive cables, and induced EMFs in the cables can be caused. So these are the induced loops that you see. Alternatively, the strike can be a few kilometers away even. It can be on your transmission lines, or it can be on your railway tracks, and these will get coupled to your electrical and electronic and communication infrastructure. So this is the second source of lightning. And the third one is any strike which happens near the service lines. So it need not be that lightning strikes on the service wires or on the tracks. It's instead it strikes near it, and these induced effects of this lightning current can again cause disturbances or failures in your signaling and telecom equipment, in your power supply systems, etc. And one of the most common causes of failure is this one, where the lightning strikes the ground near your infrastructure. And because of this, there is a ground potential rise, and all your earth connections will rise to a higher potential, which can again lead to failure of equipment. And this is the most widespread reason of failure for any equipments, in any industry. So let's see how that works. For example, say you have protected your building from direct lightning strike. It need not be that you have protected. It can be even the ground. But we are considering that, say you have given a very well designed external lightning protection system, and say there is a lightning strike onto this building of 100 kiloampere. And if the system is, or the power system or the information system is given an earthquake with 1 ohm resistance, when 100 kiloampere of lightning current flows through this 1 ohm resistance, there is going to be a potential rise of around 100 kV. And this 100 kV potential is going to come across all your equipments, all your earth terminals. In fact, even if you're talking about your PC, it will be appearing across your third pin, which is the earth pin. So this huge potential difference of 100 kV, and if you see your face wire, it is just 230 volt, which is going to damage the equipment because of the significantly large potential difference. So the concept is, how do we protect from such failures? So we have spoken to quite of our customers, not only in the railway industry, but also in other industries, where they always believe that a surge protection device will protect from this. And how it protects is, it absorbs the lightning current and injects it into the earth. So this slide is aimed to avoid that misconception. How an SPD works is, an SPD is basically a voltage triggered switch. So what it senses is, it senses the potential difference between 2 points. Once it senses a heavy potential difference, it closes, and it brings the phase wire also to the same potential. So now you see there is no potential difference between these 2 points, And once there is no potential difference, the equipment does not fail. Once this higher voltage is dissipated, immediately the SPD switches on and the power supply is restored, wherein you have the phase wire is at 230 volt and this is again at 0 volt. But this entire operation occurs within nanoseconds. So that is why you don't see any interruption of your equipment or any failure of your equipment. So this is how an SPD works. So now there are two kinds of SPDs, and in majority of the railway tenders, most of you might be aware about Class B SPDs and Class C SPDs, etc. So let's see how do we categorize these SPDs. So SPDs are broadly categorized based on the test currents on which they are tested. So there are two kinds of test currents. One is the 10 bar 350 microsecond impulse current, and the other one is the 8 bar 20 surge current. So the source for 10 bar 350 impulse current is natural lightning, and it is a waveform in which the rise time, that is from 0 to the peak value, the rise time is around 10 microsecond, and the half decay time, that is from peak value to the half decay value, which is 50% of the peak value, it takes 350 microseconds. So you can see in the y-axis you have current in kiloampere, which is the lightning current, and in the x-axis you can see it is time in microsecond. So at 10 here we are representing 100 kiloampere 10 bar 350 microsecond waveform, or 100 kiloampere lightning current. So you can see that in the rise time, which is 10 microsecond, in 10 microsecond it reaches the peak value of 100 kiloampere, and in 350 microsecond it reaches the half decay value, which is 50 kiloampere in 350 microseconds. So such a waveform is called a 10 bar 350 waveform, and any SPD tested with a 10 bar 350 lightning current is called a Class B arrestor. And now going to the Class C arrestor and the 8 bar 20 surge. So 8 bar 20 waveform is used to represent a switching surge. So switching surge happens when any switching activity happens. It might be relay switching on, it might be contactor switching on, it might be load switching on, it might even be faults which are causing trips of the breakers. So any say switching activity which affects the steady state condition of the power system causes switching surges, and this switching surges again classified by the 8 bar 20 waveform. So it means that in 8 microsecond it reaches its peak value, and in 20 microsecond it reaches its half decay value. So you can see the difference in area of these two waveforms, and the area is going to represent the energy which the waveform which this waveform contains. So you can see lightning current is far larger than a switching surge current, and you can see the energy here also. When this current flows through a 1 ohm resistor, it dissipates around 2.5 megajoules of energy. And at the same time, when a switching surge passes through a 1 ohm resistor, it passes only around 400 joules. So that is the energy difference between a lightning current and a surge current. And similarly, the capability of a Class B arrestor is going to be far superior than a Class C arrestor. Now, how to achieve a complete lightning protection? So this diagram or this figure represents how a complete lightning protection or a comprehensive lightning protection system looks like. First of all, it will have an external lightning protection system, which is going to protect it from direct lightning strikes. Then in the power supply, from any lines which are coming from the outside, which is from the field end, you can call it from if we talk about the railway applications. So any lines coming from the field end will be protected using a Class B arrestor or a Type 1 arrestor, as we call it. And then any communication lines also has to be protected using SPD tested for lightning current. And after that, if there is any chance of any switching surge happens, or there is the distance far higher distance from the Type 1 arrestor, you need to use Type 2 arresters or Class C arresters, and that has to be used commonly for both power as well as communication. During some of our site visits, some of the observations that we have made is that in the Indian Railway, the power side is well taken care of as far as surge protection devices there. When I say well taken care of, I mean some surge protection is there and general awareness is there about surge protection. But when it comes to instrumentation technology or when it comes to the communication technology, there is lack of awareness as far as surge protection devices are concerned, and we don't see much surge protection devices being used for communication networks also. So now let's see how railway infrastructure can be protected, especially the communication and signaling infrastructure. So the first one is, as I said, Class A lightning protection, which is for the buildings. And this is applicable for your relay rooms or your station buildings or any IPS rooms, etc. All these buildings need to be protected from direct lightning currents. So how to do that? Earlier, there was widespread usage of early streamer emission terminals, or you can call it non-conventional lightning protection systems. And this is a statement from the National Building Code 2016, which clearly states that any other kind of air terminal like dissipation system, ESC air terminal, or CSC air terminal shall not be acceptable. So no ESC terminals or any special kind of air terminals are allowed in India, and these are not going to help you also. So what will help you is an LPS designed as per IS/IEC 62305, which is the National Lightning Protection Standard, which is the lightning protection standard of India. So you can see the air termination design, there are multiple methods being adopted. The best method to adopt is a method called the rolling sphere method of design, wherein you have multiple air termination rods on top of your structure, all interconnected, and multiple down conductors bringing all the lightning current, intercepted lightning current to the earth. So bringing the down current, lightning current through the down conductors is also going to be quite tricky. The reason is you have very sensitive electronics inside your structures, and these sensitive electronics can get induced effects even when lightning currents are flowing through these down conductors. So special cables as per the NBC 2016 or as per the IS/IEC 62305 are available, which will contain this lightning current inside and prevent any flashover from the lightning down conductors to your signaling cables or any signaling equipment which is in the vicinity. So these cables have to be used, and these are called high voltage insulated cables, and these have to be used to bring down the special so the intercepted lightning current to the earth termination. And the best earth termination which is recommended for buildings or structures housing electronic infrastructure is a ring earth electrode. It is not individual earth pits. What you have to do is you have to run a type B ring earth electrode. It is nothing but you can use a 25/6 copper or GI strip, run it all around the building at a depth of 500 mm. It has to be at a depth of 0.5 meter below the soil, and at least 80% of this length has to be in the soil. So this is the type of earthing system which is recommended for structures housing electronic devices, and most of the signaling and telecom equipment are sensitive electronics. So this is the form of earthing that has to be used for uh, lightning protection for signaling and telecom buildings, and all the down conductors can be connected to this ring earth electrode as we call it. Apart from this, now let us see what are the protection measures required for various signaling and telecom infrastructure. First of all is the track circuit. For the track circuit, you have the field end and a feed end and the relay end. From the IPS room, you have the power coming to your track feed as a rectifier, a class B arrestor, which is coordinated and which is rated for 230 volt, has to be installed here. And also from the relay room, when your control voltage of 24 volt DC is going to your trap repeating relay, there again a class C SPD has to be provided. So this is the infrastructure protection or the power side protection that you have to employ for a track circuit. Now let us look at LED signals. For LED signals, you have the power which is going to the signals, which is 110 volt AC, and then you have the control signals which are 24 volt DC. So from the control room to the selection board, the power supply which is going is 110 volt AC, and that has to be protected using type 1 or class B arrestors. And this has to be done at both ends, one at the field end and one at the controls room or the station end. Why is this required? Because lightning is not direct, it does not prefer any specific direction. And if you talk about lightning from an electrical point of view, it is called a traveling wave. And why it is called a traveling wave? It will travel in both directions. So if there is lightning, it can travel to your control room and also, and it can travel to your selection board and also, where it can damage your LED signals. So that is why surge protection devices are required at both ends. Similarly, a 24-volt DC or communication SPD has to be used for the control signals, and that is why we have marked this in yellow. So all the power lines are we've marked in red for easy understanding, and yellow is the communication lines. So this also, as you can see, has to be protected using a lightning current rated SPD or a class B SPD at both ends. So one is at the control room end, and the other is at the selection board end. Now, when we come to axle counters, in the axle counter, again, you have a 24-volt DC power supply and you have a quad core cable which is connecting your axle counter evaluator to the field end. And then you have the reset unit again, which is supplied using a 24-volt DC, and you have transmitter and receivers. And these are also installed at the field end. So now from the axial counter evaluator to the field end, you can see the 24-volt DC supply has to be protected with a class B arrestor, which is rated for lightning current. And the communication cable which is the quad core cable, has to be protected using communication SPDs at both ends, one at the axial counter evaluator end and the other at the field end. Similarly, the reset unit, which is supplying a 24-volt DC, this also has to be protected at two ends using a power SPD, which is rated for 20-volt and tested using lightning current. And at the field end, you can see the signals coming from the receivers and the transmitters. These also have to be protected using communication SPDs, which are tested for lightning currents, or you can call them the class B arresters. Why this is required is the railway track is spread throughout, and any lightning current on that can be coupled through the railway, through the receivers and the transmitters to the field unit and cause widespread damage here. So lightning current concept is very simple. Whenever there is any chance for lightning current from entering from the outside to the inside, you need to have a barrier in between. So that barrier is your surge protection devices. So you can see that always whenever there is any chance for lightning current to enter from any side, we have provided an SPD. Now, this is again the infrastructure which we explained. So at the axle counter end, you need to have surge protection devices for both the power and the communication end. Same at the trackside EAC end also, and also for the transmitters and receivers. Now, if you look at an overview for power protection, you can see that in most stations, you have a main LT panel where the power is coming from the EB. So there has to be a type 1 arrestor there. And for large stations where the SM room is separate or the station master room is separate, we have seen that they also have separate power supplies from the EB. In that condition, that room also requires a type 1 arrestor. When these buildings are spread throughout, when you have a large station, for example, if the IPS room is far from the SM room and from it is far from the LT panel, and when you have the relay rooms are also spaced quite apart by distance, then you need to have type 1 arrestor in all these buildings, because lightning can enter through these cables which are connecting different buildings. But when all these are enclosed within the single structure, then you need to have type 1 arrestor at the main LT panel and type 1 arrestor at the station master room, and type 2 arresters in the IPS room and relay rooms. So now, what are the major challenges that are faced in the Indian Railways signaling and telecom side? So one is a lack of proper external lightning protection for railway buildings. So there are no specific specifications available for lightning protection of structures with the Indian Railways. Even though there is a recommendation to IS 2309, it is from 1989. And the conventional logic, what we have seen is, if it is a small building, there will be a single lightning arrestor and 2 down conductors. And if it is a bigger building, then there will be 2 lightning arrestor and 2 down conductors. So this has to be improved. What we need is awareness on design of lightning protection system and a properly designed lightning protection system as per IS/IC 62305. The other one is the lack of class 1 SPDs for power systems. And what we see here is, mostly to reduce the cost, OEMs or the contractors, what they use is they use class C arresters. And class B arresters, even if they are used, they use improperly sized class B arresters. For example, the minimum lightning current rating required for a structure protected with type 1 lightning protection or class 1 lightning protection is 25 kiloampere per pole. But we have seen installations where even 7 kiloampere SPDs have been used. So that is one of the major challenge that is faced. The third challenge that we have seen, or the challenge that is faced by the Indian Railway, is the lack of use of lightning current rated communication SPDs. As I said earlier, there is general awareness about surge protection devices for power supply or power distribution side, but there is lack of awareness when it comes to the communication side or from the instrumentation side. So these equipment also, from especially those lines which are feeding to the field end or which are returning from the field end, require lightning current rated SPDs. The fourth challenge that we see is the lack of equipotentialization. When I say lack of equipotentialization, there is a concept of clean earth and there is a concept of separate earthing for each and every equipment. There is separate earthing for power, there is separate earthing for lightning protection, and there is separate earthing for signaling and telecom equipment. From the point of view of lightning protection and from the point of view of standard, the recommendation is that everything should be interconnected to achieve the same potential. As you might have seen in the previous slides, the threat is from potential difference, not from the higher voltage itself. To eliminate this potential difference, every earthing arrangement has to be brought to the same potential. Every metal structure has to be connected to the earthing arrangement. So this is how we achieve it. So if you are worried about noise or if you are worried about any disturbances from different outputs, there are options available where you can interconnect it without affecting your system's daily operation. So that solution is the use of isolating spark gaps. So isolating spark gaps are nothing but 2 metal electrodes which are separated in vacuum or in air, and they're enclosed by a metal encapsulation, and these can be used to interconnect. So what it does is, under normal operations, these metal electrodes are disconnected and your system normally operates and there is no potential difference and there is no noise. Your system is completely safe. Whenever there is a potential difference due to lightning or any fault condition, what happens is there is a arc which occurs between 2 metal electrodes and it creates a momentary short circuit, thereby bringing up on equipotentialization. So this can also be explored, and we would love your inputs on this top point also, and how to implement equipotentialization. Now, the fifth and most challenging concept is the compromised SPD solutions from OEMs, which is there to reduce price. So this happens because of the say conditions that at least 3 vendors have to be there. To give you a general example, we were working with some axle counter manufacturers or OEMs and also with the RDSO. So as per the RDSO, if you see RDSO specifications, the SPDs to be used for an axle counter has to have an operating voltage which is close to 5 volt. But in the field condition, when there is a train running through the tracks, we have seen that there is an induced voltage which is rising up to 180 volt. Now, in this condition, what happens is the 5 volt SPD which is used to protect the axle counters regularly fail. So what the requirement is? The requirement is 180 SPD rated for 180 volt. But since vendors are not available for a 180 volt, or 3 vendors are not available for 180 volt, what RDSO does is RDSO goes with a specification which is acceptable by all the vendors or all the OEMs. So that is how there are challenges. And when we discuss with the RDO, so what they say is we always send the specification over to the consignee, and we don't get, or we get only very few comments from the consignee. So this is where we require your help also into because you are more familiar with the system and what are the voltages involved in that, and what are the operational conditions in the field. So your inputs will be very valuable to us also to develop better products which can work better in a railway environment, and these can again go to the RDSO, and we can also modify the specification so such that it suits the requirements of the Indian and railway signaling and telecom engineers. Now, what is the present condition? As I said, no standard compliance for lightning protection system and surge protection devices. As I said, there are some general awareness and there are some surge protection devices used, but either with indication or with the indication which is not legible, or without indication. Sometimes it is indication using LED lights which are prone to frequent failures, and sometimes there is no indication in the SPD at all. So the requirement is that indications must be mechanical. It should be clear. It should not be that a single color is used. For example, the general concept is to give a green indication if the SPD is okay, and to replace it with a red indication when the SPD is failed. But we have seen products which always have a red indication, and maybe it varies, it moves the position. So the user or the engineer who's at the field and is confused, and he doesn't know whether this SPD is actually working or not. And sometimes we have seen SPDs using LED indications. Sometimes the indications are blinking, and now again the user is confused whether this indication is telling me that the SPD is failed, or the SPD is working, because the indication should be either on or off. It should not be blinking. So that is why we recommend the use of mechanical and clear and legible indications. The third one is lack of certified or tested components. So what we have seen is there is a widespread use of SPDs. Sometimes these SPDs are manufactured even locally in India, and they have no certification. Even if you look at other governmental agencies like the Indian Army, Indian Navy, Indian Air Force, or any defense infrastructure, they always demand that the products being used have test certificates which are conducted by reputed third parties like KEMA or like VD or NABL. So this third party certification has to be demanded, and it has to be demanded by the consignee. Only then you can ensure that quality products come into your infrastructure. The other one is installation of type 2 class C rated surge protection devices at uh, type 1 SPDs at field and instead of type 2, because we have seen that normally the cheaper components, which are the class B, class C or type 2 SPDs, are installed at the field, and this is to reduce cost, but it will not suit your purpose, because the requirement is at the field and is for lightning current rated SPDs, because lightning current is more, or the interruption or the interference due to lightning current is more in the field end. So that is why you have to use lightning current uh, rated SPDs. But what is right now being used is type 2 or class C rated SPDs at the field end instead of type 1 SPDs. The fifth challenge that we see is incorrect installation of surge protection devices. Even if a very good surge protection device is being used, the lead length or the wire length which is used for the connection of the SPD is sometimes very wrong, and the earthing practices are also very wrong. Sometimes we have seen that there is separate earth pit being provided for the SPDs. That is not required. Sometimes we see that the wire length from the SPD to the earthing terminal is around 5 meters, or the wire length from the positive or negative of the SPD to the positive or negative of the equipment is 2 or 3 meters. So care should be taken in this installation, wherein the installation length is very important, because every 1 meter of cable will let through 1 kV of voltage to your equipment. So to reduce that, the length of the cable has to be lower than 0.5 meter combined. So this has to be ensured. Also the wire size, sometimes we have seen 1.5 square mm wires. So for class 1 SPDs, power SPDs, the recommended wire rating is around 16 square mm. And for class 2 type B or class C arresters, the required wire rating is 10 square mm. So that has to be maintained. And for communication, SPD is 1 or 1.5 square mm is acceptable. So incorrect installation of surge protection awareness is required for this to avoid this incorrect installation. And that is where we can also help you out, or we can also involve in certain awareness program on how to do the correct installation. This also we can do, and how your engineers can also inspect to see whether the installation done by the contractor is correct or not. So this is something which we both can work on. And also the sixth one is lack of SPD with proper short circuit current rating. Again, if you see the RDSO specification, the short circuit current rating required for an SPD is around 3 kiloampere. But if you see any field condition, normally any substation or any station, the field primary fault level at the 11 kV side is not is going to be at least 18 kiloampere, and in the secondary side it can be 10 kiloampere, it can be 15 kiloampere, it can be 18 kiloampere. In some cases, it can go even up to 65 kiloampere. So this is entirely depend on the fault current capacity of your transformer. What is the fault current which is going to come? So 3 kiloampere is very, very low. So you have to select the SPDs based on the proper fault current. Otherwise, what will happen is when the SPD operates, the transformer short circuit current will also flow through it, and what will result is in fire. So selection of SPDs based on the proper short circuit rating of the transformer is also very important. Now coming to the topic of incorrect maintenance, what we have seen is SPD indications are not checked regularly. In fact, when we carried out some site visits, we have seen that indication is red and that has not been replaced. So periodic inspections have to be done to see whether the SPD indications have changed, and if the SPD is failed, it has to be replaced. And what we have seen is SPD disconnected from the systems, again due to incorrect installations. Whenever whenever the site team is facing facing a problem, the SPD is removed immediately and left right side. So the solution there is remove the SPD and then the problem is solved. But what was the problem that was causing the disturbance? That is not identified, and that has to be identified, and then only you can integrate the surge protection devices into your system and thereby ensure proper protection. So this has to be taken care of. And the third one is corroded connectors and other connection points. So this is something which is related to galvanic corrosion. And in galvanic corrosion, most of you might be aware that there is dissimilar metals, and dissimilar metals should not be used together. So what happens is sometimes the contractor who is installing it, or sometimes the maintenance people, they change different metals. So what we have seen is at the earthing terminals, you have corroded connectors and other connection points. Even in the SPD leads, if you use normal copper lugs with say GI strips, what happens is again there is corrosion there. So this has to be taken care of, and proper coordination between metals has to be ensured. The fourth one is whenever there is an external lighting protection system due to corrosion or due to human interference, the lightning down conductors or the air termination is generally disconnected. So again, periodic inspection is required for such installations to ensure that these are not disconnected and that proper protection is always ensured. So that is it from my side, and thank you for your patience. Thank you for patiently listening to us. If you have any questions, I'll be happy to answer it.
So Manu, I am Selvadri here, and I got some questions. Now, this is actually SPD is connected. How to differentiate whether it is working or not working, or whether it is connected to the earth or not? That is one question. Physically, you have to, or any method.
Sir, there are options.
Any method is there where we can be able to find out remotely. This is one question.
Yeah.
Second one is you told both the end it should be connected. Why both the end? Why not it one end? Because it is anyway it is going to balancing both sides. That is second question. Third one, what is the replacement cycle? How long it will we can continue, and when is the replacement we have to make it?
Yeah. Thank you, sir. So I will try to answer these three questions. The first question was, how do we know the SPD is failed or not? So there are two kinds of SPDs, as I said. One is for the power side and one is for the communication side. So I'll explain one by one for the power side as well as the communication side. For the power side SPDs, you have local indications in the SPD itself. You have green indications which shows that the SPD is working, and you have red indication which shows the SPD is failed. So if you physically inspect the SPD, you will come to know. Now to the point whether you can know it remotely, yes, that is also possible. Surge protection devices come with remote contacts. So these are NONC contacts. So you can use these NONC contacts to get indications. You can connect it to your existing infrastructure and to monitor whether this is failed or not. So for example, if my SPD is working, if I connect two of my wires to the NO circuit, then it will show that the circuit is normally open, so I don't get any signal. The moment the SPD fails, the NO becomes an NC, and I can get a hooter indication, or I can get a lamp indication, or if I want to integrate it into my IT system, I can do that also. So that can be done as far as the power side is concerned. Now, when we talk about the communication side, for communication side, products are available both with local indications and without local indications. Wherein with local indications are available, you can again physically inspect it. Without local indication for these devices, there are SPD testers available. So these testers can be used to locally go and physically verify whether the SPDs are working or not. The third one is we have SPDs with remote indication. So that remote indication is also two types. We have RFID systems with the life check system, which constantly monitors whether the SPD is working or not. And it can also give you preventive maintenance inputs, because it can even give you inputs saying that this particular SPD is going to fail. So systems with preventive maintenance inputs like RFIDs are also available. Then again, as I said, SPDs with contacts, remote contacts, NONC contacts are also available for communication SPDs. Now, the second question, sir, can you just repeat the second question?
Why both the end we are suggesting now?
Yeah. Yeah, why both the end is required, sir. So when you look at any infrastructure, you let me just say it like this: you have a control room end and you have a field end. So what you can have is at the control room end, you can have a surge protection devices to protect the control room. And when you see the distance of the cable between that, every time there is an inductance in this wires, right, sir? So even though the SPD at the control room end protects it, there is lightning current, a partial lightning current, which is going to pass through wires. So you can see the rate of change of lightning current. As I said, it is in 10 microsecond, it reaches the peak value. So the di by dt of lightning current is very high. So when this passes through the inductance of a wire, you have a voltage rise, which is L di by dt. So when the distance from the SPD increases, the voltage generated also increases. So that is why if you want to protect both your field end as well as your control room end, you need to have two separate SPDs. Even if you have it at the main incomer, say your terminal equipment is say 30 meters away from your main LT panel. Even in that case, even if you have a type 1 arrestor there, you need to have a type 2 arrestor or the class C arrestor in terminal equipment side. This is to limit the voltage which is generated because of the mutual inductance or the inductance of the cable itself.
Any distance criteria is there?
Sir, for power systems, if the distance from the SPD is more than 15 meter, you again need an SPD to limit that voltage. That is the general rule. And sir, can you please repeat your third question, sir?
Replacement cycle.
The replacement cycle, yes, sir. So for power SPDs, unless the SPD turns to red, which is the FM contact or the relay contact gives you a failed indication, it can go for lifetime. In fact, I have inspected sites where our company has done the installation, which is almost 15 years old, and the SPD is still protecting. So for power SPDs, that is not required. There is no periodic inspection required. Once it fails, you can replace it. It can go for infinite number of times. Same as with the communication SPDs. For communication SPDs, as I said, you can have a prediction whether the SPD is going to fail. There are certain models available with this prediction technology inbuilt. So you can use those to see whether they are going to fail. But other than that, if everything is fine, the SPD can last an entire lifetime. It is not going to fail. The SPD typically fails when it is overstressed by any lightning currents which is higher than what it is designed for, or when some tampering occurs. But other than that, if you see the SPDs that actually done manufacturers are mostly heavy duty, so they will go for a lifetime.
Thank you.
Thank you.
Hello, this is Koti ADST. I have a small question related to DH and SPDs.
Okay, sir.
How best it is compared to remaining SPDs which are available in the market? Based on what parameter you can say your product is better?
Okay, sir. Thank you. Thank you. So, to give you a brief, sir, we are in this technology for 100 plus years, 110 years actually. This year will be our 110th year. So, our experience into this lightning protection is also quite large. Even if you see the 10 by 350 waveform was contributed to the electrical community by our R&D engineers, actually Dr. Peter Hussey. So our expense into R&D and to generate new product is very high. That is one of the things which have always separated us from our competition. Now coming to the technical topics. So one is proper rated SPDs. We only supply proper rated SPDs, and all our surge protection devices are tested by third-party vendors. We don't supply SPDs which don't have third-party certificates. So it is not that I am claiming that my SPD will perform like this. Other third-party agencies have also tested and verified this. The second thing is we only use mechanical indication in our power side SPDs. We don't have any LED indication or any unclear or illegible indications. Our indications are all clear. Our SPDs are all protected from fire, either through metal encapsulation, especially our type 1 SPDs are protected from fires using metal encapsulation, and we can limit the fault current in such a way that the nuisance stripping equipment is not going to be there. And that is because we have patented technologies like Radix flow technology and arc shopping technology, which none of our competitors can give. This is as far as the power side is concerned. Now, when we talk about the communication side, we have always used SPDs again tested as per IT or EX rated or any IEC rated or KEMA tested SPDs only or UL rated SPDs. That is something which makes the quality is something that makes us different. Another thing is we have a wide range of options. It is not that we have only products for certain applications. Even if you look at the railway application, we have SPDs which are rated from as low as 1 volt to as high as 1500 volt. So the range of products that we have is much higher compared to anyone. The experience that we have into this field is also comparatively higher. And if you see, we have certain innovative products like SPDs with preventive maintenance, like RFID incorporated SPDs for communication devices with life check, when the life of the SPD can be checked using testing equipment. We have also now created communication SPDs with remote monitoring. So these are some things which make us a class apart from our competition, sir.
No, correct only. Suppose if third party is going to test your SPDs,
yes, sir,
at your level. So
yes,
what
sir.
parameters they will consider while they are testing?
Yes, sir. So you are talking about the field testing for survival, or you are talking about
field testing for the survival?
Okay. So in the field testing, sir, each and every equipment is supposed to withstand a particular voltage. There has to be certain resistance for that. There has to be certain, say, voltage which it has to withstand. So what the testing equipment does is, for example, if it is a type 1 arrestor, most of the type 1 arrestors are spark gap in nature, and it tests whether this resistance of the spark gap is above a certain limit, and that limit is always mega ohms. So if that is the case, it means that the SPD has not failed. And if you talk about the communication SPDs, you have avalanche diodes and you have the gas discharge tubes. These are also required to have a certain resistance value and certain voltage withstand level. So we see what is the voltage that the current equipment is clamping at. So that is also tested. When we have metal oxide varistors in our equipment, we see what is the clamping voltage of this equipment. So this clamping voltage is important because, say for example, I have an SPD which is rated for 230 volt. The SPD might clamp at 1.1 times of the rated voltage. That is the maximum continuous operational voltage, which is 10% higher than the nominal voltage. So 230 volt equipment means it has to clamp somewhere around 255 volt. So if it is clamping at a lower voltage, or if it is taking clamping at a higher voltage, then it means that it is not functioning properly. So these are things which the testing equipment monitors, and that is already pre-fed with what should be the nominal values. And if it is above or below the nominal values, it will immediately give you a fail indication, which says that the SPD has failed, or the SPD is going to fail. This is how we do it, sir.
Okay, thank you.
Thank you, sir.
Manu, can you tell who are the certified agency, third party certified agency, who are all there?
Sorry, sir. Can you come again, sir?
Third party agency who are certifying your product.
Yeah. So then, sir. Yes, sir. So then products are certified by KEMA. Our products are also certified by UL. Some of the products are certified by UL. Mostly it is KEMA, sir, which is a third party agency.
Third party agency.
Yeah, it is a third party agency, sir. KEMA, KUR is a internationally recognized third party agency, just like a TUV, Railland, etc. So it is a third party agencies. And the products which are sold in the US market also, that is also tested with by UL, Underwriters Laboratory. So these are the two laboratories which test our products.
Okay.
No queries are there. We'll go for next presentation. Thank you, Manu, for your presentation.
Thank you, sir. Thank you so much, sir.
Types of SPDs, the issues related to the SPDs, and the solutions from your company. Thank you. Our next presentation is reliability improvement of telecom circuits by effective utilization of SDH by our SSC Tele Palani, Murli Krishna. Murli Krishna, please start your presentation.
Respected PCSC sir, PSC sir, PCE sir, other dignitaries in the screen, and my dear colleagues. Good morning to you all. First, let me introduce myself. I am B. Murali Krishnan, SSC Tele, OFC Palani sir. Let's move on to slideshow, sir. Here the topic I have selected for the presentation is reliability improvement of telecom circuits by effective utilization of STH in Madurai division. In this slideshow, let us see. In this slideshow, let us see the list of reliability works we have done in the Madurai division, sir. Just a list, we will see it briefly in the forthcoming slides. The short-haul protection for telecom circuits, unification of STH equipment over the division, rationalization of telecom exchanges, UTS connection over STH Ethernet port, old UT Sarcom STM1 equipment between Madurai VPT Tirunelveli is replaced by Tejas STM1 equipment for unification, 64 kbps data logger channel upgradation to 2 Mbps over the division, and other telecom improvement also. In this slideshow, we will see the short-haul protection pertaining to the telecom circuits. Already we have long-haul circuits. Normally, the long-haul circuits takes a longer path. Longer the path, actually failures also more. This is the case normally. This is the problem we have normally faced. One more drawback is if there is any failure or any issue we face in the long-haul circuit means we have to raise complaints to the RCL. They have to in turn attend the problem. And these shortcomings are avoided by configuring the short-haul configuration for all our telecom circuits. Actually, this circuit is configured, managed, and if there is any failure is attended by the railway itself, sir. That's the one major advantage we are deriving comparing to long haul protection. This short haul protection is possible due to unification of FTH equipment in major junction of the Madurai division, sir. In this slide show, let us see the protection path arrangement made for the TPJ control board connecting Madurai Dindikkal TPJ section. Here it has got three paths. One path, short haul protection path, connecting Madurai, Mana Madurai, Karaikuri TPJ, and two long haul protection paths. One long haul protection path, that is the RCL protection path 1, takes on the same cable as a working path, that's a Madurai Dindikkal section, but two RCIL nodes. The second path, RCL protection path, it takes on a longer path. Indeed, it's a very longer path. From Madurai, it travels via Koilpatti, Maniachi, Nagarkoil, Trivandrum. It travels all the way through Kerala, and at last reaches Ural TPJ. Actually, if any STM equipment, STM1 node fails between Madurai Dindikkal or Dindikkal TPJ, we got three protection. We got short haul protection, we got long haul protection path 1 and path 2. In case of any cable cut in the normal working path between Madurai Dindikkal or TPJ, we got two protection paths, RCL path 2 and the short haul protection path. This is a slide show pertaining to SNCP protection, sir. SNCP protection stands for Sub Network Connection Protection. This SNCP protection is for connecting two Mbps data routes. In this diagram, we will see two routes, sir. One working path, that's the upper path. One more path is a lower path, that is the bottom path, the protection path. In case of any failure in the protection path, in a working path, the traffic is switched over to protection path, sir. Let's see it in the forthcoming slide. Here actually we see the main working path, break in the main working path, the traffic is diverted towards the protection path. It is based on the alarm received by the SEH equipment, like all ones, loss of signals, like that, sir. In this slideshow, let us see about the network protection we are using in the railway. Normally, here we use two types of protection. One SNCP protection, another one MSP protection. SNCP stands for Sub-Network Connection Protocol. Another MSP protection stands for Multiplex Section Protection. SNCP protection is normally utilized in network topologies like linear, ring, mesh application like that. This is utilized in circuits like PD mux, voice, UTS, data logger circuits. Next protection is multiplex section protection. This is used for point-to-point protection. We are using this circuit for data networks and video conferences. Here let us see some features of SNCP protection. Normally, defect in the physical layer initiate this SNCP protection. Here actually we got a feasible assignment of protection. We may configure it for manual protection or automatic protection. Again, as said earlier, we can use this topology, use this SNCP for linear topology or ring topology or mesh topology. Again, we can use this SNCP protection to cover entire section or the part of the section. Again, we can use revertive mode or non-revertive mode. Actually, if working path is restored, if there is any cable path, cable cut is there in the working path, it is restored. If we configure the equipment for revertive mode, automatically after the restoration of cable in the working path, the traffic is switched over to normal working path. Here in this slideshow, let us see short haul protection extended to different sections of the Madurai division using SNCP protection. Here we see the normal protection path and the short haul protection path. Let's see one by one. First, Madurai TPJ. This is Madurai Dindigul TPJ. The short haul protection is extended via Madurai, Mana Madurai, Karaikudi, TPJ. Then comes Madurai Pollachi section. This is actually Madurai Dindigul Pollachi section. The protection path is extended via Pollachi, Pottanur, Coimbatore, Erode, TPJ and Madurai. Then we see for Madurai Karaikudi TPJ section. For Madurai Karaikudi TPJ section is protection path extended via Madurai Dindigul TPJ. Then we see the Madurai Tirunelveli section. For Madurai Tirunelveli section, the protection path is extended via Madurai, Mana Madurai, VPT, Tenkasi and Tirunelveli. Then for Madurai Chenkote section, the protection path is Madurai, Mana Madurai, VPT, Tirunelveli and Tenkasi. Then we will see the protection path arrangement we have done for this Mana Madurai and Virudhunagar section. That is now the link, that is for the link connecting Madurai with Narikudi. The protection path arrangement is done via Madurai, TPJ, Karaikudi, Mana Madurai. For Madurai, Mana Madurai MUX, the protection path is arranged through Madurai, VPT, Mana Madurai. Then again we will see the Madurai Tirunelveli, Tenkasi side. The protection path arrangement done via Madurai, Mana Madurai, VPT, Tenkasi and Tirunelveli. Last we will see for Madurai Rameshwaram section, it's a linear section. That Rameshwaram is a terminal station. The protection path arrangement is done from Madurai. It is extended to Thoothukudi. From Thoothukudi it is connected to Ramanad. From Ramanad it was connected via railtel node to Rameshwaram. This is the arrangement we have done in the Madurai division, sir. Almost all the sections we have protected in the Madurai division, sir, using this short haul protection. Now here in this slideshow, we will see the short haul protection arrangement we have done for PRS circuits of exchanges. To connect this Madurai, this Dindigul, that is normal path is Madurai, Kodai Road, Dindigul. The protection path is Dindigul, TPJ, Karaikudi, Mana Madurai, Madurai. For Madurai VPT section, the protection path is made via Madurai, Mana Madurai, VPT. Then for VPT Thoothukudi ERA circuit, the protection path is VPT, Tenkasi, Tirunelveli and Thoothukudi. Then for Madurai Karaikudi section, the short haul protection path is Karaikudi, TPJ, Dindigul, Madurai. Then for Tirunelveli Chenkote section, protection arrangement is made via Maniyachi, Koilpatti, VPT, Tenkasi. Here for VPT Tirunelveli section, we have arranged a protection path from VPT to Maniyachi. Again from Maniyachi to Thoothukudi is unprotected, sir. It takes on the same cable. Recently, we have augmented the bandwidth for railnet connectivity. 5 links bandwidth have been increased from 2 Mbps to 10 Mbps. Let us see the list of links. Madurai VPT, Madurai Mana Madurai, Madurai Dindigul, Mana Madurai Rameshwaram, Madurai Tirunelveli. And we have protected the circuit also, SNCP protection we have extended. Then for Chenkote Punalur section, TMS link, we have given the protection path given through Koilon, TVC, Tirunelveli, Chenkote. The control office application has been provided in 9 stations in Madurai division, namely for Rameshwaram, Karaikudi, Thoothukudi, Maniyachi, Tiruchendur, Chenkote, Madurai, Dindigul and Tirunelveli. Then we will see the protection path arrangement we have made it for Rameshwaram, Madurai, Rameshwaram section. Actually, this Madurai Rameshwaram section is a linear path. This Rameshwaram is a terminal station. We got actually protection for we got BSNL radio patching arrangement at Rameshwaram. Still, we faced a lot of problems actually. If there is any cable cut, occasionally we don't get the connectivity via BSNL. If at all we face some channel problems also. At last, we have we got one 2 Mbps connectivity, at least connectivity from Railtel, but it's again takes on the long path from Madurai. It takes the route Madurai, Virudhunagar, Maniyachi, Thoothukudi. From Thoothukudi via one roadside route via Sayalkudi, the feed is extended to Ramanad. From Ramanad, again the connectivity is via Railtel node. It reaches Rameshwaram and get connected to the MUX. This is the protection path arrangement we have done for Madurai Rameshwaram section, sir. Here in this slide, let us see the different STM equipment and the BSNL radio patching arrangement we have done in Madurai division, sir. Actually, if you see, except Madurai, Manamadurai, Ramanad, Rameshwaram section, all the equipments are Tejas only. This Madurai, Manamadurai, Ramanad, Rameshwaram is the FIFCOM equipment. Again, except this Dindigul, Palani Pollachi equipment, Dindigul, Palani Pollachi equipment, we got STM4 equipment. Rest of all the equipments are either STM1 equipment or STM16 equipment. We got 4 radio patch, BSNL radio patch arrangement for control circuit from Madurai to different locations, namely from Madurai to Thoothukudi, Madurai to Punalur, Madurai to Tiruchendur, and from Madurai to Rameshwaram. In this slideshow, let us see the rationalization of telecom exchanges. Actually, recently we have released one exchange in Koilpatti. It has got around 25 numbers of auto numbers. Those auto numbers are now extended from some numbers we have extended from Virudhunagar and some numbers from Thoothukudi. Here actually we will see some advantages we have derived from rationalization of exchanges. Koilpatti exchange released by rationalization of telecom exchange. Existing Koilpatti exchange auto numbers were given through Thoothukudi and VPT exchange. AMC and staff movements were avoided. Exchange cards like analog, PRI, power supply card, and subtract are kept as a spare. As per telecom time target in Madurai division, we have identified 13 UTS location and we got approval from PCM also for converting this UTS location, for connecting this UTS location over Ethernet port of SH equipment. The 13 UTS locations are namely Kudalnagar, Tamenallur, Kallikudi, Tirupachetti, Vadipatti, Narikudi, Tirucholi, Megalakondakulam, Anangudi, Kallal, Chettinad, Bellalur, and Kiranur. These we have already shifted this location to Ethernet port of SH equipment. Then in this slideshow, let us see the circuit diagram. This connectivity diagram we have done for UTS circuit. The connectivity diagram is from Ethernet card of STM port is connected to 24 port manageable switch. From 24 port manageable switch, it was connected to thin client using Cat6 cable. This is the connectivity diagram for extending with the UTS circuit over Ethernet port of STM. Here in this slideshow, let us see the advantages we are deriving by extending UTS circuits over Ethernet channels. Routers, modems of UTS circuits can be eliminated. UTS circuits failure due to routers, modem can be avoided. Annual maintenance cost of router is eliminated. 9 BSNL channels are surrendered and 27 railway channels eliminated. Here let us see the other telecom improvement works we have done in Madurai division. The outdated UT Starcom SM1 equipment in Madurai VPT Tirunelveli section is replaced departmentally with the Tejas Make SCH. 64 kbps data logger channel is upgraded to 2 Mbps bandwidth level over Madurai division. Madurai, Dindigul, TPJ, Koilon, Punalur, STM1 equipment is upgraded to STM16 from STM1 and PDM access are provided. CCTV camera, Wi-Fi are installed and commissioned at the Railway Hospital, Madurai and other health units. Other telecom improvement works done. CCTV cameras are provided at SM rooms in different stations like Punalur, Rajapalayam, Tirumangalam, Sattur and Koilpatti station. Due to COVID-19, contactless ticket checking system provided at Dindigul, Madurai, Virudhunagar and Tirunelveli. Contactless patient identity verification and guiding system is provided at Madurai Railway Hospitals. 9 numbers of unused VHF towers are dismantled departmentally over the division. The Tata Trust has provided 38 numbers of Wi-Fi connectivity in Madurai division. COA central office application is provided at 6 stations. SLT office files 285 number scanning work was done departmentally for e-office purpose. Due to in the wake of COVID-19 diseases, we have installed some systems for commercial department people and medical department people. Here in this slideshow, let us see, we are seeing some systems installed in Dindigul, Madurai, VPT. This system is for contactless ticket checking system. Here we see the contactless patient identity verification and the guiding system provided at Madurai Railway Hospital. Actually, we have dismantled all the unused VHF towers over the Madurai division. Here actually we see one antenna, one VHF tower dismantling. In the right side figure, we find the antenna. In the left side figure, we don't find that antenna. That was dismantled departmentally. Thank you, sir. Thank you very much for this opportunity.
There is a query from PCST, sir. Why not why 24 port switch for UTS changeover? Why not 24 port switch?
Huh?
There is a query in the chat box from PCST, sir. Why you have used 24 port switch, sir? UTS circuit changeover. Why not 12?
Sir, actually, we have used 24 port switches. It was ordered for all the stations, but actually, as you said, it's not that much ports we don't require, sir. Even if you have that 8 port switch, that's sufficient, sir.
Two ports are sufficient. Only one port you are using.
It is the existing switches, sir. I have not changed anything. Only existing switches they utilized. That is for replacement of some other switches. But 24 port standard configuration, 12 or 24 with NMS manageable switches.
No, when we don't require that much, directly, actually, in fact, switch itself may not be required. Even STM board directly, you can give it to the PC directly. That also may be possible. You think of it.
No, sir, we want to extend to other side of the equipment. Suppose we have to, from a switch, we are extending the feed to next station, sir. So actually, switch is a must, sir. We can't avoid the switch there. Minimum 2 ports we require, sir, for connecting both sides of a station.
Look at minimum configuration. That is what I am telling. Look at minimum configuration. Why
Yes, sir,
to go
that's
for
right, sir.
a big system? Right. Okay. Good.
Think it over that, sir.
But
then, what is our plan of action to completely do? Madurai has taken breakthrough. You have introduced, you have removed the G703 V35 at some places. Why don't you do at all places? Uniformly.
Excuse me, sir. Once more, sir.
You for UTS, why don't you remove at all places G703 V35 and give Ethernet directly? Like what you have done?
Sir, we have just started the work, sir. It's the initial work, sir. Starting work. We are in the process of proceeding, sir.
Suman, you can answer this question, yeah.
Sir, actually, Ethernet cards in all the SDH is not available, sir. So We'll procure those cards, sir, and we'll do it, sir.
Okay, sir.
One more question from my side. These all short all, third short all and all you provided. Are you all the changeover is being done manually or it is automatic?
For control circuits, we are doing it for manually, sir. For rest of the circuits like data log or these circuits, it will that will be switched over automatically, sir.
Changeover
We have five. Sir, pardon me, sir.
All the three roads, sir.
Yes, sir. It was regularly monitored by the test room people, sir.
Please check because I am not sure. It is normally two paths it will be changeover automatically. Third path will be manual only. It will be done unless it is done within the SDH itself. Okay, that you can you check it up. Third one is
Okay,
about
sir,
the exchanges. What you connected through your separate protection. Whether you can explore the possibility connecting to GPL. MPLS route, this one, wherever the Railtel is providing MPLS, if connected, then it will automatically take over. Just the PRA connectivity. For PRA connectivity, you can go for MPLS connectivity. You can check up whether you check digital ports is possible to do it or not.
Yes, sir.
Okay. Okay, sir. We'll do it, sir.
Then are you going to surrender any BSNL circuits?
Sir, we have surrendered a lot of BSNL circuits. We are left with only 4 BSNL circuits for control purposes, sir. After unification of equipment, we have surrendered 9 BSNL radio patching circuits. We have maintained for UTS circuits, sir. Apart from that, we have removed some 26 railway circuits also.
Whatever that BSNL circuit you are having, try to change over to E1 level instead of system.
Okay.
That can plan, and wherever the ring routes are there, you have to invariably surrender all BSNL circuits.
Okay, sir. Okay, sir. Thank you.
Okay, that's all from my side.
Just one question from my side is why is it that you've provided a switch at the end of the UTS? Why don't you look at providing a switch at from the STM equipment which you have instead of providing individual switches at all these stations, you could have directly connected them to Ethernet ports at all these stations and provided at the switch at the central end.
Yes, sir, we can connect, sir. Again, we have to extend it to the opposite side also, sir. Actually, we are getting feed from one end. We have to extend that feed to other end also. So, mandatorily, we require a switch, sir. It may be the minimum ports. We can go for even 4 ports also.
So, essentially, what you are saying is you've taken the uplink port and the downlink port.
Yes, sir. Yes, sir. Uplink port and downlink.
UPS. Is that correct?
Yes, sir. Right, sir.
So that way you economize on the bandwidth, right? Okay.
Yes, sir.
Because the other option is you provide the switch at the centralized end, provide individual Ethernet ports to all of them.
So just like connecting star topology.
Yeah, exactly. But then I think you would have occupied more bandwidth. Though bandwidth is not a constraint per se, but then it's an optimized solution.
But that's also fine, sir, because here in this topology, linear topology, if any switch failed means we don't get the other part of section goes unget, sir. But if you go for star topology, even one circuit fails also, in the rest of the circuits, it will be in working condition, sir.
But then why don't you look at that? You'll be economizing on so many switches.
Okay, sir, we will discuss it, sir.
Yeah, you can discuss it. Anyway, excellent work is being done. This is something I've been trying to pursue for quite some time. It's good to see that it's slowly fructifying because initially Chris said no, Ethernet technology can't be adopted. So now I think we should aggressively pursue this course and start replacing all your PRS circuits also onto this.
Okay, sir.
Look at a star configuration basically because bandwidth is not a constraint, more so because we've installed STM4 or STM16.
Okay, sir.
Okay, right. Thank you.
Okay, sir. Thank you. Thank you for this opportunity.
Excellent work done. Excellent work done. Madurai division.
Thank you, sir. Thank you,
I
sir.
suggest you basically make out how much money you save in terms of the amount of equipment released because of all these optimized steps, and also
Thank
the
you, sir.
cost in terms of AMC for all these equipment. We'll work out, sir. That will be
Okay,
a
sir.
better
Okay,
way
sir.
of gaining the attention of the management.
Thank you, sir.
Thank you.
On the brief of
Only releasing, replacement will not be done. Actually, replacement will not be done, though all these equipments are overdue for replacement. Okay.
Okay, sir. Thank you, sir.
Thank you, Murli, for nice presentation. And
Thank you,
measures
sir. Thank you, sir.
to improve the reliability of telecom circuits for Madurai division. Sir, we have come to the end of first session, sir. We will break for lunch, sir. We meet around, as per schedule, we have to meet at 2 o'clock, sir. We will meet around 2:15, sir.
2:30 make it here.
2:30 we will meet, sir.
Thank you. Let us meet at 2:30. Thank you. Thank you.
Yes.
Thank you.
All the best.
இல்ல பாப்பா நம்ம எதுவுமே ஸ்பீடா ஓட்டிட்ட மாதிரி கத்துது நல்லா
Hello, good afternoon. This is Krishnakant. Can you hear me? Can anybody please confirm with my audio? Hello, can anyone please confirm my audio? वो लेकिन इधर कनेक्शन करो, अगर इमरजेंसी लगा तो यहाँ से मैं यहाँ कनेक्ट करूँगा। Hello, Bhushan, can you hear me?
Hello, Krishnakant. Hello, everybody.
Okay,
Good
okay,
afternoon.
yeah. Actually, all are on lunch break, so
Okay.
meeting will start at 2:30. So just before that, I just want to check that I'm trying to share the presentation, okay,
Okay, fine.
and also the video. You can see that a corner. Can you see one video and presentation both? Okay, I'm just trying. First, I'm switching off the video. Okay, can you see me?
Yes.
Okay, now I'm sharing the presentation. Okay. Now, can you see me and the
Yes,
presentation both
present.
and
Yes,
the
both the things.
video also? Okay.
Yes.
So I
Yes.
will share the presentation screen then. Okay.
Okay, fine. No worry.
So that it will have control.
Just
So we'll
full
wait.
screen that presentation. Okay, not in the
1 minute.
slideshow.
Yeah, yeah, yeah. Okay. Now it's proper.
Wait. Yes, yes. Just keep
Uh,
it as it is. Yes.
yeah. Slides are changing.
Changing. Perfect.
Okay. Thank you. So we'll wait for 2:30. Okay. Then
Okay.
I'll keeping on the mute now.
Yes.
Thank you.
Good afternoon, sir.
Hello, good afternoon, sir.
Good afternoon.
Sir, shall we move on to second session, sir?
Start.
The first presentation is from R. Krishnakant. Is product manager at Siemens. This presentation is on insight into Siemens make axle counting system. Krishnakant, you can start.
Good afternoon to everyone, and I would like to thank PCST, CSC, all the CSTs and the senior DSTs, and also special thanks to senior DST Mr. Suman sir for giving us the opportunity to present ourselves on our product, that is Siemens Make Excel Counting System. Thank you so much. So let's begin with our presentation. I'll just share my screen over here. Myself is Krishnakant Rokedi, and I am the product manager for ACM 200 product, that is Excel counting system. And I have my colleague Mr. Bhushan Tongle, who is a development manager who looks after the development of this product. So Bhushan, you can
Hello,
introduce.
everybody. Good
Yeah.
afternoon. Sir, myself, Bhushan Tongle, and yes, I am looking after this Axle counter products, that is SCM 200 as well as the old one SZS 350U. Yeah, Krishna. King.
Yeah. Hope Bhushan, you can see my screen that I have shared now.
Yes.
Yeah, it's coming.
Please.
Okay, thank you so much. So let's begin with our presentation. So before starting with the presentation, I just want to say that we are the pioneers of the Excel counting system in Indian Railways from last 15 years. And we have an install base of 8,000 detection point all over the Indian Railways in the various zones. But today, I will introduce with the next generation Excel counting system, which was RDSO approved 2 years back, and we have started supplying this product, and we have already started our installation base mostly in the Southeastern Railway and the Chennai division, which we have recently got the tender. We're supplying this kind. So here I will provide you with the key benefits of my product, the system overview, and what are the different advantages, and mainly I will also discuss on the different application, on what application you can make use of this product, and you can tailor as per your requirement this product. Okay, so this is my today's agenda. So where else, as I discussed, I will describe about the overview, indoor and the outdoor system, and our first field trial, the maintenance, and the overview of the system benefits. So Siemens Excel counting system is offers a high level cost effectiveness. The cost effectiveness, I said, because as you can see in the photographs, this is my indoor equipment ACM 200 module. It is a stand-alone, a single module. There is no need to maintain any spares. That makes my system this very cost effectiveness. Availability, it can be used in various applications, IBS, yard, and auto sections, and any kind of application which you want to make for the track section, track vacancy reduction application. And it's a future-proof technology. I said we are the pioneer in the all of the globe from last 25 years, and in India we have pioneer of the 15 years. So which is it's a future-proof technology. So it's an automated track vacancy system for point, track, and all kind of six sections. So these are the photographs which just to analyze this. This is my indoor equipment, a single module which you can see. I will discuss in detail in the presentation slide. This is my outdoor equipment, and this is my diagnostic purpose, what I am trying to show, that the smart diagnostic which I am trying to show. So moving to the next slide. So globally, we have a install base of modules of 9,200 and detection point of 36,000 of this product. And we have a base of 110 worldwide countries. We have a strong base for this product, ACM 200. So this was our install base. So now coming to the main part of the presentation. So as we all know that the principle of Excel counting system. So here I will explain about my product over here. The we at the outdoor we have a electronic junction box and a rail contact, and the indoor we have a ACM modules. So the each counting head or the detection point comprises of a double wheel detector, that is a sensor which is connected to the rail, and these signals from the axle will be passed from this electronic junction box to the ACM module via 2-core cable only. So we required only a 2-core cable with a control distance of 4.5 kilometer to my evaluation computer. So this evaluation computer will generate the axle counting data from the wheel, compare the in count and the out count, and it will issue a track clearer occupied. So this is the indoor and the outdoor basic configuration which I have showed before starting coming to the of my main product. Bhushan, I think the slides are going well and my audio is clear to you.
Yes, yes.
Okay, thank you. So these are the ACM 200 module, the key benefits. So as you can see, this is the ACM 200 module, a single stand-alone automation kind of module. So one single module will comprises your 2 track sections and 2 DP. So it can configure, we can configure directly with the 2 track and 2 DP, but it can be easily cascaded with another module via Ethernet based industrial gate via cables with the wire switches, and it can be configured and it can go up to 200 detection point, 300, there is no limit. So coming to its main key benefit, yes, it is a modular architecture. Why I'm saying it's a modular, it is a standalone and it can be easily fit on a DIN rail, and due to this very there is no different cards in this. For example, there is for the communication function there is another card, for the DP transfer there is another card, there is no kind of any card, there is only a single compact module with this robust housing, and it can be easily installed on a DIN rail. So there is this minimize your commissioning points also and during failures also. It's a modular because it can be tailored as per your requirement. As I said, is a easy extension and modification, and ensures the investment for security to comes to you. As I said, for the communication from modules to modules, we make use of standard industrial components. So here you use the switches, the Ethernet cables, everything is an industrial automation modules and the other components which you can. It is independent with my particular Excel counting system. You can make use of any switches, any modules. And the power supplies, if you want to, you can use any kind of power supply modules also in this case. So you have a very low spare with regard to the Excel counting modules with the cards out. As I said, there is only 2 wires between the ACM to our outdoor unit, so low investment cost in that also, which we take with the cord cables. The main benefit of this is it has an integrated website. So whatever the configuration loading, no need to open this housing or do any kind of manual. It's a very simple HTML plug and play graphical user interface where you have to just click just very simple configuration, how many track session you have to take, and with this with this website you can do the configuration, you can do the diagnostics, all data will be stored. Wherever there is a failure, it will with regard to track clear or occupied, miscount, or what had happened with the communication, with the time stamping, it will show. So I will discuss in detail in the further slide. This is just a key benefit. Another benefit of this module, you have a ID plug over here. So each ID plug has a IP. So with this IP, if you put in your after setting with the internet, if you put in Internet Explorer of that IP, you can see all the configuration of that particular. The main benefit of this, suppose all the configurations are stored in this software. The ID plug has its own software. It will be stored in this ID plug. So whenever there is a failure, no in the module, no need to again change the configuration particular that module. You have to just uh, remove the ID plug and have to reinsert with the new ACM module. Wherever the module you have replaced, you have to just put just a plug and plug out play, you can say. So this minimize the failure time drastically, no need of configuration again. So this makes the another big advantage for this standalone single module of ACM 200, which is we call as Excel counting module 200. So these are the various components. So as you can see, there are only, I can see there are only 2 components here. One is module and one is ID plug. This ID plug is inserted on this is ACM 200. So these are the only two modules which we can see it is dependent on the Excel counting of Siemens. Rest all other wirings, the industry, everything, the switches, the Ethernet, the communications which is going, everything is industrial grade and it can bought out from the market, the other industrial graded which we recommend. So there is no dependency on what we for the Excel counting you have to buy us from this so and so. So there is very low spare parts you have to maintain. The only the module in the indoor part and the ID plug you have to maintain. So this minimize the hardware requirements in our Excel counting system. So that was the overview what I have made in the indoor. Now coming to the outdoor part. So outdoor part have a electronic junction box. This is my electronic junction box and this is my rail contact. Contact will consist of transmitter and the receiver. I will show in the further slide how it is installed. And each electronic junction box consists of one single stand alone PCB which is dual channel. It is the both the pieces has a replica inside it. So the main advantage of my existing system to the coming to the new system, whatever the signals which are coming from the axle to my electronic junction point, it's we are having a DSP, digital signal processing. All the filter has been done and then the signals are passed into your evaluator. This is the main. Whereas in the system, all the analog systems were passed to the evaluator. Evaluator will do the digital signal processing part and filtration. But here, all the signals will be processed at same at the location and it will be sent to the evaluator. Evaluator will again filter it. Then it will give the track clear or occupied to the interlocking system. So this is the main advantage. Going ahead, so this is my installation. So we provide a wired cabinet. So whatever the installation which we do, the wiring, everything is done in the factory. Recently we have supplied some cabinet to the Chennai division where all the same product with the same product, and we have designed the pre-wired cabinet as per the customer requirement. So we take the customer requirement, we do everything finishing and the polish work at our location and we send to the site. So this drastically reduces our installation time and gives the quality product with the quality installation with the quality product it is. So each cabinet consists of 15 modules. We can
तुम्ही ज्या
accommodate
व्यक्तीशी
like
बोलत आहात
15
त्यांनी
modules.
तुमच्या कॉलला होल्डवर ठेवला आहे. कृपया लाईनवरच राहा. The
Hello?
person you are speaking with has put your call on hold. Please stay on the line.
Hello? Bhushan, can you hear me?
Yes, I think there is some disturbance. Please go ahead.
Can I go ahead?
Go ahead.
Okay, sorry to interrupt. Each cabinet consists of 15 modules. So these 15 modules will accommodate 30 track sections and 30 DP. So you can imagine that if you have a one small yard, if you consider, that is you can accommodate easily with 30 track sections, which is I think it's a very large number with a single cabinet of 600 mm by 600 mm space. So in so these modules of the modules which we have got, it is very requires also very less space at your end also. So coming with the characteristics part, I will not take much of the time. I will share the presentation slides to whoever they can just text me. I will share the presentation of this. So I will not take much time on this. Yeah. So this is the characteristics. As I said, this is a system component. It consists of module, the outdoor unit, switch, power supply, the trackside connection box, and it can be application. It can be used for the mainline, branch line, station lines, and all kind of it is. It can be tailored anywhere and can be. It has a very wide range of applications. So coming to the characteristics part, as I said, my module has a ID plug. So this ID plug can be configured for the oscillation or it can be configured for the track section. It is very easy to install, and the configuration data from one ID plug to another module can be just easily quickly exchanged and can be easily transferred. So it had a Ethernet interface with the each module. As you can see, the Ethernet interface, standard Ethernet interface for the connection of the data exchange between another modules and for the diagnostic purpose. And this product is a seal 4 RDSO approved and fail safe. All the seal 4 criteria has been met, and the product has been introduced globally. So installation by locking, just you can see there is a locking arrangement over here. You have to just take it and you have to just put in the dindle. Very simple and quick, reduces the commissioning time. Automatic adjustment you can do. The outdoor DP can be automatically adjusted by this easy change of direction. If you want to install your DP from one rail to another, you have to just press buttons over here. That's it. No need of any additional configuration or a complicated configuration you have to do. The easy module replacement, as I said, and the advantage over here is the power. The module can be replaced with the power on, so no need to switch off the supply so that another modules will get interrupted. Whatever the module has fed, you can, being the power supply is on, you can just remove the module and can replace. That means the module can be replaced in under operation also without interrupting other modules. And another advantage over here is, here we are not required any kind of power supplies like we do have for existing system. We have a separate power supply which you for the supply of the for the working of my system. But here there is no need of, it is a standalone system. The power supply can be made available directly from your IPS which you give for the other signaling gears. So no dependency of power supply. So as I said again, Axle counter depending if is only for the module and the ID plug, which you have to depend upon the Siemens. All other things it can be available industrially in the market, and it can be available at your place. There is no dependency on our product. So this is a simple configuration in the cabinet, where I can see in the one row we can column we can have a 5 ACM modules, and the wiring has been done. So it is a pre-wired configuration which we do at the site. So this is the outdoor equipment. So that was the indoor equipment, and I now shifted to the outdoor equipment. Let's see. This is the outdoor equipment. That is a rail contact. I say this is a transmitter which is installed at the outer rail, and the receiver is installed at the inner rail. So this is electronic junction box, and inside we have a electronic PCB. So this is a function principle. Actually, there is an electromagnetic field which is generated at both the transmitter and the receiver, at the loop 1 and the loop 2. When there is an axle, there is a flux will be generated between this electromagnetic field. With this flux there is a induced voltage, and this induced voltage we have some threshold. By this alternating effect of the alternating electromagnetic field of the transmitter, the wheel is getting detected. So it is basically the, when the axis is there, the voltage get increased to particular threshold, and that too only with the particular wheel. We have a trolley separation with that particular dimension, the wheel will not get detected, because that wheel will not reach to that threshold. So the threshold which we have maintained, it is standard axle which used in the Indian Railways. So these are the characteristics, the product detail. It can we have a different kind of outdoor unit, the standard usage, and if the distance, as I said, the distance from the indoor to outdoor is 4.5 kilometer. The 4.5 kilometer, 6 kilometer also it can be extended. And if you go above 6 kilometer from relay room to the last DP, you may require the double usage, that is external supply, or the double external supply, that is you have to give the external supply to the DP, and it can be go up to 21 kilometer, or it can be keep on extending by giving the supply more than 6.5 kilometer. So another variant we have, that is a double usage. If suppose there is a 2 station and I want to communicate that particular sensor to station A and station B, I can make use of common DP which can transmit the signal from station A also station B. So there is no need of additional DP, the isolation DP from station A to station B. So there are 3 variants: standard, outdoor, standard electronic junction box, double, and the external. For the various customer requirements, supply this. So these are the key benefits. It has a very wide range of, it is independent of the rail profiles, detection of wheel with and without flea, no influence by the small metallic, it is not so sensitive, it will be detected by the particular threshold which we have set for the rail axle, and it will trolley will be suppressed because it will not into particular that threshold. It is a flexible, it is a temperature of -40 to 80 degree. It can work in snowy, humid and the flooding condition. Just Bhushan, is my audio clear to you and the slides are moving? Just to confirm from my end.
Yes.
Okay, thank you. It has a integrated over voltage protection. So in this you have a inbuilt voltage protection, and sensors are also very high mechanical stability, not prone to vibrations, and very low fault liability. As I said, the same, the high mechanical stability, easy handling, it can be done. And the main advantage over here is the maintainer has no need to go with a particular card or particular equipment to the EJB. He just had to, for the calibration, he had to just press two buttons on the PCB. After pressing this button, the ZPD43, the outdoor unit, it will be auto calibrated. The whatever the readings are there, it is auto calibrated, and you can check in the diagnostic PC that what readings I'm getting. So no need to have any kind of special equipments or the meter you have to check over there. And that the another benefit of this compared to my existing system is, if suppose the period of time of 2 months, 3 months, and due to some external interference and my values get low, the values will automatically go to the threshold. So this, it is so smart and intelligent EJB, it will always try to keep all the electrical parameters of order at its threshold level only. So this is the another advantage of the outdoor unit. So this is the sensor installation. The transmitter will be installed at the outdoor and the receiver will be installed. And between those, to avoid some eddy currents, make use of this reduction plate to avoid kind of electrical interference to the sensor. So this is the site picture. As you can see, we make use of deflector plates, and this is the sensor installation arrangement, where you can see the inner side is the receiver and the higher side is the transmitter. So as I said, the calibration can be done. The DP is changed from one rail to another. It can be directly done by pressing these buttons. So no need of any complicated. And this is the calibration buttons, which I said, by pressing these two buttons at the outdoor PCB, your calibration or your electrical parameter, and if you're installing the first time or you're changing the sensor from one location to the location, you have to do this kind of calibration where you have to press the and this is the two-way. One person has to be there at the indoor and the one person has to be there at the outdoor, and both the communication should be there. This is because for the safety reason that another person cannot come and have to press it. So there is a two-way communication at the simultaneous operation going between indoor and the outdoor, and the calibration is performed within no period of 5 minutes. It will not take more than 5 minutes. So this is the installation base of the outdoor unit. We have more than 30,000, that is approximately at today's date we have 36,000 outdoor units all over the globe. So that was my system overview, the outdoor unit and the indoor unit. So not taking much time, I have only few slides. Before that, I just want to go with the applications. So what kind of application we provide and what we are providing today in various zonal railways. They have various requirements that we need a OFC communication, we need a resetting from the OFC, we need a station master, and we need a modules at the OFC hut. All kind of configuration we have come through, and we have met all these configurations. So I just want to share this kind of applications so that even we are aware, and if any doubts we can have so we can ask any doubt with this in our question and answer session. So this is a yard application, as you can see. So this is a yard, and this is my outdoor unit, and this is my indoor unit. And suppose I have a in the yard, for example, there is a very big yard, and I have a east Gumti and the west Gumti and we have a central. So I can have a distributed system also, and I can also have a
तुम्ही ज्या व्यक्तीशी
centralized
बोलत
system.
आहात त्यांनी
Okay.
तुमच्या कॉलला होल्डवर ठेवला आहे. कृपया लाईनवरच राहा. The person you are speaking with has put your call on hold. Please stay on the line. आप जिस व्यक्ति से
You
बात
can hear
कर
me?
रहे हैं उसने आपकी कॉल को होल्ड
Yes,
पर
I
रखा
think
है.
there is
I
some
can
issue.
hear
लाइन
that
पर
there is
बने रहें.
something the person has kept me on
तुम्ही ज्या
hold. I can
व्यक्तीशी
hear.
बोलत आहात
Yes.
त्यांनी तुमच्या कॉलला होल्डवर ठेवला आहे. कृपया लाईनवरच
I
राहा.
was just
The
confused that
person you are
my
speaking with
presentation was
has
kept
put
on
your
hold.
call
So,
on hold. Please stay on the line.
No, I think it's a problem from some of the users.
okay, no problem. Suman sir, can I go ahead? Is it clear? My voice audible?
Yeah, please.
Go ahead, go
No,
ahead.
I think the administrator can mute the other microphones.
It's okay. I'll just continue. Yeah, thank you. Yeah, thank you so much. Yeah. So as I was discussing about the yard application, and I have a yard, and it's a very big yard. It can be done with the centralized location also. It can be done by the distributor. And if you want to save the cord cable, many railways are going distributor system because you don't want to lay a cord cable from central equipment till 4.5 kilometer, and you don't want to lay that. So in that case, you have a west gumti or the east gumti, or you have a hut. So what I do, I install this kind of modules at the west gumti and the east gumti, and I can make the 100-meter or a 50-meter tailpiece cord cable. I'll connect it, and whatever the signal is coming will be stored in this module, and this can be directly communicated via OFC or via cord. um, Majorly nowadays all the zonal railways are asking the OFC, so we have a OFC converters which convert Ethernet to OFC. So we have a modems which we supply, and this modem will transfer these modules from the west or east gumti to the centralized, and the resetting can also, the resetting information, the track section information, everything can be done. So what I said, the application which is there in the yard, and whatever the requirements you have, we can alter, we can customize. It is very as I can say, this module is very open to your customization. We can customize in any form of way with the use of various industrial grade components, with the help of converters, the modem converters in today's date we can combine this, because the main advantage over here is because I am using a standard in Ethernet interface. This is the main reason I can communicate with the converter of the third party, like a big company like Moxa or any other converters. I can communicate and I can fulfill your requirement. So this is my yard application. As I said, this is a distributed ISO, and if you want to centralize, then there will be only a single modules which you will install in the relay. Moving ahead, so this is the IBS application. So as there's a very huge requirement in the southern railway of the IBS. I have submitted these schemes also in the CSE office. So I just want to discuss this. So in the IBS application, we have a distributed and we have a station to station communication. So nowadays, many railways are going to the distributed because they don't want to lay in order to, we have to save the cord cable. So in order to save the cord cable from, they don't want to lay the cord cable from station A to station B. In this case, what I do, this is the scheme which we are going to execute in the one of the south, I think Gudur station. We are going to execute, and work is under progress under RVNL. So what we have done, we have installed the some modules of the IB hut which are controlling. This is a dual IBS section. So we have installed few modules at the IB hut, and the tailpiece of 100 of 50 meter of 150 meter is laid between this IB hut. And similarly for the station A, some DPs are controlled and at the station B. By this distributed architecture, I am fulfilling the IBS application, whatever the resetting function from station A to station B as per RDS, everything is fulfilled. And by this customization, I am also making use of various converters, the ring network. If one communication fails, there are A, B, C, the ring network I have created. If one communication or one switch fails, I have a redundancy over the switches also. If one switch port fail, another it will take from the other port. So there is a redundancy in the communication, there is a redundancy in the modules, there is a redundancy in the outdoor unit. So this is the compact customization which we are doing, and it also saves your cord cable. This is a major advantage on this distributed kind of IBS application. So another, we have a standard base of IBS application where we install the modules at the both the stations, and no need of installing any kind of modules. And there is a cord cable till 4.5 kilometer, and another stretch 4.5 which completes your 8 kilometer. And communication can be via cord cable. And another uh, scheme which is showing it's the same, but the communication is the auto changeover. We have done this in the auto section of the Tiruvattur and Ennur section, where we have used a auto changeover equipment, where it will auto changeover from cord to OC also. So this kind of arrangement. So there are different various kind of schemes it is available, and the main thing, it can be customized as per your requirement. So these are the application. This is standard auto signaling application, and we have already done application in the Chennai division, Trivatu, Ennore, and the various sections in the Chennai divisions. So this is depending upon the tail cable we distribute at the various location, evaluators and
तुम्ही ज्या
resetting
व्यक्तीशी
and
बोलत
everything
आहात
can be
त्यांनी तुमच्या कॉलला
communicated.
होल्डवर ठेवला आहे. कृपया
So these are the
लाईनवरच
three
राहा.
applications
The person you are
which I
speaking
have
with has put
discussed,
your call on
that is
hold.
yard,
Please stay
IGS
on.
and
आप जिस व्यक्ति से बात कर रहे हैं उसने
so
आपकी
next
कॉल
we
को
have
होल्ड पर
inspection
रखा.
and the maintenance. As I
कृपया
want to
लाइन पर
mention
बने
over
रहें.
here, my product is so
तुम्ही
robust over here, so you can very
त्यांनी
minimal
तुमच्या
kind of maintenance.
कॉलला
As you can see,
होल्डवर
the
ठेवला आहे.
outdoor equipment interval period is only just 12 months,
You are
whereas the
speaking with
grounding
has
equipment,
put
the
your
cabinet
call
is
on
24
hold.
months.
Please
So the
stay
interval
on.
months of the maintenance
आप
is
जिस व्यक्ति
very
से
low
बात कर
over
रहे
here.
हैं उसने आपकी कॉल को होल्ड पर रखा है. कृपया लाइन पर बने रहें.
So this is the diagnostic feature. So as I
त्यांनी
discussed,
तुमच्या कॉलला होल्डवर
there is
ठेवला
some
आहे.
disturbance over here.
कृपया
Please wait for
लाईनवरच
half a
राहा.
minute.
The person you are speaking with has put your call on hold. Please stay on the line. आप जिस व्यक्ति से बात कर रहे हैं उसने आपकी कॉल को होल्ड पर रखा है. कृपया लाइन पर बने रहें. तुम्ही ज्या व्यक्तीशी बोलत आहात त्यांनी तुमच्या कॉलला होल्डवर ठेवला आहे.
I think calling user 4. Who is calling user 4 can be muted.
आप जिस व्यक्ति से बात कर रहे हैं उसने आपकी कॉल को होल्ड पर रखा है. कृपया लाइन पर बने रहें.
Audio call is coming, I think.
तुम्ही ज्या व्यक्तीशी बोलत आहात त्यांनी तुमच्या कॉलला होल्डवर ठेवला आहे. कृपया लाईनवरच राहा. The person you are speaking with has put your call on hold. Please stay on the line. आप जिस व्यक्ति से बात कर रहे हैं उसने आपकी कॉल को होल्ड पर रखा
Who
है.
is calling user 4? Who is calling user 4?
त्यांनी तुमच्या कॉलला होल्डवर ठेवला आहे.
Lateral response.
This calling user 4, how it has come? This calling user 4, how it has come? So you just check up.
Yes, sir. Now
Like such people should be banned. How calling user has come, man? Right now. So you just check up. We should be able to find out and then just remove them. Okay.
It is audio call, I think.
Continue.
Suman, it is audio call, I think. Just to check up that.
No, audio call cannot come in this.
Come, sir. The dialing is there. Dialing is there.
Dial-in, you people don't give facility for dial-in. Such conferences, we should not give dial-in facility. Okay, that should be banned.
We can log the presentation.
No issue. Continue.
Sorry to
Someone
yes.
lock it.
sir, actually control is at Chennai only, sir.
Who is having the control?
No, okay. You continue with the conference. Later on, we will discuss and finally the scheme.
Yes. Bhushan, can you see my screen, the diagnostic via website, and am I audible to you? Thank you.
Yes.
So now, just coming to an end of the slides, I have just want to share with you the diagnostics, the main part of this Excel counting system. We install the maintenance part. So we have a very high end of diagnostic. First, we have a local diagnostic website where you have to connect a Ethernet cable to the ACM module, and it will be connected to the it can be connected to your local PC, and you can see this kind of screen, and you can see what are the indications, and you can download that file, and you can check what are the timestamp thing. So this is the one thing, the diagnostic. The diagnostic feature is that we have another new product which is a very good product, that is data capture unit. So what is the data capture unit? So I have a modules of ACM 200 over here, and what I will do, I will connect these modules to the cloud. So these modules can be accessed from Germany. It can be uh, accessed from the Australia. We don't want to speak on such a large field. I just want to give the overall picture. But it can be accessed by the Delhi. It can be accessed by the Southern Railway headquarters. By this, just you have to put the IP address of that particular IP, and this what it will do. It will transmit the data from one from local station to your to the cloud, and from the cloud, from the your internet, you can use your mobile, you can use a tab, and you can use anything. You can just check the modules, what are the, this is called as the application, the mind application, which we say over this. So we need a safety for this. So we need a safety, and we are also talking with the RDSO to make introduce of this DCU. It's a very different product. So what it will do, it will transmit the data from one location to other location only in one direction. For example, in this, if the data is going from my module, it will collect the data in one particular PC, and this PC will be connected to my this unit, that is the DCU, data capture unit, and this will go to the gateway. So person want to hack my modules anywhere, from anywhere, he cannot hack, because the data cannot be transmitted from open network to the safety network, so it can be transmitted. So this is, we have already installed in one of the station in Central Railway, and it was very successful, and we have shown various exhibition. So this is what we are going to promote in the coming projects. But there might be some kind of fees or whatever that we will discuss internally, and what kind of fees or what kind of this, or it can be provided free to the customer also, depending upon the applications. So you will provide, you, there will be different tabs or different applications, you can just click, and all kind of history, or like right from the predictive maintenance, like what going to happen
तुम्ही
when
ज्या
I going
व्यक्तीशी
to go.
बोलत आहात
So everything
त्यांनी
going
तुमच्या
to be
कॉलला होल्डवर
checked,
ठेवला
and it
आहे.
can be good. So this
कृपया
is the new
लाईनवरच राहा. The person
diagnostic
you are
which we are coming. So this is the installation. This is the installation which we have done in the Central Railway, where the outdoor unit is there, and we have connected this small unit with the
तुम्ही
modules,
ज्या व्यक्तीशी
and it is
बोलत आहात
all the data
त्यांनी
is
तुमच्या
transferred to
कॉलला
the cloud. So
होल्डवर
this is the
ठेवला आहे.
advanced feature of my
कृपया लाईनवरच
diagnostic
राहा.
feature.
The
So
person
when
you are
you
speaking with
open the
has put your
diagnostic
call
feature,
on
you can
hold.
see this kind of
Please
graph,
stay on
and
the line.
when you
आप
press
जिस
on the
व्यक्ति से बात
timestamp,
कर रहे
with this
Very good,
उसने
timestamp,
Anushka.
you
कॉल को
can see the
होल्ड पर
frequency.
रखा है.
At this
क्या
timestamp, what
लाइन पर
was my
बनी रहे.
frequency? If there was a failure, I can
तुम्ही
check
ज्या
in that
व्यक्तीशी बोलत
timestamp that
आहात
what was the
त्यांनी तुमच्या
failure in
कॉलला
this timestamp. So
होल्डवर
this is
ठेवला
for the
आहे.
live streaming of the
कृपया
data.
लाईनवरच राहा. The person you are speaking with has put your call on hold. Please stay on the line. आप जिस व्यक्ति से बात कर रहे हैं उसने आपकी कॉल को होल्ड पर रखा है. कृपया लाइन पर बने रहें.
I think like somebody is attacking this. Let us find out who is calling that number. Let us find out. Somebody is calling in. Somebody knows the facility who is calling. Let us find out the number and then block that number from calling in.
We are expelling, sir. Now expelled, sir. He has been expelled out, sir.
No, no. But like every time we'll have to expel out. No? Let us block that number. Whose
We
number
have
is there?
expelled.
Let us find out.
We have expelled and now we are locking, sir. So
Right. Okay.
new person cannot come in. So existing person was doing so that he has gone.
Okay, okay. Like no. Let us find out the number. Who is the fellow?
Okay.
Our own staff means we'll have to take him up through a different method. Okay.
Right.
Right. Okay.
Yeah. Thank you. Thank you. Yeah, so the question is wondering what I said in a overall key benefit, the application which I said, remote monitoring, which I'm saying, it is a visualization of ACM 200. If I have a 50 modules in one tab, I can just have a small boxes in my mobile or in my laptop. I will having a 50 modules. You can just click on that and you can just check that module status, and what is the status, and what was, if there is a failure, you can check what was the failure the night. And this we have shown in various exhibitions, and we are going to execute in various projects also now. So this display of remotely ACM 200 remote and live information of all ACM statuses anytime and anywhere, no presence in the interlocking room, physical access to the safety network. All the historical data storage, it will be there. Improved investigation of the failure will be done from our end and the railway end if there is any kind of failure, and the replay of multiple unit possible for event analysis can be replayed and can be checked. So this is the advanced feature of the remote monitoring of my system. So this is my first installation which I carried out at the Jagram station. Parallelly, there are 4 stations near to the Kharagpur, which this going, and overall we have a 2000 DP order over there, and which the work is under progress. So this is my first installation which is carried out 1.5 years back, and it is still working and without any failure. This is my indoor installation over here. So as you can see, I said in the cabinet we have a modules which is connected in this way, and this is my outdoor unit. it's a vertical. Again, there's a space minimization over here. It is a vertical installation, where before we used to make other kind of installation. There is minimal of requirement of the space at the rail side, because it can be very useful in the very messy or meshy, we can say, the point zone area can be installed. The earthing we have done is a negative rail earthing, which we recommend the 50 square copper cable, and this is the indoor part of the electronic junction box, where maintainer has to press this button and it will be autoclave. So this is an overview of my first installation. So this is my overview of the key benefits. Yes, our ClearGuard ACM 200 offers a very smart rack vacancy reduction. As you can see, I think there is no other Excel counting system. I can proudly say today that it has a one single module with all kind of cards application in a single module. Only a single module, an automation module. It's only Siemens over the globe. I can proudly say on this, and this makes my system very cost effective. It has a only standard Ethernet based, minimized building space, optimized system configuration, low power consumptions, and also there is life cycle cost also, and modular system allowed to upgrade and can be tailored as per your requirement. And all the concept of ASM permits very easy extension modification, thereby ensuring industry further. So we are looking for you to provide this kind of modules and the solutions to the Indian Railways with the next generation Excel counting system. With this, I end my presentation over here, and I want to take questions. And I want to take after this question, I just want to paste one link, that is my feedback link for our side. The participants just click on that link, and you can just rate us, and your requirement and your mail IDs, whatever it is mentioned, just it will not take more than 1 minute. You can rate us so that we can come to you, we can reach at you, and we can provide you this product, that is our next generation Excel content asyncronous. And with this, I thank you so much for your patience. There was some disturbance, but it was handled by your team, and I thank you so much that it allowed me to complete my presentation in a very good manner. Thank you so much. Now we'll take with the question and answer. After the question, I'll paste the link to you. The Bhushan, you can just paste that link in the chat box. Yes, we are open to the discussion, me and my colleague, Mr. Bhushan Tong.
I'm Rajshekar, CSE. Am I audible?
Yes, sir. Hi, sir. How are you?
Just one or two things. Basically, when we are looking at a solution for the auto section bar IBS,
yes.
Let's say I locate the evaluator at this site, at the IB site, okay?
Okay.
Now from there to, let's say, the stations on either sides, I need communication, right? One DP is here and the other DP is at the other station, right?
Yes, sir.
Can your DP be worked on? I can cascade units. That's what you were mentioning.
Yes.
The cascading, can it be done on OFC without having a switch in between? What I'm essentially saying is your equipment having a SFP kind of an arrangement for interfacing either electrically or optically?
Okay.
I'm talking about the evaluator.
Okay. So you mean to say that we no need to make use of any switches. It can be directly connected to the OFC, right? To the OFC
I'm
converter.
talking about the evaluator unit when I'm
Yes,
cascading them.
I totally understand. My module gives the Ethernet protocol in this case. So for the OFC, I need a converter. So I'll be making use of this converter from the from the Ethernet to OFC. Then it will be done. Then it can be done, sir. And these switches
Okay,
are used for the cascade. These switches are used for the connection of various modules. It act like a hub actually. So these switches anyway it will be required for me, sir, for cascading all kind of modules to connect it.
Actually, to put it possibly, I'm just drawing equipments of telecom, right? Where any Ethernet port, they are what are called SFP modules. The SFP module basically gives me an option to tap either electrically or optically the same Ethernet port. So all I need to do is remove a module. For electrical, there is a module, and for optical, there is a module.
So does
Though
it
the
allows
signal,
the
base signal is Ethernet, so without getting into an additional equipment of, let's say, you're essentially saying is a media converter, I can directly use the same equipment by replacing the SFP module.
Yes, sir. That module should accept my Ethernet protocol. If it is taking the Ethernet telegram, the HTTP, then you can directly connect it.
Oh, is it inherent in your equipment, or am I asking for an external connection?
External connection is required. There is no port where you can directly connect your port directly to connect to my module.
Yeah, I
There
think
is only a
Um,
Ethernet port. That's it.
Yes, let me add something here. Sir, actually in our SCM200 module, the port which we have for the communication is the Ethernet port, RJ45 connection port, where you cannot put that SFP module. Okay, for the SFP, means the SFP port is for the different than these Ethernet ports. So for the SFP, we need that type of modems or that type of converters. And with the Ethernet connection, we will connect our ACM to that Ethernet Ethernet switch or converter, and then it will take that information to on OFC using SFPs. But we cannot put SFPs directly into our SCM modules.
Right. Okay, fine. That's what I
Yes.
just wanted to confirm. Yeah.
Yes.
Yeah, thank you, Bhushan, for adding your points. Thank you so much.
Yeah, Chandodre here. You see, regarding actually, earlier we are using quad cable, no? And after
Yes,
that,
sir.
now YFC also is coming to the picture. After conversion for this YFC, what are the failures you are encountering, problems you are encountering? What we are encountering in the earlier with the quad cable, all those are everything nullified, or still we are facing other same similar kind of problems. And for YFC performance here, just a brief.
Yeah, Bhushan, you want to add points on this, because I think from my side there was some breakage in the connection. If you're clear, you can go without asking the same question again.
Sorry, sir. I request you to please repeat that question actually.
Earlier we used a quad cable completely. Now the transmit media we are changing to YFC completely.
Yes,
And
sir.
what are the problem earlier we faced on quad cable? Is it entire thing being nullified? Induction, loose connection, these entire thing.
Yes.
What are the other problem we are facing by introducing this? And you overcome
Uh,
of this.
no, sir. Actually, the aim of replacing this cord cable by OFC is we can send the multiple information on OFC as well. Okay, and the another point is the speed transmission rate, data transmission rate. The cord cable, the OFC can transfer the data very fastly, and we can say the speed of transmission is higher than the cord cable. And we are using the cord cable between two stations. Okay, the DPs, that is the outdoor unit, is connected with indoor unit by cord cable only, of course. And when we said in between the two stations, when we are replacing this cord cable by OFCs, in that case, the requirement is also less, because the OFC converters are much more efficient than the copper cable converters. That is our experience. Okay, so that's why the OFC is better for the communication between two stations, and the failure rate is also low in that case. Yes, sir.
The a question from my side, for connecting these equipments, do you have a communication redundancy? Meaning to say that, let's say I have between two stations, I'm communicating between the evaluators.
Yes, sir.
Yes.
Can I lay OFC on alternate paths and then both of them get merged through using two cards on the equipment? Or
Yes,
is
sir.
it a
This
single
can be
card?
done. Yes, this can be done, and we are doing the same as I showed in the scheme in the Gudur project. All redundancy is there in the ring we have
How are you
created a
achieving?
ring
How are you
architecture.
achieving? How are you achieving the redundancy?
So we're making use of dual Ethernet switches in that case. So the dual Ethernet switches with the ring network. So additional hardware we are using in that case, switches.
So this is external to your equipment.
The switches which we are making use of industrial gate, that will be the switches which are making use, the additional, yes. So with this we are
So
customizing for the yeah.
Yeah. So essentially, what I'm understanding from what you're saying is, from your evaluator to the switch, you're having a single Ethernet connection.
Yes.
There, you're developing your dual redundancy.
Yes.
That could be
Yes.
on account of the uplink port and downlink port being used through two separate parts.
Yes. Yes. That's true. Yes.
Correct?
Yes. Yes. That's true.
Okay. Right.
Yes, sir.
Thank you.
Let me add something here, because we have not given this type of means 2-3 types of connectivity in our SCM, because it's of course it's a universal product, and there is the option available for the next level communication, means next to ACM will get connected by Ethernet only, but after the in next level you can use the converters, you can use the switches, or you can use the routers. That will be the choice depending on the architecture between two stations. And in between two stations, I want to add in this the in we are forming a ring network by using two different parts. That is, if the one OFC laid on the downline and second OFC on the upline, we are using both the OFC cables for redundancy. In that also, sometimes we got the requirement that they have limited fiber optics. That is, if they have laid the 24F cable, then they have only the 24 fiber optics channels. In that, if we use the simple SFP, that is, it has the TX and RX port. Here we have added one thing. We are using WDM technology. In that, only one fiber optic is required for point-to-point communication, where we are saving the fiber optics, okay, and we are forming the ring. If the one link get fails, then the data will route by a second path. That will
I
be
think
available, sir.
all these solutions, what you're talking about, is extraneous to your, external to your ACM 300, or sorry, 200.
Yes.
So these are more kind of standard off-the-shelf
Yes,
kind of a
it's
product
a
which you're using in
yes,
conjunction.
yes, 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 yes. Because
Okay.
it's an Excel counter product, and it's only counting the Excels and gives the Excel counter report. But the communication is always open market. We can use the open market feature, and of course our product support that features. That compatibility we have given in our Excel counter modules, sir.
There was one more thing. What about these functions which you want to transfer between and information you want to transfer from, let's say, the IB to the evaluators? You have a kind of a fail-safe multiplexer inbuilt into it, or any such functionality available?
Okay, so as I said, as Krishnakant has already explained in the presentation, this module is specially configured for Excel counting purpose, and it has very minimum configuration, that is 2 track circuit configuration only. So here the question comes for the block information. So you can use this module as a Excel counter product or block information sending product, either one of them. So in our product, we have 2 track circuit configurations. Similarly, 2 block information exchange facility in our module. So if you are using two track section, then you cannot use that SRI, that is safety related information exchange. But if you're not using the track circuit application, then you can use 2 SRI information exchange facility in our SCM module.
And how many such functions can we transfer? Like, let's say I'm using a module exclusively for transfer of the block information.
It's a for vital, means if you are using both the channels, then it's counted 2, and it's if it's a non-vital, means yes, then 2 information, sir.
2 only.
2 only, sir. Yes.
Non-vital is
Because
also
because
either
in Excel
vital
counter
or it
feature
could be.
sir, please. Yes, sir.
The question was
Because it's a special requirement to
vital functions and two vital functions. Do I need to take one evaluator unit, or I have to again evaluator units because the ultimate functions are only two?
ultimate functions are only two. You can use either way.
Oh, that's fine.
Yes, sir.
Thank you. I think.
Thank you, sir.
Thank you, sir. Yeah.
Thank you, Krishnakant, for giving us insight into Siemens MIG axle counter equipment, explaining their indoor and outdoor equipment and its applications. We'll move on to the next presentation. It is about self-reliance and electronic interlocking, MEDA MIG, by G. Gopal Krishnan, SSC Signal Group.
Okay. Thank you so much. Yeah.
Sir, here one request from my side that to fill that feedback form, sir, please, from all your colleagues. That will help us a lot, sir. And thank you for your time. Thank you for the slot, sir.
Yes. Thank you so
Share.
much.
Good afternoon, sir. Good afternoon to our respected PGSC, sir, CSC, sir, all officers, JE, SSC, and other engineers from other firms. Sir, let me introduce myself. I am G. Gopalakrishnan, SSC Signal Dindikal. Now I am going to give a presentation about the self-reliance in electronic interlocking, MEDA MIG. That model is 633. I am starting your presentation, please. The outline of my presentation is first we'll have an introduction, then EAE system working, technical specification, system and subsystems, maintenance practices, minor modification done in EAE, we have done in Ailur station, then I'll conclude. Coming to the introduction, electronic interlocking, why it has been brought to the following advantages. We have a very less power consumption. The relays used are only for interfacing purpose. That is, the field relays are only interfacing, and there is no interlocking relays. The interlocking is in a form of Boolean bits. The space required is very less. We can go for a distributed interlocking also. So communication, coming to that, it can be central or distributed. While going for distribution, the OFC with redundancy part is also possible. Alterations to the existing circuit is possible with minimum time, with less wiring or no wiring. Mean time between failures is high, less relay contact failures, connector failures, soldering failures. Fault speed detection is available. Failure diagnosis using event logger and RM logger is possible. Since an inbuilt data logger is also available in the electronic interlocking. It can be networked with other EAs, axle counters, etc. So it is more flexible for CTC also. EA system working. Generally, EA system working have two main components. One is the hardware and the software. Coming to the hardware, we have microcontroller, processors, and peripheral devices. Software, the executive is the base, and we have application software.
Gopalakrishnan, why don't you put in PPT model? The only the PowerPoint model, you put it. Presenter mode.
Step 5.
PPT, no, screen.
One minute, sir. Page full page.
The bottom is there, no?
From current slide is there.
Run it in slide from the current slide.
Yes. Please, sir. So can I start, sir? Excuse me, sir. Can I start, sir?
Yes.
Yes. The software is executive. The software is executive. Yes, sir. Please. The software is executive and application software. Hardware is 2 out of 2 and 2 out of 3. In the second case, 2 out of 3, we have safety with additional redundancy is also available. Executive software is common for all stations for a particular mode, but application software is station specific and it changes as per our yard requirement. Totally, the entire system comes under SIL, that is safety integral level is 4. To achieve the above standard, we have various levels of testing verification, validation, and these processes are available. Technical specification of MEDA electronic interlocking. The power supply required is 110 volt DC bar 24 volt DC. The cycle time for execution is 333 milliseconds. Optical communication is the OFC with ring modem configuration. Operating time is for data transfer is 115.2 kilobits per second. Route handling can go up to 450 routes. Number of vital input outputs can be handled is 2048. Number of non-vital IOs is 3072. Operating temperature is from -10 degree to 70 degree. It is completely 2 out of 2 system with hot standby feature. The F value should be maintained less than 1 ohm. The MI633 system consists of the main system, that is the central interlocking unit, and other subsystems are object controller, panel processor, VDU, then maintenance terminal and counter box. This is the main system, sir. This is the central interlocking unit. This is the main rack. In main rack, we have this front panel display. Then top bin, it is the power supply module, and bottom bin, we have the processor module, and below that, we have the ring modems and the communication interface. The central interlocking unit, the first top, we have the front panel display. It is provided to display the error codes and system health condition without seeing the MT. This is very, very useful, sir. When we are in the relay room, we can directly see the error codes and system health, whether the system is booting up, what is the status, and like we can go on with that front panel display. Top bin, we have the power supply model. In power supply, we have 3 types actually. It is A, B, and C. The A type power supply we are using for panel processor only, and B type, all type of controller cards are used, so we use B type, and C type we are going for other peripherals, that is linear ICs are used in input and output cards. This bottom bin, we have this main component, that is the vital interlocking computer or the card. Then we have the communication card, voltage and health monitoring card, and the communication interface card. Coming to CVC, this is the heart of the system, vital interlocking card. We have 2 systems. In extreme left hand side, we will have this CVC A system, and right hand side we have the B system. Next comes the CCA, left hand side, then voltage and health monitoring card, then communication interface card. This CVC card, we have 2 systems. It gets all the non-vital commands from the panel processor bar VDU. It will read the field inputs regularly. It will run the program and gives the necessary command to the all object controllers to drive the field gear. It also regularly monitors all the card health, and any failure is notified in the wrong side, that is safety critical error. It gives immediate command to withdraw all its output to its OC. In front fascia, we have the indication to find whether the system is active, standby, and is also communicating with which channel, that is CCC A or CCC B. This is the actual that data transfer. The CCC card. This is the communication card. This is also a vital processor card. We have 2 channels here, that is channel A and channel B. This card is also loaded in MEDA. The application software is loaded in 3 main cards, that is the vital interlocking card, communication card, and if a panel processor is available, we are loading in the panel processor also. Here the CCC card is loaded with executive and application software. The CCC card consists of 2 channels, that is channel A and channel B. It communicates in bidirectionally from CVC, CCC, then communication interface, then ring modem and object control via OFC patch cords. Central interlocking unit consists of 12 serial ports, that is RS485. Out of this, 8 ports are used for 32 OCs, that is maximum 32 OCs can be connected with the central interlocking unit. 1 port we are using for panel processor and VDU, 1 port is reserved for connecting other EIs, and 1 port is reserved for ETC, and remaining 1 port we are keeping as future stack. CAU also has 3 serial ports, this is RS232 for connecting with maintenance terminal, data logger, and panel display via RS232 for OFC converter. In front fascia of this card also, we have important indication, that is it is communicating with vital card A or B as on. This is the user of the bottom bin. Then coming to the communication, here we can see that Right hand side, all the OCs are connected. Here we have a primary and secondary path in the ring modem, so that is the multiple redundancies available with the OC. Whereas with the panel processor and VDU, we have only two links, channel A and channel B. Left hand side, we have this RS-232 connection with the maintenance terminal. One is with data logger and FPD. Coming with the voltage and health monitoring card, very important card. Card will monitor the whole voltage, health of vital interlocking CCC cards. There are two cards available for individual A and B system. This card is provided with switches to reset the shutdown the system and restart the system also. In front fascia of the indications are available to know the health of voltage, system and communication also. Next is coming is the communication interface card. Communication interface card, it actually acts as an interface between the CVC and the CCC. Actually, this UR signals here are converted into RS-485. Then it will come to the ring modem. Ring modem. Ring modem, we have 5 different configurations in MEDA. This is one is the master, which is used in the central interlocking unit. Next is the slave, which is used in the OC. Then we have a panel processor, master and slave, then MT bar VDU. The ring modems are selected with hardware and software. They communicate bidirectionally. The modem used to communicate between CIU, OCM, OCM to OCM, and CIU to panel processor bar VDU. Each ring modem will have 2 sections, that is the primary and secondary. CIU ring modem is always master, and other modems are slave. Separate ring modems are provided for channel A and channel B communication. And next thing, we have RS-232 to OFC converters also. These are provided for serial communication between the CIU, MT, data logger and front panel display. Object controllers. Object controllers, it is the next subsystem, the main subsystem. The OCs can be connected in central or distributed. The radius is within 15 kilometers. OCs are provided to acquire the field input data, and it will drive the output field gears. It consists of one card file consists of 5 input cards and 3 output cards. One OCM can handle up to 64 IOs. Totally 32 OCMs can be connected to the CIU. So we will get 2048 IOs can be handled. It consists of 2 bins, that is the bottom bin and the top bin. The top bin consists of the power supply model, voltage and health monitoring, and then we will have the communication processor. Here we call it as an IOCOM. The bottom bin, we have this input cards on the right hand side. We can accommodate 5 input cards, and left hand side we have the output cards. Output cards is dual, processor card is different and relay driving card is different. And in the center we have vital cutoff card. The input cards. The input cards can read 8 inputs, and one OC can accommodate 5 cards. Totally 40 inputs can be read. This card gets the status from the wastage function in the yard, like NWK, TP, whatever it is, and then front context is available in double cutting arrangement, and it has a dual processor, a master and slave. OCC output card, OCCO, each card can drive up to 8 field gears, and it is driven through a separate relay driver card only. Each OCM can accommodate 3 cards, totally 24 outputs can be driven. The card will receive the basic function output data from the IOCOM and drive the relay. This IOCOM will be connected to the CIU. Coming to the IOCOM, this is the object controller communication processor card. Both the input and output card is connected to the IOCOM A and B. Again, this IOCOM card is hot standby. Actually, input and output card is common. They are not in hot standby mode. This communication card is only in hot standby mode. They are connected to RS-485 ring modem. From ring modem, patch card will go to the CIU. Their master ring modem, then again it will go to the communication interface, CCC and vital interlocking card. This is the data transfer, how it is going on. Next comes the vital cutoff card. All output cards in the OCM are monitored continuously by the vital cutoff card. The vital cutoff card drives the VCO relay. On voltage, any voltage and health is not found correct in the OCM, then immediately this relay will be dropped. This relay drops will shut down all the cut off all the relay status will go to off status. VCO relay drops, by which all the output relays connected to be de-energized, thereby ensuring the safety of the system. So this OBC card will monitor the entire system of OCs, and any command coming from the CAU like safety critical error, the VCO relay will be dropped and the outputs will be in off state. Coming to maintenance practice, this maintenance practice is very, very important. We are going to do with the help of maintenance terminal, that is embedded PC with maintenance tool as software. EA has an inbuilt data logger. The data from the CAU is logged to the maintenance PC via RS-232 or OFC converters. Both online and offline data simulation is also logged to the MT. This is done with ring modem. So we have an RS-232 OFC converter and RS-485 converter for both. With event logs, error logs, which is being loaded in the MT, we can go for a troubleshoot. Any failure can be attended in a preventive manner. Because in regular technician visit or any inspection, we have a separate notebook. We have to monitor what are the errors and safety critical errors. Then we have to go with that. Then it will be very clear that there is no error log in my system. Both critical and non-critical errors will be displayed in the MT. Then offline errors has to be backed up regularly to study the system health. In maintenance, an important thing is that a physical checkup of all the communication connectors, that is coming from CCC card up to the OC and VDU bar panel processor. Visual indications in the cards are available from the OCs and panel processor also. These indications have to be continuously monitored. It has to be diagnosed and recorded so that we can avoid failures. Preventive maintenance is possible. All SPDs to be checked in regular. Earth connections to be checked for intactness with clean equipotential bus bar. All voltage and current readings are taken regularly. It is measured, recorded. We have a mini DC-DC converter rack in the relay room itself, and we are also taking voltages in the backplane of the CAU and OC. So that while taking voltages in the backplane, we can know whether voltage drop is available in between the mini rack of converters to the CAU or OC's level. 110 voltage is coming to the mini rack of the DC-DC converter from the IPS room in dual path. So the voltage must be less than, drop must be less than 0.5 only, and the dual path is also working, can be checked regularly with clamp meter so that the current is sharing equally. CCC card A and B. As I said, the communication is dual. We have two channels. So individually, every channel is working individually with the system A and B. So one CCC card has to be shut down in monthly basis to check the other CCC card. Same, the vital system, that is the A system and B system, has to be changed in monthly wise. So that A system is active, we have to shut down, B system will become active. We have to see the entire working in the next month in B system. So likewise, we can improve the performance. We can know the performance of the system, whether the system is available with me in healthy condition. Same weekly, we are going for maintenance or inspection in technician level also. We have given clear instruction to see that the video is changed from video 1 and 2. We have a setter box in dual video, in that there is a changeover available. Video 1 and video 2 has to be selected and it has to be operated and maintained. Communication to these videos also has to be checked from individual channels. That is channel A, whether both the videos are working. From channel B, whether both the videos are working, has to be checked. Event log bits to data logger. When we go for a data logger maintenance or AMC of data logger, there is a protocol converter available inside the data logger. So whether the data, that is the bits coming from the CAU, is correctly logged in the test room, it has to be checked in regular manner. Failure analysis. We have some failures in my section. That is, in Manapai, we had a CCC link failure. We have changed the card. Then a panel passer card also failed. We have changed the card and restored. In Dindigul and Manapai, it's a very simple thing, but it has created some confusion. While going for a LED replacement in the panel, that is CACIP, a panel processor, this input, when changing the LED, the input leads were accidentally short. What has happened, the entire card has failed and the indications are showing in an irregular manner. So it leads to panel failure. To avoid this, we have to switch off the panel processor input supply. Then only we have to go for an LED replacement. This was brought to the company person also. Then after replacing the card, then only the failure was restored. Meantime, we were operating with the VDU. In Vadamadurai, recently, we had a failure noise. The channel noise, the failure is IOCOM failure, link failure, like that. 2 weeks it has taken. First week we have been troubleshooting with the CCC and the IOCOM cards by replacing them. Subsequently, between OCs, by seeing the modem indication, we found that intermittently the primary and secondary path was breaking. So with that, we had an idea that whether maybe our patch cards problem. So step by step, we have changed the patch cards from OC 1 and 2, and this failure was restored. After installation of this executive software by Meda 1.2 version, now monsoon precaution instruction has been given. So the CVC B system was shut down. In that time, we observed that the maintenance PC, the data was not updating. That is, the event log data was not uploading. So this also was taken to Meda engineers level. Now they are working on it. And after that, Meda staff came. They have removed the card. They cleared the bug. Then only this data was flowing to the maintenance terminal. Well, coming to the minor modification in Meda, here in ILU station, we have done a minor modification, that is RLA removal in the ASR system. So what are the tools required to do this minor modification? What we have done in ILU, I'm going to say once again. The computer is required, a PC is required with Windows operating system. Application jig, programming jig is required. It is a PCB where we can take the cards and insert. It is supplied by the company firm with connecting cables, RS-232 and some different connectors they are giving with company standard. The PC must be loaded with application data generation tool. It is version 1.1. This is a very important tool. It will convert our application, that is the DET equation, to the bin, that is the machine language file. Video, while going for FAT, we require a simulator. So we want a CIU simulator. Then to simulate the inputs, we require an FSP, that is called a field simulation software. After doing all these things, I have done some alterations in one DET equation, whether both are correct, in what area I have done the alteration in the DET equation. So with this WinMatch software tool, it is easy to compare, and it will give an output that in which area, which line I have done this alteration. So this will build up our confidence. First of all, we have to create a folder in my desktop, in my PC. Then the DET equation required from the particular station has to be taken. The checksum has to be once again varied, confirmed again once again. Then after that, the DET equation, it is a text file, it is a Boolean language. So it has to be edited in a very careful manner by removing, for example, RLA. Then after that, this Boolean text file must be saved. Then the altered DET file is not sufficient. We require a database file. So this is a fitter file .mdb. This file and DET file, which is altered, is being stored in the new folder. Now I am going for application data generation. So now I will open the application data generation tool, and I will select the new folder path. After selecting the path, some 8 pages will open. That is, it is progressing. So page by page, we have the input section, we have the relay grouping, whether we have any relays we are adding, that is to the internal, external, additional relays, like that. We have to add. Then only we will go to the next page. Next is the timer section. For FAT, we have to go for a 5-second logic. So we have to change the timings also. Like this, IO mapping is available. So after completing all the page, finally we come to the station installation address. Here we have an installation address. For example, ILU we have 134 and other details. Everything has to be checked correctly. Then at last we have to go for generation. When we press the generation button, automatically some 7 files will be formed in my new folder. So again, now I have to go to the new folder. While checking there, I will get one file called fitter.bin. It is a .bin binary file, machine language. This file is important. This is going to be downloaded in the EA card as well as in the simulator for FAT setup. While going for FAT testing, this is actually the new folder, sir. In this new folder, we'll have the DET equation, we'll have the fitter file. This is after generation, so many files are created. Here we'll have the database for the data logger also. Then this XR equation, lookup tables, relay, everything. This is the this slide shows the application data generation software. Then next here, this is the first page. Here I am going to select the folder. That new folder I am selecting. Then det.txt and this MDB file is also selected. These are the pages going to be open. This is an example. We have panel details, OC details, timer, power on relays, IO correspondence, installation address, port interface, and relay login. This is the WinMerge application for the software. Here, in left hand side and right hand side, we are having the old ILUR beat equation and the RLA altered beat equation. So these are the ASR 10 ASR circuit which I have removed the RLA is being shown by this particular software. So we are confident this mode. Now this is the last page. After giving generation, the process is complete. It will give the final checksum. So this is 8980 is the final checksum we got in the FAT for 5-second logic. This is the FAT setup. This is the field simulation panel, software operated switches, tracks, points, signals, LC gates, and SMR, whatever the entire yard requires can be simulated from this software, and this will be connected to the CAE simulator where the .bin file is loaded, so that it will work in a communication RS-232, 2-wire or virtual port. In both manner we can connect it. This is the CAE simulator version 1.2 that is updated. Here I have to copy this .bin file. Next important thing
Gopal, voice is not coming.
Yeah, the voice is coming.
No, sir, I'm just checking, sir.
Sir,
Oh, you know.
Yes, sir. Now we are getting the voice actually.
I think there is some problem that end, I think.
Yes, sir. Mother end, I think some problems. Sir.
வணக்கம். கோவிட்-19 அன்லாக் செயல்முறை இப்போது நாடு முழுவதும் தொடங்கிவிட்டது. மிகவும் அவசியமெனில் மட்டுமே உங்கள் வீட்டை விட்டு வெளியே செல்லுங்கள். வேர்க்கவர் அல்லது மாஸ்க் அணியும்போது வாய் மற்றும் மூக்கு நன்றாக மூடியிருப்பதை உறுதிப்படுத்திக் கொள்ளுங்கள். பொது இடங்களில் குறைந்தது 2 கஜம் இடைவெளியை கடைபிடியுங்கள். கை மற்றும் சுவாச பாதையை தூய்மையாக வைத்திருங்கள். நினைவிருக்கட்டும், சிறிது கவனக்குறைவும் அதிக பாதிப்பை தரக்கூடும். இருமல், காய்ச்சல் அல்லது சுவாசிப்பதில் சிரமம் ஏற்பட்டால் வானிலை எண் 104 அல்லது தேசிய உதவி எண் 1075 தொடர்பு கொள்ளவும். என்ற அரசின் சொன்னார். நீங்கள் அழைக்கும் நபர் உங்கள் அழைப்பை ஏற்கவில்லை. தயவு செய்து பின்னர்
Sir, coming to this SAT testing, again I'm starting from the SAT testing. It is audible, sir?
Okay, Gopal, now you are audible. You please go ahead.
Please. Again, I'm starting from the SAT testing, sir. For SAT testing, we have to take the .bin file, which has been created from the Jira generation tool. This bin file is being downloaded in the card. So for that, we have to take this bin file to this particular station, and the station, this bin file is being loaded in 3 cards. Since ILUR is a dual video station, panel processor is not required. So CVC and CCC card is being loaded with this bin file. For doing that, first we have to set the jumpers. The card has 2 modes, that is programming and unprogramming mode. When the card is on online, it is inserted in the electronic information CAU system. First, we have to make it offline by desoldering. With the help of soldering, we have to do the jumper settings. It is an 8-bit address 0 to 7. The first 3 poles will have the offline and online mode, and we have watchdog timers also. So totally in CVC card, we will have 7 jumper settings, and CCC we have 3 jumper settings. After these jumper settings are ready, now we have to insert in the jig. The jig is provided by the company firm. So in this jig, their slots are available for CVC, CCC, and panel processor. Now the card is inserted. It is connected via RS-232 connecting cable to the embedded PC. In the embedded PC, we require the application downloading software. It is a separate. It is not attached to the maintenance. So this software is now just opened. Then this bin file is loaded. So this will be like this. We have to open, go with the ID. Then it will ask the file. We have to select the comport1 and the .bin. So automatically it will erase the old program, and the new program will be, that is the application software will be loaded. .bin file.
After loading, again the card has to be soldered. That is, we have two type of soldering. Once we solder, it is 0, and if it is opening, it is like that. We have to configure the card. After making it online, we have to bring it to the EA system. Now we are going to insert in the EA central interlocking unit, and we will start the SAT testing. After SAT testing is complete, the database has to be uploaded in the data logger and as well as the MDU. So after changing the database in the MT, online checksum we have to take. That is the final record, whether the same checksum is coming or not. So we have to update the database and take the online checksum, and we can record it. So this is the SAT testing we have done, and few photos I am having how we have done the jumper settings, and this is the data uploading and downloading. So uploading and downloading software. Like that, we have completed the RLA alteration in ILUSA. Thank you, sir, for spending your valuable time. Any questions, please? So any questions, please, sir? So can you hear me, sir?
Yeah, we are able to hear.
Yes, sir. Please, sir.
Recently, you have carried out that R relay modifications.
Yes, sir.
Other division only it has been done.
Yes,
you
sir.
are involved in that?
Yes, sir. I'm fully involved in that, sir.
Then what are the precautions you have taken? Can you explain that how it has been carried out? What are the support you have taken from OEM?
Actually, we got this installation software, sir. From IRSTE, we already got this software. That is the application generation tool is a important software. Then this maintenance terminal, we have uploading and downloading software to the particular cards that we are having already. Then the FSP and the simulator software we had already. I'm having, because I was in fact testing while commissioning the double line from Dindigul to the stations. So with the help of this, and we have some guidelines from Meta company, some designer side, because this tools have been updated to version 1.2. So after having this necessary tools, we got this BET equations from the iLoop station. So in that we started our alterations. We have removed the all relay very carefully. We have 10 ASR circuits in iLoop. So one by one we have altered. Then with the WinMerge one software application is available. There we have confirmed that what is the alteration carried out between the old BET and the new BET equations. So we have generated the text file into the bin file using this data generation tool. So after that, we started the FAT setup in my legal office. Myself and the DST sir SW was involved. So after completing our FAT setup, we have gone for a SAT testing. Sir, we got approval from headquarters. The circuit was being given to headquarters. After approval, we have gone for a SAT testing.
Is it the procedure is same for all EA? It will be different. What you got from
we followed the times.
No, again you tell.
We got a TAN from Audio Sosa regarding this minor modification for MEDA. So I just followed the TAN.
No, that's okay. The procedure, what was the procedure he told, which file to access to modified everything.
Other is also same, sir. Only we require the software necessary tools, sir. Mainly uploading, downloading tool we require. We require the compiler, sir. That is the forward and revise compiler is very, very important. So other things are same. Same equations will be available. We have to save in the notepad. Then it can be converted into machine language. The unsolved will be an we have a different compiler. So there two files will be formed, MLL and MLP. That is an VLC file. It will be uploaded to the card, particular card. So the procedure will be different for loading the card. But unsolved, they are having this uploading in the maintenance terminal also. Compiler, everything is available in the maintenance tool. But in MEDA, it is different. Maintenance terminal, you are not having the downloading, uploading software.
All tools are all supplied by the OEM free of cost, or it is already available with us?
It is already available. We are collected from the IRSTE, sir, and from IRSTE only we are collected. We are having supplied by the without the costs.
Since you are done already, it is better you that procedure to be followed. No, you can make out
Yes, sir.
complete setup of writing.
Yes.
Step by step, that will be useful for others also.
Yes.
It's good work done. Good.
Thank you, sir.
Gopal, it is Rajshekhar here.
Yes, sir. Please, sir. Good afternoon, sir.
First of all, I wish to record my appreciation. It is a good trend you have started actually.
Thank you, sir.
It is in the right direction. And I wish to tell that what are the safety practices also. That is, you have to, after the work is finished, as per the norms,
yes,
you are supposed to enter the checksum data, revised checksum data in the history book also.
Yes.
And immediately you have to process the estimate, and we are maintaining a record on cloud. Rental cloud is made for all the EA circuits.
Yes, sir.
All kind of all circuits, all these things. So immediately you have to revise that cloud data, for which you are supposed to upload the data to headquarters.
Yes.
That you have to then you have to update your divisional records also.
Yes, sir.
And don't forget to inform the OEMs also, so that there should not be any clash.
It is
Because
available.
when any restoration or anything to be taken place, they may bring some different software. That kind of issue should not happen. So OEMs also should be updated. So any future requirement should be met properly.
Yes.
Thank you. You are setting a good trend, and all the best.
Thank you, sir. Thank you, sir. So finally, I want to thank my senior DST sir, our DST sir and ADC sir. Without them, it is not possible. Sir, senior DST sir has given me
I just have a question before you give your thank you to senior DSTs and all of us.
Yes, sir. Please, sir.
You see, now one is in terms of the yard layout modification. I think the difference between what Salem Palghat had done earlier was that only modified the yard layout which was on the VDU. Right?
Yes, sir.
So now essentially, of course, in our relay, you're not going to have a video modification.
Yes,
am I
sir.
correct?
Yes.
So now in this particular case, your video modification. So now are you confident of carrying out any of the alterations to the ALC? Because right now your modification would have only been on the ALC.
Yes.
Correct?
Yes, sir. Yes.
So one is in terms of verifying the modified Boolean versus what has been the uploaded Boolean.
Yes.
What I'm meaning is you first modify the Boolean, you
Yes.
upload it onto the EEPROM, then whether the EEPROM is registered, whatever you uploaded is to be counter checked.
Yes.
Is that the process?
Yes, sir. We can get an online checksum in the MTs. After uploading, we can create the database and get a. It will come in Excel, sir, in the MT itself.
Okay. So are you in a position to verify pre-R modification, whatever is the checksum, versus the post-R relay modification checksums together? Apparently, there is a Word file which has a has the summary, has the translation of the Boolean equations.
The equations we can summarize that. But checksum, we have to go with the system, sir. We'll get the first. We have to download this particular bin file. We'll get the checksum, of the old software. We can download the altered software. Then we can get the checksum. So that we can properly, sir.
So you're in a position to correlate both of them.
Yes, sir. 100%, sir.
So
Because
that means that now.
In SAT also we have done all the TCs, entire TC we have done.
I think till we develop confidence, it's always better to do the complete SAT also.
Yes, yes.
Right. It's always advisable because till we gain that confidence. Now coming down to your next evolution, I will say the evolution of. Now the next case, what is going to essentially happen is, like, let's say you want to close an LC gate, right?
Yes.
So it will involve the circuit modification, that's the ALC modifications, plus the yard layout modifications.
Yes. Yes.
Will we be in a position to do both?
We have to work out, sir. First, we don't have that kind of ideas. We'll do it, sir. We'll try.
Yeah, I think you've made a lot of progress. In fact, the very first step is developing the confidence that it can be done.
Yes.
So I think that was a major breakthrough in your case, because I remember Palghat division has only, I think if I recall right, modified the VDU.
Yes.
I don't think they went into the ALC modification.
Yes.
So possibly you can experiment the next yard. Only thing is you do your SAT completely.
Yes, definitely.
Once you develop 2-3 yards, then I think it becomes an automation.
Definitely.
Okay. Did you also run a comparison between the two Word files which are available pre and post?
Yes, sir.
So that we know what are the changes.
Yes, sir. That WinMerge one software is available, sir.
Sorry, what is the software?
When WinMerge one software tool.
Achha, WinMerge. Okay, yeah, correct. WinMerge. Okay.
So this both the files are BET files are selected, sir. So after selecting, it will show in which lines I have done the alterations.
Okay, so that you are able to again correlate.
Yes, sir. That is the confidence we got.
Yeah, excellent. I think great work has been done. Congratulations.
Thank you, sir.
For being a pioneer.
Thank you, sir.
And all the best.
Thank you, sir.
Sir, any questions?
I agree with what Rajshekhar CST has said. This is a really pioneering step by MDU, and I also wish that not only MDU goes into the next phase as CST has mentioned, other divisions also start getting the capability of modifying themselves, so that we don't become captives of the EI contractors or EI OEMs. Once again, congrats MDU division.
Let me just add here something, Suman.
Yes, sir.
Since CST project is also there,
yes.
This software, this application data generation software should be available in our design office also.
Yes.
So there is some activity which has to be done at the design office, wherein the field unit will submit the Boolean equation of the existing and the modified Boolean equation. This comparison has to be done, and this application data has to be generated through the same process that has been done at the field. And that checksum has to be entered in a register which is there in the design office. So that is again one level of check which has been mentioned in the tank. So that setup has to be there in the design office also. I request Suman to guide the design office also to load the software, so that this activity can also be done at the design office as a second level of check, which is mandated as per the TAN requirement.
Yes. We'll go for next presentation, sir.
Yeah.
Next presentation.
Suman, sorry,
Sir,
Suman,
yes.
I think I didn't allow your SSC to complete. So please allow him to complete, because I intervened in between before you wind up the session.
Yes, sir.
Yes, sir. Please, sir. Sir, I want to thank my CDST sir, DST SW sir, and ADST sir. My CDST sir was in a full swing to do this alteration. Sir has given more confidence, help in getting the software tools from IRSTE, and day by day sir was following me. What is the progress? So that was the main thing which made me to have confidence in doing alteration. So thanks again, once again to sir, and also thank you, sir. Please.
Sir, we'll move on to next presentation, sir. It is on fault analysis and failure prediction through data logger by Sri Suresh Kannan, SSC Signal Test Room. Suresh, start your presentation.
Good evening to all. I am Suresh Kannan, SSC Signal Test Room. Now I am going to present
about fault analysis and failure prediction through data logger. Nowadays, we use data logger as a main tool in SNT maintenance and failure analysis, etc. Something about data logger is a data logger is a microprocessor based embedded equipment. Is a data logger log the change of state of every relay and analog voltages connected to it. And logged data is transmitted to the central place by means of networking to generate various reports, simulations, and exceptions by application software. Three types of alarm are generated, mainly maintenance, safety, and operating related. So, data logger is developed as per IRSTE spec 99/2006. At present, is a data logger in standalone mode up to 10 lakh event storage capacity is there. To connect the networking, it can increase. At standalone mode, we have LCD, LED, and printer for local report generation. Data logger working is 24-volt DC. For networking, we use copper cable, fiber, now even network channel, data channel also. Mainly the advantage of data logger network to know the failure state and report generation of signaling system and power supply remotely. To send digital signal failure message to different people responsible for maintenance, and to use control of this application for auto entry of train arrival and departure timing. Another thing is safety point alarm generation. Speed of the train and point zones can be calculated, and it helps analyze the cause of accident and to provide evidence. And also it helps a diagnostic tool to prevent the maintenance of signaling gears. At present, in Madurai division, 4 network is available, and each network with a single FEP and CME connected to server. Yes, 4 network with 4 FEP, 4 CME is connected to one server. And now, one proposed arrangement is ready at Madurai division, that is with 100% standby. Proposed arrangement is for network. In each network is 100% standby of 2 FEPs, 2 CMU, and 2 LAN switch, and with 2 servers. In each and every division, as per RB guidelines, data logger management center is there. This is for data availability, data security, and easy accessing of data in one center. If data availability, as per new arrangement, the redundancy is 100%. If communication part, if one link failure is there, another one is ready. And FEP data storage and forward 100% standby. It is by 2 FEP provided for one network. And then CME also in 100% standby, server also 100% standby, and UPS also 100% standby for servers. And data security we use for firewall and antivirus software. As a benefit to SNT, as a reduction of mean time to restore of signaling system by reduction of incident, informative maintenance staff by fastest means, providing inside information regarding incident. It leads to increasing of MTBF, mean time of between failure of the signaling system, by providing insight into behavior of signaling equipment, by generating report of equipment over a period of time, and also provide evidence of events, that means at the time of unusual occurrence. Now we see data logger for fault analysis and prediction. How we use data software? It's a network management of data logger software that use the validate of packets received and segregates data, check for integrity of data, and generate fault alarm, and feed alarms to SMS software, and provides data to signal maintenance screen and network maintenance screen. Is used through NMDL software. And one more software there is a NMDL report software. The software used for viewing of events, viewing of alarms, and alarm detailed report, alarm summary report, digital input count report, analog input graph report, equipment room access report. All are available. This is the NMDL window. In this, on fault pop-up window is there. On fault display of digital analog fault is displayed there. And this is report generation window. Through this window, we get digital reports. This is for digital report for multiple stations. It helps to compare data of two stations during failures. Like block failure, we get a required both the station block instrument condition. So at the same time, two stations selected and relay condition is compared to block relays. And also a single station complete report also able to take. And also analog report for each and every station is connected to the analog data are getting. Normally, we use like this digital analog report only. Apart from that, other type of reports also generate for analysis. As one of this, fault count summary report. They find out the number of fault occurred for a particular time duration. They use by this report. And another one is all station fault count comparison summary report. To find out which type of fault occurred more time and which time station for a particular time duration. It is used to find out which station in the section to give preference for direct maintenance. And another one is as a relay up and down position graph report. It's able to see relay up and down conditions through graph view. Another one important is analog graph report. It is used to find out analog voltage variation in graph view. It's normally it's difficult to find out the through analog reports. If through this graph view, we quick analysis comparing to that analog reports. And also that cable parameters during any cable earthing or other conditions easily identify through this graph report variation of analog voltages. Another one type of report is fault count graph report. This type is able to see number of faults occur in bar chart view for easy comparison for faults. Another one is simulation software. The simulation software you use it for online and offline simulation and for the condition of station yard layouts. This is the simulation generation window. And this is simulation. For example, for a simulation of one station, including in this, one relay status screen also is there. During the simulation, online or offline simulation, there's a operation of relay is also able to see. Apart from the above, we are using and adding some additional equipment and logic. We get some more benefits. As one thing is cable fault identification by utilizing data logger and ELD. Normally, ELD equipment potentially contact connected with the data logger to find out the earth fault. In existing arrangement, if fault occurs, an alarm indicates display in ELD equipment will remain up either fault disappear or rectification. In case of acknowledgement is pressing acknowledgement button. In case of intermediate fault means after acknowledging the button, the fault will disappear. But our people doesn't know which cable is fault. In case of main cable is fault means permanently after acknowledging also it will not disappear. But in case of any tail connected to main cable, if any tail cable is fault or intermediate fault, it's not able to identify. Now by adding some additional input in data logger logic, we are able to find out which cable parameters, which tail cable and cable pairs intermediate fault is able to identify. In trial basis, in Ambassador station, we tried just a diagram. As normally DC supply is connected to ELD through potential contact data logger connector, getting failure, earth leakage appear or disappear information only. Now we additionally give inputs of relay contact inputs, CPR, NWKR, HR, and all the things is additional giving inputs. After that, we get some alarms. For getting this, we want to add some more items. That is, for getting 110 volt AC signal supply, additional input is there. That is RECR, HECR, HSECR, DECR, VECR. All the inputs are to be given. And for point, NWR and RWR relays for external signal control relays of HR, HSR, DR, EGR, and TPR, and point direction relays, NWKR, RWKR, and LC gate relays. For BPSC circuit, VPR and PPR for required additional input. Just I will show. This is the old logic. ELD failure, earth leakage appear is there. This fault description is the ELD relay is down, then it's ELD failure. This is old logic. And then if ELD relay is up, then it is ELD restored. This reports only we get additional. Now with new logic, we ordered additional inputs. That is for point, where additional inputs added. For point WNR, WR, all the points in connected in that cable. This is for one side of Ambassador station. 3 group of points is there, 63, 64, 65. All the 3 group WNR, WR relay is connected. In case of signal supply, all the ECRs, just is additional is inputs, all the ECRs are added. Now, after adding this, we have simulated some fault and get some reports. Now you see that the existing logic report, we are getting the report earth leakage appeared and earth leakage disappeared. This is only for we are getting the existing arrangement. Now through this new additional input is given, new logic after new logic is generated. Now we are getting the information earth leakage occurred ELD, and you see that additional input check the fault in the conductor of 64 WRR up. That means during 64 WRR in up condition only this failure is occurred. Like that, again is operator check fault in conductor of 64 WNR up. That means during 64 WNR in up condition only this fault is occurred. So for analyzing this, actually we simulate that point CW conductors can earthed. So both point normal and reverse condition, during operation only this earth leakage appeared. In previously, if the indication is appeared, up to acknowledge that indication continuously appeared only. So not able to identify whether this is main cable or in tail cables. Up to that, with the new logic report, we are able to get additional information which cable and which cable conductor fault we are able to identify. Like that, in case of any HECR and RECR, HG aspect or DG aspect or RG aspect cable conductor fault means during the particular ECR relay up condition only, that fault will generate. In case in HG aspect tail cable conductor fault means during HG aspect blowing condition only is earth leakage appears. After it goes to normal condition, it appears that earth leakage is disappear. Which we are getting the information that during to check that HECR conductor. Another one tool is the axial counter diagnostic tool. The axial counter diagnostic tool is a DAC interface system we used to find out the data log axial counter failures. This is the DAC interface unit is connected to all the reset box provided at the station SM room and able to get indication of, you see then below 8 numbers of reset box able to connect in one DAC interface. You see in below 8 numbers indication is there. This indication nothing but this field axial counter modem condition. Without going to location, we are able to see the modem condition at station master room. This DAC interface is a reset box directly connected to interface. That DAC interface, digital access counter reset box interface connected through data locker. The use of access counter monitoring is access to additional diagnostic data, and SM get audio visual alarm, and error codes can be sent as SMS to the staff, and monthly reports can be generated to improve MTBS. This is implemented into Chennai Valley, Manamar and Dindigul Junction in Madurai division. Another one is safety point alarm. The safety point alarm is provided at the SM room and connected to data locker. The reports able to get at control room. Is used for audio visual alarm to station master help implementation of GR 3.382 setting of the point against occupied line. Suppose that the SM failed to set the point against occupied line, it gives an audio visual alarm to the station master. It prevents collision of trains in case of mistake by one driver. There is monitoring performance of station master in implementation of GR 3.38 from control office is possible by report generation. This equipment provided at the Tirupati, Sudiyur and the Ramar stations in Madurai division. And one more is there, through data locker, we are able to see train speed analysis over point zones. I show one video. It's offline track simulation video. On this side, the run through signal is clear. Just you see.
Sorry,
passing the point zone.
We are yet to get your video. Your video is not getting. Please wait.
Yes, sir.
No, your video varla. Konja wait பண்ணுங்க.
Oh, yes, sir. Okay.
Video is not coming. You can go to the next slide.
Sir, able to see the video?
No, it's not.
No, Suresh, we are not getting the video.
Yes,
Next slide.
I think just give it some time, it will come.
No, you have to do enable one feature. When you do the sharing of video, when the dialog box comes for sharing of video, you have to click on optimize for motion and audio. Only then the video will come clearly.
Yes. Yes.
You unshare, stop sharing it now. Again, you do the sharing. In that, on the left hand top corner, there is one option box. Click on the option box. There you select optimize for motion and audio. Then you will get the video.
Okay, sir. During this online simulation, during the passage of train over the point zone, we are able to get the speed of the train through that that software we are include the track circuit length we ordered there in software, and we are getting the speed of the train on simulation screen, and also in fault logic generator with the section speed, with the mainline section speed and loopline section speed as per section data. The logic generator in case of during main lane, if overspeed is taken place on over point zone, one fault will appear. This is the screen. You see the overspeeding of at 64 TPR on main line, speed 103.68 km, and overspeeding of 58 TPR on loop line, speed 32.13 km. So it's able to get overspeeding of train. And another thing is failure monitoring through SMS. This online SMS software is configurable if each alarm to each user is possible, and feeds the alarm through GSM modem connected to the PC. It's possible to view the reports of SMS sent over a period user base. And notification is sent to mobile phones and reports accessed by PCs of user. Alarm to PCs of user also is there. This is data locker connected to FEP and CMU. CMU connected to GSM modem. Through GSM modem, we are getting SMS. This is a SMS sending status report. If you want to get proper analysis and report, we require correct data. If you want to get correct data, important things is data locker validation. The validation of data locker is three types. It's validation of analog and digital data inputs, and validation of simulation diagram, and validation of fault logics. And digital input validation is there. Digital input validation is if connected to front contact means during relay in drop condition, we check that wire the data log to loop wire. Through loop wire, we check the condition of the contact, the observed in LED panel, corresponding LED glows and the simulation corresponding changes occur. In back contact, if wired in back contact during relay in up condition only able to check. This is a display. And analog input validation. For analog input, correspondence test is there, disconnecting monitoring wire and monitoring end, not in data logger end, and observe value of LCD screen of data changes to 0. And value calibration is there, is measure input voltage and compare with value on LCD screen. The both are in at site level, and then checking of validation from test room for digital input. Is validation of simulation diagram which is signal interlocking plan, and observe track circuit aspect of signal and point indications with the recorded data and test room. Observe input which are not included in simulation by seeing the sequence of operation. First, data analysis and identify inputs which are not satisfying the conditions of simulation and fault alarm. Only those inputs which are not operated and which could not be corrected by software to be attended at site. And checking of validation from test room for analog input. Correspondence test. Ask technician at station to disconnect all the analog input in sequence. Observe alarm on online fault alarm, and sequence of alarm generated shall tally with the sequence of disconnection. And value calibration test. However, its value calibration shall be done by measuring voltage at the site by maintainer and comparing the values recorded in data log from its LCD screen, and also cross-check with the test room. Checking of validation from test room for simulation. Keep copy of the signaling plan and verify input linked to each element in simulation, that is track circuit, LC gate, point, and signal aspect by taking the element simulation both shall tally. At validation of input and correction of database, observe train movement online and offline simulation for few movements. Through this data logger, we are getting descriptive analysis, diagnostic analysis, predictive analysis, and prescriptive analysis. The descriptive analysis, it shows the user what was happened. Normally could not be seen by user. It cannot provide reason for what has happened. And diagnostic analysis, it provides reason for what has happened. It helps to user the next course of action to correct the system. And predictive analysis, it predicts the future event, and the user can take decision now to prevent it or allow it to happen and use it. And prescriptive analysis is enabled without the intervention of user to prevent an undesirable event or ensure a desirable event occurrence. By using the data logger as an effective tool, we improve the reliability. Thank you, sir. Look at that.
Any questions, sir?
Any questions, sir?
Yes, sir.
Yes, sir.
I think a lot of innovative work is being done, more so the one of using data loggers, using the WNR, WRR in conjunction to localize the particular bit of cable, which is,
yes, sir.
I think this may have been the first division which experimented successfully with this.
Yes, sir.
So it's a good development. Have you done it at multiple stations, or is it still on a trial at 1 or 2 stations?
It's a trial at one station, sir. But one difficulty is there, sir. As of now, in ELD equipment is unvidyut to make and that data logger is required that bypass acknowledge button, sir. But as of now, in RDSO, there is no provision for bypass acknowledge button. For testing purpose, manually you continue to press the button through bypass only you get the data. If there is a provision for bypass, is that we use this software.
Well, I didn't get this concept of bypass. You're talking about bypass button is required for testing the equipment, testing the simulated fault.
No, sir. That acknowledge button is given for once this fault is occurred means after acknowledge only it will disappear.
Okay.
But it's bypass means whenever it's occurred, it appears. When disappear means actually is getting disappear messages.
Hello?
Ask for bypass the acknowledge.
No, your speech is getting cut.
Sir? Sir?
Suresh, please repeat your answer.
Please repeat, Suresh.
Sir?
Yeah, speak.
Sir, without the bypass the acknowledgement button, even though it's a disappear the fault, continuously getting the indications, sir. So that purpose they are asking that the data logger company asking to bypass the button. After bypassing only, this appear disappear for intermediate fault we are able to identify.
Okay. But then how did you overcome it there at that location?
That is for trial purpose we are tried, but getting successful reports, sir. I saw
you are getting successful report.
Yes, sir.
So possibly you can make a recommendation.
Yes, sir.
Try it at 2-3 more stations, because
Yes,
this is an interesting concept.
Yes, sir.
Because the one thing is the ELD getting triggered for a fault. The next is localizing the fault. I think localizing the fault is a bigger challenge in ELDs.
Yes, sir.
Once they're operational, of course, once you make an ELD operational, then the bigger problem is that. And this is a fairly innovative method by which you are actually localizing it using some other relay contacts and using the equipments in conjunction with the data logger to get hold of, to localize it. I think this is an interesting idea which you can build upon.
Yes, sir.
That's good work. Congratulations.
Yes, sir. We have tried not only that point, sir. We tried at the signaling circuit also, sir. AC 1 time and external supply also, sir.
Absolutely. I mean, this can be further extended to the other functions also.
Yes, sir.
possibly LC gates, possibly the other functions of signaling also.
Yes.
More importantly, the less your EKTs which you're using for interlocking of your siding points, which are normally neglected locations. Okay. Okay. Right. Thank you.
Thank you.
Thank you, Suresh, for giving informative presentation on fault analysis and failure prediction through data log.
Yes, sir. Thank you to Senior DSP Madurai to give this opportunity and DSP Madurai for valuable guidance and thanks to Ananda. Thank you, sir.
Sir, we have come to the end of the session. Shall I conclude it, sir? PCST, sir.
Conclude.
I would
now,
like to
now we have to decide next month TC.
Next month, who is going to handle? Which division will handle next month? Trichy. I think Trichy should handle next month. Over. Finalized.
Yes, sir.
Okay.
You're not responding. It's accepted.
Yes, sir. Yes, sir. I'm responding, sir.
Right. Not responding is Maunam Sammadam. Accepted.
Sir. Yes, sir. Yes, sir.
Right. Trichy will handle next month. Okay. Next month, who is left over?
Palghat.
Right. Trichy will be followed by Palghat. Okay. Salem will give him some time to settle. Okay. Trichy will be followed by Palghat. Okay. Right. So now you people can conclude.
I would like
September 24th, sir. Next VC. IRST next chapter. September 24th.
Third Thursday.
Third week, no?
No, not September 24th.
17th.
Third
17th.
Thursday.
17th. September 17th, sir.
September 17th. That's all. Okay. September 17th. Only thing, Mahinder, you just send the YouTube link one day in advance. We want to publish it among the retired officials also.
Yes, sir.
One day in advance YouTube link. So video conference will be limited to inside Southern Railway people. YouTube link will be sent to all throughout India in every group. CST group, CC group, CST planning group, and retired officers group will all go. Okay. So then entire India will be watching you.
Yes, sir.
The quality also has to improve. If it is required, you can get one moderator nominated also among the Southern Railway. Okay.
Yes, sir.
One person will handle. Morning CC will handle. Afternoon CSC will handle. Over. Okay.
Yes, sir.
Probably, sir, one of the last time also we told, sir, one of the innovations should be
one should be innovation. Okay.
Yes, sir.
One should be innovation.
Other divisions have done innovation on the Gangekondan solar, the IPS signaling. They shot all the protected both sides media diverse done. So not explained, but similar like that. One of the innovations they can discuss.
Right. Then what we'll do is, let us decide, since a big group is there, that there are 20 block section where IBS is there, second fiber is there on the other side of the track. Everywhere, let us, before the next IRSC meeting, let us look for putting one more, that is, short haul production should be done similar to what is done in, one is Gangekondan, second one is there is Salem, Omanur, whatever is the technology which is done. People can study it and put through in all 20 block sections, and somebody can present the paper. Okay.
Sir, we are
All
having
20 block sections, let us complete in this month, and somebody can present the paper on this shuttle. That is high availability shuttle STMs, shuttle SGH network introduced in Southern Railway. That's all. Okay. These 20 block sections, whatever cable cut is there, short haul also will not get cut. Even if protection is not there through the other path, short haul will not have any interruption. Okay.
At present, sir, I was speaking, sir.
Yes.
Sir, we got a 17 IBS work sanction now, and we are having around 32, 33 IBS up and down. If you sometimes you take it, around 38 are there. Out of which four works we are doing MS DAC, including Ichpaturi, fifth work. There only we are having this MS DAC and both sides OFC cable. Otherwise, there is no OFC cable, even normal purpose itself, at present for the IBS. If you take any IBS, we are having a pure quad cable even for signaling itself. First, we have to convert.
Rao, I accept it. Not all places. There are 20 block sections where both sides are available as on date. Both side fiber is available in 20 block sections. Let us locate the 20 block sections, introduce only in these 20.
No, sir, that figures I don't know, sir. I was just not joined. Who has put
Not there, sir. Only 5 or 6 only. What recently
not
done
two,
only.
not even a single one. Not why 5? Not even a single one. Now I am doing 4.
No, no. What is already
One
done
work
only you are
completed, sir.
talking.
Ichpatur, Gangagondan. Now we will do it, sir. Now that all the 17 IBs we got sanctioned now only. So estimate is not that returned. Yesterday also we met PFA.
No, you locate where it is available. It will be available. You locate where it is
No, sir,
available. Random division, it should be available.
I'll send you the data now itself. It's readily available, sir.
See,
I'll send you WhatsApp data fully available, sir, with me.
Trivandrum, it should be available. You just locate. You locate, it will be available. Okay.
No,
Sir, one more thing also, sir, regarding Vital Rao.
No, please carry on, sir. If you want, I'll send one data sheet available, which we have sent to board for umbrella work sanction and got sanctioned also is readily available. We have taken the full data, sir, full IBS data.
No, sorry, telling what already done, finished work. That you change it.
No,
yes,
finished work. Normalizer Rao is thinking of only where IBS is available. Right now, even without IBS, Trivandrum division has laid cable on the other side of the track. You just look at there are 20 block sections which are having both sides. Let us look at implementing the high availability short run. Even if 20 are not there, 5 are there, let us implement it and complete until over. No issues. That should be presented as an innovative idea.
Yes, sir. In that way, we got one work, as you told correctly, sir. Where it is not available, we are put a signaling cable in Trivandrum division. Work is going on, sir, currently. There we can do it.
Okay, wherever it is available. Okay.
Yes, sir.
Next meeting, I thought of one paper required from project, sir. Actually, what happened, sir? GC work, lot of changes has come. Latest GC. And everybody is started putting their own, some fellow updated, some fellow not updated. On standard there. I think project Rao was attended.
तुम्ही ज्या व्यक्तीशी बोलत आहात त्यांनी तुमच्या कॉलला होल्डवर ठेवला आहे.
Yes, sir. This is a very good idea, sir. One paper we can finalize now, sir. GCC by project, sir.
आप जिस व्यक्ति से बात कर रहे हैं उसने आपकी कॉल को होल्ड पर रखा
Sir, thank you,
है.
sir.
कृपया लाइन पर बने रहें.
Sir, actually, sir.
तुम्ही ज्या व्यक्तीशी
It has become call-in user 7.
कॉलला होल्डवर
So
ठेवला
somebody
आहे.
should Sandeep remove call-in user 7. Correct. Okay.
Sir, what is happening? We have, of course, CST project is also of the same idea last some 3 months back. We have reviewed all the tender document, particularly some of the divisions we don't want to name it. They are using still very old. Very old tender booklets where it is not covering even GCC changes itself. And not even writing what are the ACS and advanced correction slips and all. Apart from that, there are a lot of editions are there. Swami Kalyan, then a lot of LOLCs, then DPR. So many other things are also available. Apart from changes in the GCC. For example, one small word they will attach 30%, 60%, 40% each, like the each work. So those things and all will give you a lot of problems while finalizing the tender if somebody catches us. So these changes and all, of course, everything is now rightly covered in the GCC 2020 September. This 2020 now what they have released it. Apart from that, book is already standardized by project. That book can be utilized, let's say, for the EA work or any other work, any civil work.
No, only thing if we are standardized, let us communicate it with the letter as a policy to all the divisions.
No, sir.
That is what we
Sir,
have not done.
what I suggest, sir, is CST planning. Basically, the tenders aspect and is dealt by CST planning and CSE 2. Let us standardize it and indicate from the headquarters itself. In fact, informally, in case VNM has noticed some issues with some of the divisions tenders or some of the unit tenders, we can informally bring it to our notice.
Yeah,
also.
I told, sir.
Because
Time
this
to
is
time
important to set right.
So, Mahinder has got a second paper also ready. The standardization of tender booklet, one more also can be there next month. Okay.
Sir, that
So
GC
two
and
papers
the
are
tender
ready today.
together we can make one paper, sir.
Okay.
Project can give a GC on the
One paper by project and the standardization of tender booklet. And then immediately after that policy will be issued. Okay. On the day the presentation is over, same day the covering letter will be signed and it will be issued. Okay. Any alteration which is coming on the discussion, the policy letter can be issued. Or no, like this, we'll have to bring in more innovations. Okay. Good.
Yes, sir. Yes, sir. Actually, this will give a lot of benefit to divisions and units, sir. Because we are actually every time while floating the tender, struggling to finalize the conditions and these things. Once it is systemized, means we can easily float the tenders.
Right. Okay.
Thank you, sir.
Go ahead. That is good. Right now, two papers are finalized. Mahinder should chase with the people, whoever is to present, and then get it done. Okay. And remaining,
Yes, sir. Yes, sir.
You decide it very quickly, another next 10 days, and then let us look for rehearsal being seen by you. You or one of your fellow. Rehearsal should be seen before presenting it in the forum. Okay, because next time I am going to give wide publicity. Around 200, 300 people will be witnessing on YouTube. Okay.
Yes, sir.
So good.
Moderator missing, sir. Actually, this year also, here today, moderator should have been sorted out. Problem then and that should be addressed.
No. Moderator is decided. Morning will be communication subject. CCE will be the moderator. Afternoon will be signaling subject. CSE will be the moderator. Very simple. Okay, our local seminar. When we go for international type, then we will take from retirement. Okay.
Moderator is the monitoring GC, and then some issues are there. You have to talk to the speaker, then sort it out immediately. That kind of thing.
Oh, that is what CCE will do for communication subject and CSE will do for signaling subjects. Okay. That is the best. Okay, Mahinder, note all these things.
Noted, sir.
You make the draft invitation quickly and then send it in the group. This is a draft invitation, then all the comments will be coming. Okay. Now, most of the decisions are made. Another 3 more subjects and 2 should be from the firm, one or two from innovation. Like that you make IRSTE. Okay.
Yes, sir.
Right? Then come on, Suman.
We'll conclude, sir.
You can give finishing touch. Who is going to give vote of thanks?
I'll complete, sir.
Right. Okay. Go ahead.
I would like to thank PCSD sir for giving this opportunity to Madurai Division for organizing this webinar. I thank all the HODs and other officers from headquarters and divisions, supervisors for participating in this webinar, sparing their valuable time. I thank all the speakers from Madurai Division and industry for giving the informative presentations and making this webinar successful. Thank you.
Thank you, Suman.
Thank you, Suman. All the best for all of you. Thank you. We'll meet again on 17th, 16th, 15th. No, 17th. On IRSTE, 17th September we'll meet. Okay, right.
Thanks.
Well done, Suman. Keep it up. A lot of local papers. It is very quality paper. Good. Keep it up.
Yes, sir. 4 papers from division, sir.
Good, good.
We're impressed with the AI and the design modification and all is really good. Good work. Very nice.
Thank you.
Thank you. We'll sign off. Okay. Thank you.
Thank you, sir.